Hi guys, welcome to this section. We're going to be producing an animated lamp. I'm really excited because this is the first time we're actually going to bring our models to life. So, what are we going to do first of all?
Well, Mikey's going to start you modelling a basic bit of the lamp, but before you go on and get too detailed on your model, we're going to very quickly start animating. And before you get too excited with the animation, we're going to start rendering, and then we're going to go to modelling, and then animating, and then rendering. And we're going to keep going around that loop so that, for example, you don't model yourself a lamp that can't move right because it kind of collides with itself. And you make sure that you put the correct materials on the lamp so that it renders properly, because rendering is going to be a little different this time because they're going to be using what, Mikey?
The Cycles render engine. So the Cycles render engine is very computationally heavy. So that means it's going to take tens of minutes to do a render. Now it's very important that we set your computer up so that it's using the right settings, otherwise it can take twice, 3 times longer than it needs to be. There's no quality difference when you do that, it's just your time is very precious and we don't want to sit there waiting for our computer to just heat up unnecessarily. And after we've finished introducing the Cycles render engine,
well, then we're going to go on to rigging. So rigging is the way that you're going to use Blender's very powerful tools to constrain the way that your model moves so that you actually give it an invisible skeleton on the inside of the model. And Blender will do some fantastic calculations for you called inverse kinematics, which is going to allow you to be able to move the end of the lamp, and it will work out what has to happen to all the joints upstream of that in order to produce that motion. So that's super useful, super powerful, and will set you up beautifully for future animation and rigging that we're going to be doing with bunnies and things. So, Mikey, once they have done the rigging, what do we do next?
Well, you've touched on it just there. We're going to move on and do some basic animation. We're going to cover some of the principles of animation and get that lamp moving, actually bringing it to life. So, without further ado, let's hop straight on over into Blender. Welcome to Being Lean. In this section, we are going to do many iterations through our model to the very end, even though the lamp won't be built fully on many occasions. Later on, rendering times, just to let you know, are likely to be longer than the last section, and we'll go into more detail in that in a moment. And we'll be making and testing the lamp as we go to make sure it's lean. We'll go through all the processes one by one. So I'd like you to think about being lean for a moment. Think about the process of construction, how it is made, rendering, what it's going to look like, and rigging and animating, how it will move. Now, we haven't covered rigging and animating yet, but just think about what constraints might you come across when you start moving your object rather than just having a static one. What problems can you envisage happening? I'd like you to grab a pen and paper and just think about that now. Write down a couple of questions that you think would be good to ask. So pause the video now and give that a go. Okay guys, welcome back. Let's go through a couple of questions that I thought about during this process of thinking lean. So what happens if the lamp cannot move because something is in the wrong place or is obstructing that movement? So if you've gone ahead and made the entire lamp before actually testing this out, you could have a much bigger task or even have to start again. And this lamp is going to be a very basic mechanical interaction. You could only imagine the length of time it may take you to recreate something that you would have spotted the problem immediately going through multiple iterations. So another question that I thought about was what happens if the lamp looks wrong or the lighting is incorrect? Now this isn't such a big problem with just a couple of materials in the scene that we'll be working on, but without checking as you're going, whilst we can make the changes rather quickly, you'll be wasting a lot of yours and your computer's energy. And why is that? Because rendering takes time, and I can't stress enough, sometimes a lot of time. And we'll go into more details later on in this section of how we can cut down that render time and the differences you're going to experience. Okay guys, remember to think lean, and I will see you in the next lecture. Welcome to Cycles versus Blender Render. In this video, we're going to go over how Blender Render is generally quick and you get a reasonable result quickly. It's as simple as that, and it uses only your CPU. That's a central processing unit in your computer. Now, Cycles itself is a physical based renderer and is accurate, but it does take longer. It is designed for GPUs, which is a graphics card essentially, but runs fine on CPUs as well. And we'll go in later on how to configure these to be better and render a little more quickly. So why are we using Cycles? Well, we are using Cycles since we are modelling a lamp. It's a light. It's a great time to introduce you guys to Cycles. The two are not cross-compatible, okay? So there's no real switching between the two and expecting what you've done in one to come across to the other. That is important to know at this stage. So you can use other renderers too if you have access to them, but we won't be covering these in detail. Some of the supported renders we can have a look at if we quickly hop over to the Blender website. So here we are on the Blender website. If we go to, I believe it's under download and external renderers, we can see there's a list of other renderers that do work directly with Blender themselves. Things like V-Ray and Octane also work, but they're not listed on this list at the moment. So there we go. There's a series of... I'm going to stop scrolling up and down randomly. There's a series of external renders that if you already have access to, you may want to use. They all have their own pluses and minuses as well, and that's always worth bearing in mind. So none of those are absolutely perfect. So render time differences, this is an important consideration. I will be showing you in a few moments 3 clips of a 4-second bowling ball animation that I mocked up a while ago, a couple of weeks ago now. The Blender render itself came to only 2 minutes for that 4-second clip. Now that's quite a long time to wait for 4 seconds, but at I think it was 30 frames a second, it was actually doing 120 renders in that time. A basic Cycles render, well, that took 15 minutes, and a thorough Cycles render took 4 hours. So you can see immediately how being lean with all of this will help massively, especially if you're doing a thorough render towards the end. You don't want to spend 4 hours only to find something wasn't working properly. It would be better to do a basic Cycles render at some point rather than going for the full one, and then when you're happy, bumping it up and doing the full one. So I quickly show you that video now. Here we have Blender render, and as you can see, it's a relatively good mock-up straight away. Skipping straight into Cycles, a low pass there, we get a relatively grainy and horrible result. So here's a reminder of the Blender render. And then if we skip straight over into Cycles again, but this time spending a lot more time on the render, we get a very polished model. So what's the solution here? Well, neither really. The Blender render is great for getting stuff out quickly. That whole scene, it was only 4 seconds long, took about 2 minutes to render, something like that. The Cycles, the very basic grainy one, took almost 15 minutes to render. The Blender render again, back down to 2 minutes, and that really polished one, we can see the end frame here of it. Well, that takes a silly amount of time. That took nearly 4 hours. Now, is that worth it? Probably not in this case. Now, the main thing that's going to determine your render speed is your machine specs. So let's have a look at the CPU at the moment. Now, just like graphics cards, there are going to be a lot of different machine specifications. They're going to vary massively across every one of you guys taking the course here. The simple rule is the more cores you have and the higher the frequency of your CPU, the better. So if you've got an 8-core 4 GHz processor, it's going to be faster than a dual-core 3 GHz processor. Simple as that. You're unlikely to hit any memory limits when using CPU rendering, because if your system runs out of memory, it often goes on to virtual memory, but we won't delve into the details of that at the moment. It is important at this point to know that you cannot use CPU and GPU rendering at the same time in the same instance of Blender. So your machine specs again, but this time focus on the graphics card. So NVIDIA cards, any that support what they call CUDA, which any modern NVIDIA card is going to do. ATI AMD cards, the support has started in Blender 2.75, but it's not complete. And you may have memory issues if you're using a graphics card, a GPU. And the simple reason for that is some cards just don't have as much RAM as your computer would. A lot of cards may have 1 or 2 gigabytes, and you may be sat with a computer that's only got 1 or 2, but it can switch over to the virtual memory. However, if it runs out of memory on your graphics card, that's it. It can't do anything. It's just run out of memory and will fail. If in doubt, or you are having trouble, remember you can switch to CPU rendering at any point. So that concludes this round of Cycles versus Blender Render. Now there's no reason to not use either one of these. It all depends on the application you're going to be using it for. As they are interchangeable, not as in switchable between one another, but you can use a Blender Render to work out a scene's animation quickly or mock it up really quickly, get it out there to the person you're working with or even yourself to make sure that it is what you want, before then going back and manipulating the same meshes using Cycles to make a much more realistic render. You can do a mix of them both. In this section we are using Cycles, and in the next few lectures we'll get Blender set up so that it can use Cycles well, and we'll also compare CPU versus GPU for your particular machine so you know which one is quicker. However, that's it for now, and I will see you in the next lecture. Let's talk briefly about dedicated graphics cards. A quick note for you, Cycles runs with AMD ATI cards and Nvidia cards. It works better using CUDA at this moment in time, which is an Nvidia only system. Now, either way, I'd like you to make sure you've installed the latest drivers for your graphics card, for your GPU. If you do not have a dedicated Nvidia graphics card, then you can skip the next few lectures because you're either going to be using your dedicated AMD ATI card or you're going to be using your CPU for the rendering. And the next few lectures are all about setting up CUDA on a Windows and a Mac computer. Welcome to installing CUDA on Windows. Now, in this video, this is a lecture for Windows machines. Please skip to the next lecture for the Mac setup. It's also only if you've got a dedicated Nvidia card. So we're going to show you how to check your driver version and make sure that you have the latest version of Nvidia's drivers on your computer. There's no real activations of CUDA itself, just 2 requirements. A, you've got up-to-date drivers, and B, you have a card capable of CUDA 2.0 and onwards. So let's hop into Windows and check out our version of Nvidia's drivers. So here we are over in Windows. Now there's a couple of ways of checking the driver that you currently have installed for your Nvidia card. If you have done a full installation of Nvidia before, in your task area down here, you can go up and select the Nvidia settings. When you go into Nvidia settings, if you look at the system information, which is in the lower left or under help and system information, it will tell us the driver version that we have, which is 3.32.28. Now, I know that is out of date because I've just installed this version of Windows on my computer. So I know that's massively out of date. That's just the drivers that came with my computer. So, how do we go ahead and update that? So, let's just close that down. Now, the little Nvidia icon down here, the Nvidia settings, if you left click on it, it just appears on the screen. However, if you right click, it says new updates are available. Now, if you don't have this bit of software installed, the Nvidia control panel, you'll have to go to the Nvidia website itself. So let's go there now, Nvidia, and we can also check out the version that we're currently on as well. So I know that I've got a GeForce, in fact it's remembered from when I came here last. So I've gone to the Nvidia download section of their site, and we can see here GeForce 750M is what I've got inside. If I search for that, we can see that the latest driver is 3.5582, and you can click download there and install that. Bear in mind it is a rather large update. Okay, it's challenge time. I'd like you to install the latest Nvidia drivers. Now, I must stress at this point, it is optional. So if you don't feel comfortable installing the latest Nvidia drivers onto your computer, then please don't. Remember, you can always use the ones you either have or indeed the CPU rendering if necessary. Otherwise, please go ahead and install the latest NVIDIA drivers onto your computer. Once that's complete, restart the computer and check the version of your drivers is up to date. Pause the video now and give that a go. Okay guys, welcome back. Let's hop straight over and make sure we've got the latest drivers on our machine. Okay, so let's have a look. Let's go through. I'm going to use this NVIDIA control panel area here and go to new updates that are available, and we can see that we are on 332.28 and it's 355.82. So I'm going to click on download. And lo and behold, it takes us to the appropriate site with the latest drivers. I'm going to agree and download, and it's going to whiz away in the background here. Now, you don't have to do this. Obviously, updating drivers on your computer can cause some issues. So if you're unsure about this, then you can always use your CPU for rendering in Blender. And in the next couple of lectures, we'll go through how to set up cycles and actually test it with your GPU and CPU. So you may want to check out that first. Yeah, of course, if you play games on your computer, you're going to want the latest drivers on there to have all the latest features. So we've got about 10 seconds left of this download going on here. I'm going to click to open it up when it's finished, and we'll go through the installation process. Okay, so let's go ahead and install our drivers. So it needs to extract them first, and then it will put them onto the computer. Okay, so now the system is just being checked over for compatibility. If you've downloaded the wrong drivers, this is where it makes sure it won't install anything that would potentially ruin your computer's setup. So, of course, you'll need to agree and continue. I'd always recommend just using the Express thing, unless there's some sort of add-on, and I don't think there will be from NVIDIA, but obviously with other software, you've got to be careful if you just click Next, because you may end up with a load of rubbish on your computer. Do bear that in mind, and do only download any drivers from the NVIDIA website itself. Do not download them from some special driver update software or anything like that. If you've got something like that on your computer, you may have something malicious on there. So here we are installing the NVIDIA drivers. We'll let that go through. Don't be alarmed if your screen, like it does now, goes blank and then comes back again. I will just check that I am still recording at this point in time. Yep, I am still recording. So don't be afraid. Don't worry if your screen goes blank and then comes back again. It's perfectly normal whilst it's going through the process of installing the latest graphics driver. Now, when this process has finished, you will find that it is likely that you'll need to restart your machine. So make sure you've saved any work you are currently working on before you do restart the machine, because we don't want you losing any of your stuff. There we go, so the drivers are installed. It's just got a couple of options down here. I don't want to have any of those, and I'm just going to click close. It hasn't prompted me at the moment to restart my computer. However, I'd always recommend after doing a driver update like that you do. So let's just check and make sure the latest driver has been installed. Let's clear that one down, go back to the NVIDIA control panel, open up the NVIDIA control panel, go to Help and System Information, and we can see we've now got the driver version 355.82. Brilliant! I hope you were successful with updating your graphics drivers. Take care, and I will see you soon. Welcome to installing CUDA on a Mac. In this video, we're going to show you how to download NVIDIA's CUDA drivers and install them. Now, once they're installed, checking for updates, you have to manually check for updates via the system preferences once installed. You can go to the site and download the latest version again if you notice the version number is different, of course. And then finally, you can install updates from the system preferences in future once you have them installed. So let's go and do that now. The easiest way of finding them is to type in NVIDIA CUDA drivers into Google, and let's just have a quick look here, and it looks like we've got CUDA download 7.5 here. That looks good to me, so I'm going to click that, and see what we get. We are on the NVIDIA website. Nope, that's not the right one. Let's go to the next one down. Now, there was one earlier. It might have been drivers that I searched for. I did want to warn. CUDA drivers Mac? No, it was a site that had very old drivers. So you do have to make sure you're on the NVIDIA one. So here we go. CUDA drivers Mac. NVIDIA Home, download drivers, clicking on that. Here we have the latest driver, and we can see it was released on the 19th of August this year. So that's CUDA 7.0.64. You can download that and install it to your computer. I've already done that, and if I check in the system preferences under CUDA, we can see that I have that version installed. Okay, it's challenge time. I'd like you to install the CUDA drivers on your Mac. Once again, this is optional. You do not have to do this if you do not feel comfortable. And if you have a Mac with an ATI card in it, you certainly do not want to be doing this either. So go ahead and pause the video now. Install the CUDA drivers on your Mac. Okay, welcome back, guys. Let's go ahead and do that now. You can see in front of us we've got the Mac CUDA drivers, and obviously you'll want the latest one. So you'd download that, extract the package, and install it on your Mac. Now, once you've done that, under System Preferences, you can confirm it's there because you'll have a CUDA option. And when you click on that, it gives you a couple of options. And we can see here, no newer CUDA driver is available. At the time of recording, the CUDA driver that I'm using is 7.0.64. In fact, I updated that the other day whilst just checking my GPU performance against my CPU. And I noticed there was an update, and you'll need to install the CUDA update manually. That's it for setting up CUDA on your Mac. So I will see you in the next lecture. Welcome to setting up Blender for GPU rendering. In this video, first of all, it is optional, this video. If you do not have a dedicated GPU, this lecture will not apply to you because you will not be able to follow it along fully. You may find afterwards, after you finish this lecture, that your GPU is in fact slower than your CPU at rendering. And finally, there is a reason to have your GPU using it even if it is slower. It does mean your CPU is free to do other things that may make a difference to how you're working on your computer. But let's hop straight on over into Blender. So here we have my default Blender file opened up with our lovely cube in it, and we need to go to File and User Preferences. Once you've gone to User Preferences, you will find the option that we need is under the System. Now, I'm going to make this window slightly bigger. On the left-hand side, if we go down and down, we see Compute Device is set to CUDA. If you have an ATI AMD card, that will say OpenCL, and you can switch them backwards and forwards here. And we can see the compute device here says none, but we can use the CPU. CUDA, that enables us to use our built-in graphics card, in this case an NVIDIA graphics card because it's CUDA. And once that is selected, you do have to save user preferences, otherwise it will not apply the next time you open Blender. So there we go, we've now set up Blender to utilize the graphics card when it renders. There are a few other setting changes that we'll need to make to ensure that it does use the graphics card, but we'll deal with those in the next lecture. Welcome to lowering your cycles render time. So looking at the Cycles render engine, we're going to have Cycles CPU versus GPU. It's important that you go through this process now so that you know A, which one's quicker, and B, how to set it up for your particular computer. So we're going to go through how to change your render settings. You will have to run multiple tests as we go through, and different scenes will have different characteristics depending on their complexity. But in general, all will follow a similar pattern. So let's hop back on over into Blender. So once you've saved your user preferences, we can close down the user preferences window. And I'm going to expand these windows on the left-hand side. Now the render tab is this one on the camera on the left on the properties panel. So once we've clicked that, we have a series of options. And as we scroll down, we can see there are lots of them to go through. And we're only going to go through the very basic ones at this point in time. First of all, are we in cycles? No, we're not. So let's change it, because when you're using Blender Render, the only thing you can use is your CPU. It does not use the GPU at all. So if we switch that from Blender Render to Cycles Render, we get a few other options. First of all, device, CPU or GPU compute. Depending on which one you select, will change which component Blender uses to perform the rendering. So let's change that now to GPU compute. Now the two other things we're going to pay attention to at this point in time is the dimensions of the render. Now at this point we're only focused on the resolution, and by default it's set to 1080p or high def. Now we notice there's a slider underneath that says 50%, so actually this is going to render at 50% of 1080p. So you can adjust that to get a good feel of render times. If we whack that up full from 50% to 100%, I think it's going to take about 4 times longer to do the render than if it's at 50%. And it'll be 4 times quicker if we knock that down to 25%. So let's scroll right down. There's one other option that's very important. That's under performance. If we open that up and scroll down, we have tiles. Now this is very important and will vary from card to card, graphics card to graphics card, or processor to processor. So X and Y settings. Play about with those and we'll find that some things take longer than others. So let's leave it at 6464 and render up this cube here. So let's go to render and render image. And there we go, it's rendered it out, and we can see the time at the top here is just over 1 second. Now this cube is rather basic, so we can't really do any testing with it because the render times are just going to be around 1 second whatever we pick. So what I'd like you to do is go to your section assets and open up the BMW file. So let's go and open up our section assets now. So here we go, BMW 27.blend. If you open that up, you should end up with something like this on your screen, and it's got a convenient notepad. Remember to save the file as you go. Now the person that set the scene up, we can see that they used an Intel i7 at 3.8 gigahertz, that they've got a GeForce GTX 770, and they've noted the times beneath using the GPU and CPU. Now feel free to explore around our scene. We can see how it's constructed, and we'll be doing a similar thing later on. In fact, if we zoom out, we can see that this is, these two cars are in a bowl of sorts, and there's a couple of cameras all set up. When you go to render your image up the top here with render image, or the F12, or indeed there's a button under render on the properties here. When you hit render, you can see it starts building our scene first of all, because it's much more in-depth, and then it starts rendering. Now, we're on GPU compute, and if we scroll down, the dimensions are set to 50% of 1080p, which is fine. You'll want to leave it at that for these tests. On performance, we can see that the tile size is currently set to 128 by 128. Now, I'm not going to sit here and wait for the whole thing to render it out. As we can see along the top here, it's predicting about 12 minutes in total. However, if we change these here, the X and Y, you will see that what the impact of that is. So this tile size refers to how many pixels by how many pixels we're actually rendering at. So if I cancel the render with this little cross on the info header and change this to 512 by 512, you will see that it renders a much larger area at once. So it needs to build the scene first and do some calculations. And we can see it's building up this large area here, and it's doing that all at once. Now, depending on these settings, your graphics card or CPU will render at different times. In general, these numbers are larger with graphics cards and smaller with CPU. So if I go up to where it says GPU compute and switch that to CPU, stop the current render, and then scroll back down and perhaps put this at 64 by 64, so it's slightly smaller than it was before, and hit the render key, F12, you'll notice that I have, after it's built, 1, 2, 3, 4, 5, 6, 7, 8 squares. So it's doing 8 renders at once, whereas the GPU does 1 at once. So here, that is because I have a 4-core processor that's got hyperthreading, so it acts as if it's got 8 cores, so it's able to do 8 things at once. In general, the faster CPU renders are the ones that can utilize the whole of the processor for the longest time. So if we set this whole scene up at 512 by 512, for instance, or even bigger than that, if we set it up to 1,000, well, let's do the full res. I've got those the wrong way round. I do apologise, but I want half of those. So 540 and 960, I think, if my maths is right. So that will render the whole scene at once. But instead of using all 8 cores, so let's stop the render. Instead of using all 8 cores, if I go and render this image, it will just literally use 1 core. We got the orange borders of there, and it will be rendering it only using 1 core, which is not very efficient. Okay, it's challenge time. I'd like you to get your best render time. If you haven't done already, please open up the BMW27.blend file from the asset pack. And I'd like you to perform multiple renderings with the GPU and CPU. Leave the render at 1080p at 50% and only adjust the tile size to see the effect on render times. So you will have to get a pen and paper or a spreadsheet out and record the times. Or indeed, you could record it in the little notepad that's conveniently placed in the lower right hand side of this Blender file. Now, do that several times and post your best render time, CPU or GPU, and the tile size in the discussions. Just a word to the wise before you go off and do that. If at any point you think that the time is going to be astronomically high, then I would recommend stopping the render and changing the tile size. In general, the GPUs will do better with larger tile sizes and CPUs will do better with smaller, but that will vary depending on your particular hardware. So pause the video now and give that a go. Welcome back. Let's hop over into Blender. So we left our scene like this. Now I'm not going to bore you all with rendering times at the moment. I've already gone off and done that all. So I'm going to open one of the files I've been working on, which is the BMW 27 render times. So how did I fare on my computer? So I'm just going to pull this out completely. As you can see, I've done lots and lots of tests on my computer. Now, I've gone all the way from 16 by 16 all the way up to 512 by 512. You don't have to have these particular numbers, by the way. They don't have to match. As you can see, res matched underneath. These are direct divisions of the resolution that we're rendering to. So here we have at 16 by 16, you can see it takes up to 52 minutes. I actually did not wait for that one to render. At 32 by 32, it gets down to 13 minutes, 8 minutes, 7 minutes, 7 minutes 23, 7.5, 7:23. So that looks like that one there was the fastest that the GPU was going to render. And we can see that I got it even lower when we had a res match. It's just because this happens to be closer to the ideal value for both my graphics card and this particular scene. I've made a couple more notes here when it comes to the CPU. I'm just going to pull that out so we can read my drivel. Let's just pull that down so you guys can read what it says as well. Okay, so CPU time. It looks like as you can see here, at 512, 512, well, 4 cores were utilised briefly and then a rapid drop down to 2 cores. So my max utilisation on the Mac is 800%. That's 4 cores with 4 hyper-threading units running at once. So 100% would be 1 core and 8 would be the 8 cores in total. So the longer the whole processor can be utilised, the faster the render. So here we have 8x8 was done in 4 minutes and 10 seconds. So the first thing to note here is that my CPU on this particular scene is significantly faster than the GPU. So I will probably have cycles using the CPU all the time. Now if you imagine if this was one frame that you were rendering of a, let's say, 24 frames per second, and it was just a 10-second clip. Well, what does that work out to be? If I can spell calculator, there we go. So let's just call it 4.5 minutes, because it will differ. It may get more complex or more simple as it goes, but 4.5 minutes would be a good one. Times 24, so that's how many minutes it's going to take to do 1 second. 108 minutes to do 1 second of video, of animation at this particular resolution. And that's not even 1080p. Wow, that's a lot. So let's have a look at the res matched, and as you can see, there's no real benefit from going this high. So in this case, the 8x8 CPU tiles on the CPU was 16x16 was the fastest. Now, these 3 here are actually all within the margin of error, even 64x64, I'd say. If you run these tests again and again, you'll probably find that these 3 are pretty much the same across the board. So 8x8 to 32x30 seems to be the ideal position for this. Now, on the Blender website, if I can just take you to the Blender website here, blender.org. Let's leave the page there. Okay, when we go to the downloads area, there is a series of demo files, and that's where we've got the BMW benchmark file from. And I've opened up FishyCat as well and run it on that, and the Classroom. The Classroom is incredibly intensive, so I wouldn't recommend using that one as just a quick render test. Now, the FishyCat itself, I've done that one as well, and he was the little mascot of the last version, 2.74. So if we go back into Blender and I open up my FishyCat render, we can see that a similar thing happens. So let's just pull this open here. I haven't done all of these, but as you can see on the GPU, it runs. Well, the best time there is here, in the same place it was last time, I believe. And we can see that this lot here are all within the margin of error anyway. It could quite as easily flicked between the two. Maybe not this one here, not quite sure. But CPU times, we can see that in this case, 32x32 happen to be the best. So again, these are all pretty much within margin of error. 8x8 in this case was outside of that, but these 3 here, 16x16 to 64x64, my CPU were the fastest. Now, you may not think, oh, well, that's a few seconds difference. But again, if you're doing an animation where you've got 25 renders per second, I mean, that's really the minimum you'll be working to. If you wanted 60 frames per second, oh my gosh, it's going to be a very long wait. Those few seconds add up to a huge magnitude. So after that you've done this, what I would like you to do, of course, if you haven't done already, is post your best render time to the discussions. I really want to see what type of hardware you've got, whether you've used your GPU or CPU, the tile size you've used, and how quickly you managed to render out that BMW. It would be great to see the differences in the technology. Now, it's also very important at this point, again, to highlight the render time. As you can see, 6 minutes is quite a long time to wait for something to come out. However, if we go back to the BMW we were working on, you'll notice as you start rendering the image, I'm just going to switch this to CPU, and we know from my tests that actually around 16x16 is going to produce the best results. If I now go and render this, it'll buzz away in the background. but you can see that you can get a relatively good idea of how it's going to be rendered by just zooming in. And if that wasn't good enough, that's the final thing there. Well, it's not actually the final. If you follow it through right to the end, you will spot there was a bit of compositing where a light appears as well on our scene. But there we go. You should now be able to set up Blender to render cycles as quickly as it can on your particular computer. And I will see you in the next lecture. Welcome to creating a backdrop. In this video, we're going to decide on a scale of our project that we're working on. We're going to create a basic environment for our lamp. So up until this point, we've just been making models in isolation. I suppose the chess set, the pieces had an environment to be in, which was the chessboard, but the chess set itself didn't really have, it wasn't on a table in a room, etc. So we're going to create an environment for our lamp to be in. And we're going to run through a couple of options with that, and you can pick either one. This is an artistic choice rather than an exact choice, a right or wrong. You can do whatever you like. You can even produce some steps if you like, but I'm going to keep it simple in this. So let's hop over into Blender. So in Blender, we've got our default cube here, and we don't want this. What we want to do is get rid of that, so we will go ahead and delete that from our scene. After we've removed the default cube, we'll want to add ourselves a plane. Now notice the 3D cursor is all the way up here, so I'm going to recenter that first with Shift and C. There we go. So now that the 3D cursor is there, we can add ourselves a plane. And I'm just going to scale that up so it's nice and large so we can work on it. Now, when we position our lamp and move it later on, I'm literally going to, it's going to be a 3D object, but thinking ahead, we're just going to move it along a 2D path. We're probably going to move it along the x-axis and make it hop or something along there. Haven't quite worked out the moves yet. So, that's a basic floor, but of course it's a basic floor. We don't want a basic floor, we want an environment for it to be in. So the next thing we can do is just grab this end edge over here. So hop into edit mode and select this edge here. I'm going to extrude on the Z axis and just lift that up. Now that produces a lovely corner for us to work on. Now with corners you generally get some harsh shadows. Let's quickly hop over into rendered mode and just see how that's going to come out. You can see there's well, hopefully you can see it's a bit dark around here, but there's a harsh line there. And you'll generally get shadows casting against that, and they'll usually be quite harsh. So that helps define an edge of a room. However, if you wanted it to be a bit smoother, then we can have what's almost like a studio backdrop. And a simple way of doing that is using the bevel tool. However, we're going to bevel it slightly differently. We're not just going to bevel this edge here. We're going to add another one along this x-axis. So if we select, well, if we do Control and R and pop a loop cut along here, and just shift that back ever so slightly, maybe 2 Blender units. 1, 2, we can see on the grid there. Only roughly, it doesn't matter at this stage the exact thing, and we can alter this later on. Whilst we're here, I'm going to rename our plane backdrop. Must be consistent with this. Now, when we select this edge here, we can go and bevel that with Control and B, and as you can see there, when we've put this line in here, and the reason that line's there is because the bevel will stop at that point. Excellent. So then we can add a couple of segments in. Doesn't matter how many. That's probably enough. Hop back over into object mode and set it to smooth shading. And it looks pretty smooth there. And although the render isn't that great at the moment, if we move around in rendered mode, that looks pretty smooth to me as well. Of course, if you need it higher, more geometry there, you can add a few more cuts in, but I think that's absolutely fine. So the final thing to decide here is scale that we're working on. Now, if I hop back on over into just solid render, this backdrop is infinitely scalable now. So we can select that at any time and just scale it along its x-axis and drag it out infinitely. So that's absolutely fine. But the scale of the lamp itself. Now, I think we should work with the lamp to 1 Blender unit. It's going to be a big lamp. If that was a real a real lamp. That would be approximately 1 meter across. But again, I like dealing with whole numbers, and I think one's a great starting point for it. And at the end, once we've produced it, if we wanted it to have a, let's say, 30 centimeter base rather than a meter base, then we can just scale it down by a factor of 0.3, and the whole lamp would reduce down to the appropriate size. Now, since we're not dealing with physics or anything along those that at the moment, its physicality, its size, its weight, etc., don't really matter as long as we get the impression that it's a lamp and it's animating. If we stick to the core principles that we're going to be working on, I think a base of 1 would be brilliant. So we'll go for that. And now I've got a challenge for you. Okay guys, it's challenge time. I would like you to create your stage. So go ahead and create a backdrop ready for the lamp. Now you can choose whether to have a sharp corner. You can make it a bit more funky if you want, but do keep where the lamp is moving absolutely flat. Add in a placeholder primitive, just so you can get an idea of scale within there. Just leave it as a default 1 radius for the moment. Okay, hop over into Blender, give that a go now, pause the video, and I will see you in a second. Okay guys, welcome back. Let's finish off our stage. So let's hop back over into Blender. So I'm quite happy with the stage that I already have here. I am going to make it just a little bit wider, so I am going to scale it along the x-axis by 2. So I'm just going to make it twice as wide. So I know that if we look at it from an angle, we're probably going to be okay. So let's add in our placeholder. So I'm going to add in, lots of choices here, a cylinder or a cone. So which one of these shall I go for? Eeny, meeny, miny, mo. Oh, a cone. That sounds good to me. So we're going to have to lift that out to the floor. It's got a depth of 2, so let's lift it up on the z-axis by 1. There we go. So that's definitely on the floor now. And finally, we just need to make sure that's 1 Blender unit across and not 2, because it's got a radius of 1. It's actually going to be 2 across. So we'll put a radius of 0.5. That's sorted that out. Okay, let's just see how that looks in rendered mode. Take it through to there. Excellent. It's not very good lighting at the moment. I think in the next lecture we can sort that out. So how did you guys get on? What sort of background did you go for? Share in the discussions, and I will see you in the next lecture. Welcome to Lighting with Cycles. In this video, we'll show that lamps sort of work in Blender. However, it's better to create a light source as geometry and then apply an emissive material to that object. So, let's go explore that in Blender. Okay, welcome back into Blender, and the first thing I'm going to do is change my viewport shading to rendered. Now, I often use the menu item down here so you guys can follow along, so I'm not pacing it too quickly. But just to let you know, you can also use the shortcut key whilst your cursor is in the 3D view. That is always important. Shift and Z, and that will flick in and out. Just to note, at this point, I'm only rendering to 10 samples. I don't need it super detailed at this point in time. I just need a rough idea of what's going on. It also won't tax your computer so much if you keep the sample rate low. So what we can do is, if we hop over to the outliner, we'll just check that this is the only lamp in our scene. I know it is, of course. But if I click on the little eye icon, it will disappear from the viewport shading. And just a side note here, if we go to render and render image, or hit the F12 key, we can see it here. If you go ahead and click the camera icon, it turns it off in this render. So the eye is for the 3D view, and the camera is for your final render. So let's go ahead and have a look at the lamp properties themselves. I'm just going to move the outliner. Now you'll notice whenever you resize a window, the viewport starts recalculating. So if you want to keep your computer from ramping up in volume as it gets really hot and it starts thinking, try not to resize your windows, or certainly not the viewport one, that often, especially if it's actually building up. So if we were wanting to have a little look at what it looked like with 100 samples, and I go and move that, it will reset back to 1, which would be really, really annoying. Okay, so I'm going to click on the lamp in the outliner. I could also select it in the 3D view. And I'm going to go to the lamp properties on the properties window. And we can switch here between point, sun, spot, hemi, area, etc. So there's lots of things to choose from there. Now, we can't change the intensity like we can in Blender Render as easily unless we click on this button that says Use Nodes. When we click on that, we can see that the surface changes to emission, and then we can change the color and the strength. The other thing we can do is actually make an emissive object, and that can be quite powerful as well. So you've got, I suppose, 6 options in total. You can pick any one of these or create an emissive object, and that's what we're going to do right now. I'm going to leave the lamp on at the moment so we can just have a bit of light whilst we're making our light source. So let's whiz back out and just have a quick look at our scene. Right, I'm going to create a little, like a light bulb, I suppose. So I'm going to create we're in object mode, brilliant, because it's going to be a new object. It doesn't matter, I'm going to create a UV sphere, and it doesn't need to be complicated at all. In fact, it can be the lowest possible thing, 3 and 3. Size radius of 1, well, we can adjust that in a bit and see what its effect is. I'm just going to lift it away from our cone, just leave it straight above it, and I'm going to go over to the Materials tab and create a new material and call it Light. Once we've got the light material there, we need to change the surface here to an emissive or emission. Here we go, emission. So it's just about a third of the way down. Now, once we click emission, it's going to emit this color at this strength. So it's going to emit a white light at strength 1. So let's hop straight back on over into rendered mode. And we can see we've got our spotlight. So let's turn our lamp off and let's rename our sphere light source for the moment. And just turn off the lamp. So at the moment we've got, as we can see here, we've got, I'm sticking in rendered mode and just moving around. We've got this kind of very dim light here. The strength is 1. So if we turn it up to 10, we can see it's starting to light our scene up. We turn it up to 100, that's quite bright now, and it's taking a while to render off, but that's like having a light above. Now we can have a sphere there, we can have a plane, so you can have like a window basically emitting light into the scene. Now I'm going to try and move this light source in the Y direction in our scene. I'll just move it away so you can see it updates our scene accordingly, and we've got a harsh line there, so this is important. I quite like the lighting that's coming in there as a bit of ambient lighting. I might tone it down a bit once we've actually got the lamp, but again, we're just going through the principles here, setting up our scene. In fact, we could have 2 of those lights if we wanted to. Let's just see what effect, if we select the light source, it's there, that's absolutely fine. We know it's selected in the outliner, and just scale it. So if we move it in, it gets dimmer. If we scale it up, it gets brighter. And it also changes the type of shadow that appears behind our cone, as we can see there. If this is very big, it might get a bit too bright for our scene, but we can see that it's, yes, that is far too bright. We can see that it's starting, the shadow behind is starting to be a bit more blurry. If we make that really, really small, as if it was a little speck on, we're going to have to turn the strength up at this point to even make an effect on our scene. Wow, we're at 10,000. We can see that the shadow behind here is much more sharper and defined. So depending on how large your source is, just like in real life, if you've got a large light in front of you, it's going to make the shadows behind you much softer than if you had a tiny light in front of you. That will create a much harsher light, but I quite like that, so that's worked out really well. So what else can we do? Well, we can have different shapes of light, etc. And we can obviously grab our light source, and I want to keep the lamps the same, so I can link duplicate here. and just move that across to over here. So now we've got two lights and we can light up our scene as if it was in an office or something along those lines. Okay guys, it's challenge time. I'd like you to set up your scene lighting. Set up an object or two as a light source in our scene. Now do remember, we can and are likely to change this lighting later on once the scene gets more and more developed. It's just almost a placeholder lighting at the moment, just so you can play with the lighting. Try different sizes, different shapes. You don't have to go for a sphere. You could go for a plane and have that plane emit light. And obviously as you rotate the plane itself, it's like having a window or a skylight, depending on how you set it up. So pause the video now, give that a go. Okay guys, welcome back. Let's hop back on over into Blender and have some play about with our lighting. Okay, so back over in Blender, I don't really like the idea of these two spotlights, thinking about it. Not spotlights, but spotlights. I don't know how else to put that. These two just circles in the sky. So I'm just going to delete both of those from our scene, and it will go pitch black. But I'm not going to delete our lamp yet, because it can always be a subtle addition to our lighting. Right, so in object mode, I'm going to actually recenter the 3D cursor. And I am going to hold down the right keys so I can move about properly and add a mesh that's going to be a plane. I actually quite fancy a window open. So let's just make that a little bit larger, move that up, move it back, and then I'm going to rotate it around its x-axis. So it's a bit like that. So you can imagine that would be a very large window, but you can imagine a window just there. We can always scale it in again, depending on the effect it has on our model. So now we've got the plane selected, we just need to assign a material. Now, because I've assigned a light material and I haven't exited my animated lamp blend at the moment, I still have the light material available. Now, if I was to quit, that 0 would disappear. Anything that's got a 0 against it will disappear upon saving, quitting, and coming back. And we'll go into some more details in that later. But we can click on light, and it will assign the same thing we were working on to this plane here. Now, I'm going to switch into rendered mode, and I've got a feeling that is going to be far too bright for our scene. And I'm right. So that's because the emission level is 10,000. Let's turn that down to 100 and see what happens then. Oh, that's still too bright. So we've got a couple of options there. I'm going to just hit 1 and see how that comes out. That's a bit better, probably 5. Let's have a look at our cone. Yeah, I like that. The only thing I don't like is the cone itself doesn't have smooth shading on. So with the cone selected, I'm just going to hit smooth shading in the tool shelf. Have a quick look at that. And there's some funny stuff going around the base here. And the reason for that is it's trying to smooth shade around the base as if it didn't have a sharp edge. Now, I know this is a placeholder, but I'm just going to go in and make it look a tiny bit better in solid mode. I'm going to add an edge loop. And with that edge selected, I can't add an edge loop because it doesn't allow it when you've got a cone. So I'm going to just extrude by nothing. So I'm going to hop into rendered mode. Now that's selected, we can see it gets dark artificially around the base. And if I hit extrude by nothing and hit enter, that should create a much better roundness around there, and it has done. So there is some geometry on top of one another, but that's okay because that has defined that one edge as a sharp point. Now, there are a couple of other ways of doing that, but for this purpose, for this exercise right here, that's absolutely fine, and it looks much better because of it. So I just need to turn off the other lamp, of course. That will re-render the scene, so we've only got the one light source going on. Excellent. Let's just go to render and render our image and see how that comes out. It's lucky that the camera faces at x, y equals 0. And I'm still not happy with this sharp crease here. I've set it up so we've got a smooth curve going around there, and we've still got a crease here. So let's see if we can do something about that as well. So let's just go out of here. Oh, we need to go down here to 3D view again. Right, so let's skip over into solid. Make sure we're in object mode. I'm going to select our backdrop and make sure it is smooth shaded. So I believe it is. Hop into render. We've still got that sharp edge there. So in this case, I'm going to bevel this edge here. So let's hop into edit mode. And this will just help smooth it out just a little bit more. I'm not going to add too much geometry into it. I think we've got doubles on top of one another here. Similar thing to the bottom around here what we did want, because I've managed to create this with doubles around it, we've actually got ourselves a hard line there, and that's why it's rendering like that. So in edit mode, I've selected the entire model. I'm just going to go remove doubles, and we've removed two vertices. And if we hop back into rendered mode, I bet that's lovely and smooth now. It is perfect. It's exactly what I wanted. So occasionally, if you've got doubles, they can cause sharp edges. And they did in this case. Brilliant. Okay. How did you guys get on? I'd love to see the lighting you came up with in your scene. So please share that in the discussions. And I will see you in the next lecture. Welcome to rendering a small area. In this video, we're going to show you how to render just part of your scene. Now, this is going to be great for those with slower machines at this, or even on this basic step, and it's going to be great later on for complex scenes on any computer, because you'll often find that you don't need to render the entire thing. You just need to see how that object looks within the entire scene. Okay, so we left it like this before with it rendering our scene. And I can see that this particular scene here, up in the top left, took 7 seconds or 7.5 seconds-ish to render. And depending on what it has to do, it will take a certain amount of time to do. Now, as we can see, it's still taking several seconds, even with this low-quality render. For doing 10 samples, and this time it took 8 seconds, so it will vary depending on what it's got to do. Now, one of the things that you can do is basically draw a box around the area you wish to be rendered. Now, it's from the viewport itself. You're not actually drawing a box around anything else. So the two keys are Control and B and Control Alt and B. So Control and B will give you a border that you can draw around your object, and you can see straight away it's rendering just that small area. And if I wanted to redraw that, I'm just going to do Control B again and draw a new area. And as we can see, just the cone itself now is taking around, well, less than a second to render. Now, if we move the viewport, it's absolutely fine at the moment. The cone will pretty much stay in there when you're orbiting around it. However, if you were to move away, you can see that it's actually what you're doing is you're drawing a border as to what you want in the viewport to render. Now, if I just wanted to clear that down straight away, Control, Alt, and B will clear that selection. So it's Control and B, and you can draw a box around the area you wish to be rendered, and Control, Alt, and B will cancel that selection. Of course, if you need another area really quickly, you can go Control and B and render over there, Control and B, render over here, and Control and B and render your cone again. So there we go, really useful when working with larger projects, or if you've got a slightly slower machine. You may not have a powerful computer, and this is a great way of rendering a small bit of the scene really quickly. And later on, this will become invaluable even with those with really powerful computers, because it means you're going to be able to see high quality renders without doing the whole scene. Hope you guys find that useful. I'd like you to go away and try that now. I think that would really benefit people, especially with those with slower machines. I'm willing for it to pop up. You'll probably not see me use it at this stage, but perhaps later on. I'm quite happy with it on this machine as I get a good preview quite quickly by just looking, and that means I can skip around quite quickly as well. But for those with slower machines, as I said, this is going to prove quite invaluable. And again, it means that you're only rendering a small part of the scene and can see the rest in normal solid mode here. Okay, hope you found that useful. I will see you in the next lecture. Welcome to using curves to create geometry. So in this video, we're going to be using curves, and this makes it infinitely editable. Now that basically means because a curve is a vector object, it's not really, it has a beginning point and an end point, but it's an infinitely calculable object in our scene. It also means that our mesh, when we generate it using this method, is infinitely editable too. Now this is only going to apply to certain types of modelling, but it is incredibly powerful. Now we're going to be changing the Bezier handle type as well. We haven't done that before, but that will allow us to create sharp edges in our models and also generate a 3D object by defining these curves. So let's hop over into Blender. Okay, so over in Blender, I've opened up a brand new blend file, and I have noticed that for some reason in the past, I've saved my brand new Blender file with the 3D cursor nowhere near the center. So I'm just going to sort that out now. I'm going to center the 3D cursor. There we go. And I'm just going to go and save my startup file and go File, New, Reload startup file. Brilliant. That's been causing me a few headaches recently, and I didn't realise what I'd done. Anyway, back to the task at hand. So let's get rid of the cube that's there. So let's delete that. And we're going to need to add 2 curves to our scene. So first of all, let's add a curve that's a type circle. Over in the outliner, I know it's 1 in radius, but that's fine for this purpose. In the radius, I'm going to call this a path, because that's going to be the path at which our next curve is going to follow. So let's generate our other curve by adding another curve, but just a Bezier curve. And that's going to add it right on top, but that's okay. We're just going to shift that out of the way over here. Excellent. Now the next thing I'm going to do is I'm just going to literally rotate it by 90 degrees on the x-axis. So I'm going to rotate by 90 degrees on the x-axis, so constrained to x and 90. And the reason we're doing that will become quite apparent in a moment. In fact, I've moved it along the wrong axis here. I actually just want to move it to one side of the circle. Now I'm going to view everything from the front. So I want to be in perspective view. No, I don't. I want to be in orthographic view and looking at it from the front. So we could see our circles just here and our curve, our outline. So we'll just call that outline now. Of course, you can choose to group these together if you want to. Our curve and our outline are there, and we're going to flip around again to the front view because I've just moved away from it and zoom in a little. I'm going to hide the tool shelf and the properties pane so I can see what's going on. So we're going to introduce a new section now in Blender, and that's the data properties. So we've got all of the options along here in the properties panel, and next to the spanner is what looks like a path really, and that's the data. If we hover over it, it says object data. So we're going to hop into that and have a look at some of the options there. Now we're interested in this bevel object. So what we're going to do is select the path and select the bevel object as this curve over here, the outline. So if we select that, well, we've got something straight away. And what we've got is this outline going around our circle. Now, when we're in object mode, it doesn't matter where we put this. We can move it and it doesn't adjust our model over here at all. What's happening? Well, if we go and grab in edit mode and start doing the same thing, it does make a difference. So do bear that in mind when you're editing. Now, because it's following this path around a circle, of course, the distance between the first point and the other point here, if we go beyond that, the model itself will go through itself. So if we go and extrude this point here, you can see it's creating a nice vase-like shape, but what's happening is the geometry is passing through itself. And we don't want that to happen. However, what we can do is drag this other bit as far out as we want without that being a problem. So if we lift this area up here and just do a bit of manipulation on our model, we can make sure that the model itself is not going through itself. So if we move that in, we can now see, because there's a hole in the top, we can definitely see that it's starting to work. Now I'm going to hop back over to front view to see how it's looking. Well, that's rather good. In fact, that's kind of like a lamp, isn't it? You could just imagine the bulb sitting in the top there. That may be useful later on, of course. So, vectors. Now, these can be a bit of a tricky one to see sometimes, but when you make these handles, the bit that you move the direction of your curve around with, when you move those about, they've got different properties. And over in the tool shelf, or when you press the V key, so the area down here is under handles, or when you press the V key, you can actually change the handle type. And vector means you get a straight and flat edge. Now, there's not enough detail basically in the curves, so we can see this really working well. But if I now go to here, you see that there's a sharp edge before it curves back round again. We may need a few additional curves to make that a really defined flat edge. So that's really powerful for making no end of things. It now looks like the beginnings of a jet fighter engine or something along those lines. If I make that really pointy, what's it called? A MiG or something along those lines, and pull this handle here, pull it right down. It looks like a MiG 17 or something along those lines. Or a Lightning, a British Lightning. Yes, definitely. I'm going to pull up an image of one of those now. There you go, guys. One of those Cold War beasts, the interceptors there. Oh, there you go. I've started making the nose cone for one of those. How does that look? Pretty sweet, hey? Anyway, I've got a challenge for you guys. I would like you to create the lamp base. So go ahead now and create the lamp base using curves. Change the handle type to vector where straight edges are required, if you want any straight edges, but there is definitely going to be one, and that's where the lamp base connects to the rest of the lamp. So you're going to have a hole at the top of the base where the rest of the lamp's going to slot into, a circular hole there. So make sure that you use vectors around there. Everywhere else can just be curves. Remember to fill in the bottom of the lamp as well, so you're going to have to go across and do some measurements. We're going to be setting the base, as we know, to 1 unit across, so it's only going to be half a Blender unit that you're going to be able to work within. Okay, pause the video now and give that a go. Welcome back. Let's go and create the base of our lamp. So let's get rid of the lightning nose cone there and head over to our animated lamp. Right, so we've got our placeholder here, and I'm going to leave that in our scene for a while, simply because it's going to act as the base size, so I know it's not going too far out. I am going to turn this plane off, so it's not in the way, so if I zoom out I can still see things, and I'm simply going to hide this cone when it's not needed. But first of all, I'm going to add a curve that's a circle, and I'm going to make it a radius of, I don't think it really matters, but I'm going to set it to 0.5, and I'm going to call that the base. I seem to have caps lock on, but that's absolutely fine with me. And now I'm going to create another curve in object mode, of course, that's a Bezier curve, and I'm going to shift it to the side and rotate it. I'm going to do it here, the rotation, on the x-axis by 90 degrees during the creation, and I'm just going to shift it over to one side so I can see what's going on. It'd have also helped there. Can I undo and get back to it under the operator panel? No. So let's just recreate that really quick. Curve, Bezier, if I could do everything all at once, so add a Bezier of a radius of 0.5. I can do that straight away, so I don't have to worry about measurements. And of course, set the rotation on the x-axis by 90. Brilliant. I'm going to shift it over to one side so I can see what's going on. Hop over into orthographic and front view. I'm going to get this Bezier curve here and call it outline. And I'm just going to place my outline under the base itself. So set parent object, that's absolutely fine. So now those two things are linked together, so I've got some control over my hierarchy. I might have to start cleaning up all of that in a bit. Anyway, so let's go into here. Let's go over to the data of it, and we need to make sure we've got the base selected. We're going to set the bevel object to outline. Excellent. We can already see it's too big. So I'm going to go over here to this and simply go into edit mode. Now we're in edit mode, we can have some control over this. And I'm guessing the reason why it's too big is the distance between here and here happens to be one blender unit. So I'm going to move it straight away so I've got the right depth. I'm going to hop out of edit mode and just move it across so there's a bit more space round to the front. In fact, what we could do with here is splitting our window. So I'm going to split my window and hide the tool shelf, hide these properties over here. We're not going to hide them, I'm just going to push them as far away. Again, you may not have such a problem if you've got a larger monitor. I'm a bit constrained on space so you guys can see, and I'm going to hop into this curve into edit mode and move this point here in the x-axis by 0.5. Excellent. I'm going to lift this one up, and now I'm inside the cone, so I'm going to select the cone itself and press the H key to hide it away. So there we go, we've got our rough base going in. There's a couple of things that we're going to have to do here. We're going to have to make sure that it all joins up and there's a slot in the top. And of course, I'm nowhere near finished yet. So let's select these two areas here and add in a subdivide, which is going to add another area in the middle. And that'll allow us to control the shape of our curve that little bit better. Not too worried about the shape at the moment. This one here, I'm going to have to pull back. Now, I'm going to have to think of the size of the slots that the rest of the lamp's going to slot into, and whatever it is going to be doubled because we're working on the radius. So I'm going to be moving that one in the minus x-axis by, let's say, 0.1, so it's a 0.2 across, and let's see how that looks. It might not work, it might, who knows. This is all about experimentation at this point and playing with our model. So let's grab that, which we have done, and move it in the minus, so x by minus 0.1. Excellent. So if we rotate this round, we should end up with, once it updates, we should end up with a hole in the top. Come back to that in a few moments. Now we're going to have another point, so we're going to select this end one and extrude and pull it across. We saw there was a problem or a delay in its updating there. Don't worry if that happens. I do want to be in front view just in case if you're not in front view when you start doing this, you're going to end up potentially with the curve going off in the, well, in the Y plane in this case, and we don't want that. Now the position of this, we want it at, so we're going to have to open up this and make sure the local or the global, local, that's what we do want in this case. The X position is 0.5, I believe. Let's zoom back out. Yes, that's right. We're going to have to change this one here to a vector. That will flatten it out. And probably change this one here, but not both of the handles, just the bottom one, to vector. And that should bring it round so it's got a completely flat base. Now, the top here, we've also got a little bit of fiddling to do. And it's getting really tight here on my screen, so I'm just going to pull that one back across so you guys can see what's going on. So down here, we've got to move it down and in by 1. So I'm going to move it down probably, or not move it, sorry. I'm going to extrude from there downwards, and it'll have this horrible curve initially. So let's move that one downwards by about there, and we can alter the settings in here. So the x coordinate is, the local x coordinate is going to be 0.4 because that's 0.5 minus 0.1 that we did earlier. I'm going to go down by at least 0.2 in this case, so 0.2. Excellent. And then I'm going to hit V and go vector there, so that's straight. I'm going to select this bit, select just this handle here, and change that also to vector, and we've got a straight bit going down. And then finally we need to go in, so I'm going to extrude here, and it will remember this time that it is just a vector, which is great. And we're going to move it in, so the X is 0.5, the Y is 0.2, and there we go. That's perfect. I'm going to change this handle type again to vector, so it remains straight. And let's have a look at our lamp base for the moment. I don't want it that tall, by the way. It looks more like a hat at the moment than a base of our lamp. So let's hide some stuff so we can see what's going on. Right, so here, we're probably going to have to lift this up, but I don't know for the moment. Let's select all of this geometry here, all of these curves, vertices, and just pull them down. That's a bit better. And there's another point here, this one here. Let's move it about and see if we can get a slightly different shape going on. I would like a little bit of a ridge going around. I don't know why. You know, it's just oh, that's interesting. I thought I'd applied the change and I hadn't. There we go. So let's have a look around our lamp. That's looking pretty good. And we've got a hole in the top for the rest of it. Now that might be a bit big actually for the rest of the lamp. That does look rather large. So I can go to here and here. Select those two. Oh, individually, that one there and that one there, and move them in the x-axis by 0.1. Oh no, not 0.1. I think that will seal it up. And let's move them back. It's going to be half of 0.1, so move it in the x-axis by 0.05. Looks like I didn't have the right thing selected there, so let's just undo all of that. Right, that's going to move it. In fact, I'll do it live here. 0.05, yeah, that does look about right. So I'm going to undo that and move it in the x-axis by 0.05. There we go. And for some reason, it doesn't always update on here, and it's worthwhile remembering that, as that can be incredibly confusing. Oh, I've made it smaller, why hasn't it gone any smaller? It's always a good question, but it does seem to catch up the moment you move something else, which is a bit strange. I'm going to undo that change there, and there we go, it's updated. Now, I quite like the base of my lamp there. Looks pretty sweet. And of course, we're going to take it through to the final end, as we've been doing. So I'm just going to hide this. Oh, I've just made another 3D view. Lovely. So I'm going to hide that away, so we've just got one big view again. Excellent. Let's hop back into perspective mode so we get a better feeling for things. And then, well, let's render it. Let's see what it looks like when we render our image. Why is that going on? Of course. What you will find is if we change the view to camera, it has a different box selected on it. And of course, when we click render, that's what it does. So if we go Control Alt and B and clear that, we see the whole thing will render. And if we go to rendered image, and of course it's rendering our cone. Now, why is it rendering our cone? Over in the outliner, we have our camera here, which is what we're looking for, and beneath we have our cone. Now, it's not visible in the 3D viewport, but it is visible in rendering. So if we turn that off and go back to rendering the image, there we go. We can see our model much better. Of course, this is too far out, so we can adjust our camera, etc. But we don't want to do that at the moment. For the moment, we literally want to go back to the 3D view. Of course, we need to turn on our plane so we can see some stuff. Excellent. And then we can move around. And this scene, because it's now more complex, I'm just going to let it run out now to see how long it's taking. Now we've got some much more geometry in it than just the simple cone we had before. It looks like it's going to take around exactly 14 seconds, 15 and a half seconds it takes to do that basic render. Of course, if we draw that box around it, what we were talking about earlier, it's going to take considerably less time, 3 seconds. So there's a great benefit, even when you're on a reasonably fast computer, to rendering it in that manner. Brilliant. How did you guys get on? I'd love to see your lamp-based designs and how you managed to create it with the Bezier curves there. Please share in the discussions, and I will see you in the next lecture. Welcome to creating geometry from a curve. In this video, we're going to refresh our knowledge on this. We first covered this back in the bowling pin when we created the bowling pin from a curve itself. So we'll be converting our curve object to a mesh object. Once we've done that, we can then perform mesh operations on it, and that will become clearer as we go forward. We will choose whether to delete the original curve data if we want to. That's entirely up to you whether you do that or not, but in the challenge ahead, we'll probably be keeping it just for reference if nothing else. It's good to have all the data ready there. So let's hop straight on over into Blender. Right, so back over in Blender, I've just reopened my file from working on it earlier, and it appears my base has gone missing, but fear not. The first thing I'm just going to do is get rid of this red border, which is a bit of a distraction at the moment. I'll get rid of that with Control-Alt and B. And then let's just move around. It looks like we were looking at it from the camera view a moment ago. And, well, we've got another border now. That does happen, so I will do Control-Alt and B again to get rid of that. So the camera has a separate border to your main viewport itself. So now we're here, we still can't see our model, and the reason for that is over on the base curve object over here, the Bezier circle, if we click on that, it just comes back again. So it's definitely there, no panics. Phew, didn't want to have to recreate that. So we just need to convert this now to a mesh object, and we've done that before with the pin when we converted it to a mesh object. And just to remind you, we need to, because I keep mentioning the word object, of course, because it's an object operation, so we're going to have to be in object mode. So I'm going to switch over now, click on object mode, and immediately I'm going to go to object, towards the top, convert to a mesh. So we're converting to a mesh from a curve. There are other things you can convert to as well, but we just want this one here. You could also use the shortcut Alt and C. Now, sometimes you may want to preserve your data. And if we go into the tool shelf before doing anything else and ask to keep the original, it can cause some problems. If we do keep original, it disappears and we end up with a mesh object here that's just a circle, which isn't what we want. So if I now go to the undo history and just go back to toggle edit mode, so just before we did the conversion, so we see we've got curve objects again, and I do the same thing again. I'm just going to use the shortcut key this time, Alt and C, and create a mesh from it. We can see that there, and this time we actually seem to get our mesh object. Now, it's a little bit of a quirk with Blender, but if you don't do it in that order, you end up losing your mesh object and just having a circle defined, which isn't too great. So now that we've got that, I've got a little challenge for you guys. It's just a bit of organisation. I would like you to convert the base into a mesh object. Now, if you've been following along, you'd have already done this, hopefully successfully. I am going to, in the challenge, just reset my model itself and go through it again with you as well. So convert the base into a mesh object, name the new object appropriately, and remember to keep the curve data and make it a child of the new geometry, so it's just nested underneath there. Pause the video now and give that a go. Welcome back. Let's hop straight back into Blender. So this is where we got to before, and what I want to do is just run through the process once more. So I'm just going to revert my file back to where it was before. I'm going to just hide these two red borders. Let's zoom into this area. I'm going to go to the Bezier circle. Excellent. So we've got the object selected. I'm going to hop into object mode. I'm going to go Alt and C to convert that to a mesh. Now, of course, we need the operator panel open, and I'm going to click Keep Original, and of course that means everything disappears, which is very, very irritating. However, if we literally go to our undo history and go back one, and do exactly the same thing, again, we manage to keep both. So Alt and C, convert to a mesh. We've now got both our base, curves, the defining curves themselves, and we've also got our base mesh in the outliner. So the final thing to do here is just name these things appropriately. So I'm going to call this base curve, and I will call this one here base outline curve. I think that's an appropriate name to call it. And finally, I'm going to nest this under the mesh object itself, just so it keeps it nice and tidy on our hierarchy here. We'll probably do a bit more tidying later on. I'm just going to call this lamp base, I think. Lamp base. It's a very descriptive name for it, and we will hop now into edit mode on the lamp base itself and make sure that we can select edges and faces, which we can do. Brilliant. That's all done. Feel free to share your progress thus far in the discussions, and I will see you in the next lecture. Welcome to Altering Curve Resolution. In this video, we're going to be culling unnecessary geometry. Now, we've kept the curve data itself, so we actually have two options in this case. We can recreate our mesh object from those curves, or we can fiddle about with the geometry itself. Now, this is a prime example of when we've produced something that's basically too high poly, and there are a couple of ways of going about it. Now, of course, if you've managed to create it perfectly the first time round, great, that is absolutely brilliant, well done. However, if you're a mere mortal like me and the rest of us, then occasionally you will end up making something that doesn't quite fit what you wanted in the first place, and you'll have to go back and rework it. In fact, in this section, we do that a few times once we've explored the way to go. So that's absolutely fine. That's part of the fun of learning and moving about within Blender. So, which path to take? Well, both are okay. It does depend on the stage of construction you're at, and we're right at the beginning this time. And in fact, we'll be altering the curve resolution and the mesh itself to tidy it up. And of course, after we've done that, we're going to tidy up the rest of the geometry as well, just to make it a little bit easier to work with. So, let's hop straight on over into Blender. Right, so looking at the base that we've currently created, as you can probably see, there's an awful lot of faces here. In fact, there's, in my opinion, far too much detail in this model. I mean, it's absolutely fine as the model goes, but if we, in any mesh object that you have, if you hop over into edit mode, we can actually see the number of triangles that it is, and it's 4,700 just in the base, and I think that's a little over the top, especially as we can employ other techniques later to smooth it out if necessary. Now, we have a couple of options in which to do this, basically. And we're going to, first of all, modify the curve that we've done and recreate our lamp base. So the first thing we'll need to do here is go and alter the curves. Now, first of all, I'm going to unchild them by clicking on the icon. That's important, not the name, but the icon itself. Moving to the left, and we see it there, it says drop to clear parent, and I'm just going to do that there. So now that's removed from our mesh itself, I'm just going to hide the mesh for the moment, bring it out of the view by clicking on this eye just here. And of course, we can't hide that until we're not editing it. So let's go back into object mode and just hide the lamp base. And of course, nothing's changed here because we've still got our curve-based object just here. So let's go to the curve outline, which is this one over on the left-hand side. I'm just going to widen my view here, turn off the tool shelf, probably bring this in just a little, not completely, but just a little. There we go. So in the curve properties, this data section here that we've been working on before, we can change this resolution. So we can see it's currently set to 12, and we can see what type of effect it has. So let's tone that down a little, because this resolution actually controls how many vertices are made once this is converted into an object itself. So with one, we end up with, well, a very angular model, as you can see there. In fact, what I'm going to do at this point is turn on or rather off, smooth shading. So if we go to flat, we can actually see how things are working out. Let's go here, flat shading. That gives us a much better idea. So I needed to select the base curve at the top here before in the tool shelf, clicking flat shading. Now we can see what's really happening underneath with the underlying geometry. And let's go back to our outline curve. So as we increase that, we will see our model changing. As we can see, at a certain point, we were at 12 before, it ends up quite smooth. And as we go back again, we can get an appreciation of at which point we no longer need to go. So at the moment, it looks like 4 or 5, or maybe even 6. I'm going to go for 5 in this case, because I think it defines the shape well enough. And of course, we've got the Bezier circle as well. Now, because this has 4 points on it, and it's got a resolution of 12, that actually makes a circle of 48 segments, which is 4 times 12. Now, usually a 24 or 32 makes a good number of segments for a circle to keep it smooth when you look at it. So let's just see if we set it to 6, which would be 24. I think that might still end up looking a tiny bit jagged. So I'm going to just up that to 8, which will equal the 32, because I'm quite happy with it being 32. I know that's going to produce a nice smooth circle type shape. Brilliant, so that's now done that, and now all we need to do is change these curves once again into a mesh object. Okay guys, it's challenge time. I'd like you to lower the triangle count of the base. So we're going to lower the resolution of the curves to an appropriate amount. Now we've already done some of that in the previous explanation about lowering those, but I would like you to experiment with it, see how low you can go without losing the definition of the shape. I would like you to create a mesh object from the new lower res curves, and then finally once that mesh object is created, you're going to find that there are some faces within the hole itself. So I'd like you to remove the extra geometry from within the hole, and I recommend using bridging edge loops for that. So go pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender. Okay, so over in Blender, I'm quite happy with the resolutions that I've picked of 8 for the actual circle, the defining circle, and the Bezier curve itself. I'm happy with 5. I think that gives enough definition for us. So I'm going to click on the base curve itself and go and press Alt and C and make a mesh from the curve objects. Brilliant, we've got all that there. I'm going to keep the original, of course that will make it disappear. So we hop into the undo history, go down to where we switched into edit mode. I think that's where it was. Excellent. And repeat the task again. And this time we will keep the original, because I do want to keep those curves just in case something like this happens. I'm going to immediately set the parent object as this new one. And I'm going to call this lamp base, and I'm quite happy now with deleting the old one. In fact, we can see the difference there. One's smooth shaded, so that's not a very fair comparison. So let's turn on smooth shading. And we can see that the difference between that and that is not that much at all. Brilliant. So I'm happy to delete the lamp base, or in the process of preserving stuff, I will hide it from view and everything else that's not being rendered. And I'm going to shift it up and nestle it all the way under, it's called base curve at the moment, but this will become the new lamp base. And therefore we've not lost anything in case I want to use that again later on. Okay, so now that we've got our mesh object there, I'm going to hop on over into edit mode. And I'm quite happy with the level of detail that's here because it keeps the curves. That's absolutely fine. The base looks like it's got a few extra bits that are unnecessary, so we can remove a couple of the edge loops that are going around there. It's not going to be deformed. So let's do that first because that's going to be the easiest one to deal with. I'm going to get rid of our backdrop so we can actually see the base of our object. And I'm going to select with edge select turned on. I'm going to select these edge loops whilst holding down shift as well. Oh, selected the wrong one. sometimes happens. Let's just start again. Select that edge loop there, that one. I'm going to zoom in so I don't muck that one up. There we go. So I'm happy with that, and I'm going to have to leave actually the inside one because these stop here in a point. So I'm just going to select that one, and that one there. That's fine. So I'm going to delete the vertices there, so I want that completely gone. And now I'm going to select this edge here and this edge on the inside and go and search for bridging edge loops. I'm going to use the space bar to bring that up and bridge edge loops. There we go. So we've got a nice flat bottom going on there. There appears to be a bit of a funny bit of geometry going on. We'll have a look at that in a moment. There may be something else still turned on. Let's go and have a look. There doesn't appear to be. That's a funny artifact going on there. Let's see if there's any extra geometry. So I'm going to highlight the entire model and remove doubles just to see. Okay, that's removed 30 vertices, which is useful, especially when we're trying to lower the triangle count. I'm not quite sure what's going on there. So I've had a look at the model and it's unbelievably simple what's gone on. Well, I've still got my curve object actually visible. I thought I'd turned it off, but I obviously haven't. So let's go and do that now. If we go down here, the base outline and the base curve are still showing. That's going to confuse even me at this point. So there we go. Now we found out what's causing that. We can go in and go back to our mesh object. We should be able to see the inside. That's what I was expecting to see. And I'm literally going to fill this outside face. There we go. That's the bottom bit sorted. Now up here, we have a series of faces running around here that aren't necessary. It's a single tube. We don't need all that extra geometry because it's not deforming or changing shape around there. So let's go in, and I'm inside the model now. As you can see, I've zoomed in enough so I can see inside the model, and that's exactly where I want to be because I want to select in face select. I want to select this face loop here, this one here, this one here, and that's it. I don't want to select the top or bottom one because when I delete the vertices, it'll actually delete these faces at the top and bottom as well. So when I go X and delete the vertices, it's actually left us with this here, which is brilliant because at the top we can select that edge loop there, and then we can bridge the edge loops again. And that creates far less geometry. In fact, we're now down to only just under 800 triangles, and that's a huge drop from what we were on before.
Okay, so I can guess here that a few of you are yelling at the screen going, Mike, why haven't you just used dissolving edges to get rid of those? And you're quite right, why didn't I? That's because I'm human, unfortunately. Yes, dissolving edges in this case may have been a more efficient way of doing this particular cut down of polygons. Unfortunately, that for some reason my mind wasn't thinking about that, so I chose a different direction. It just goes to show that Blender is very versatile in the way that you approach it because there are always going to be several solutions. And you will find that as these sections get increasingly more complex, there will be more than one way to do something. So don't worry if you went around and dissolved edge loops and thought, oh, Mike didn't do it that way. Don't worry. Seriously, do not worry. You have done it correctly. I have done it correctly. You might have done it quicker than me, though. But that is a great thing to do. And whatever way you took, do share that work in the discussions so I can see how you're getting on. And tell me, how did you do it? And I will see you in the next lecture.
Welcome to using existing geometry to create new. So in this video, we're going to use an existing face to create a new face. We're going to separate that immediately, creating a new object.
And this basically allows us to match up parts of our model even when they're not exact sizes. So if you had a face that was 2 Blender units across, of course you could just create another, start with a plane. Let's say if you had a square, a top of a cube, you could have a square and just make it the exact size. That's absolutely fine. In fact, you could scale it to match the right size. But sometimes you're not going to have these nice shapes to work with or exact sizes. So in this case, we're going to use an existing face, separate it immediately, and that will automatically match it up anyway. So let's hop straight on over into Blender. So we have the base we've been working on here, and this face in the middle is the one we're going to work on. But instead of playing about with this, let's learn the techniques we need to do in a new Blender file. So I'm just going to go and open up a new file now, and we'll simply work on the default cube. So we're going to copy this face that's on top. It's relatively straightforward. You've probably already got it in your mind's eye what we're going to do. First of all, we're going to hop on over into edit mode. Then select face select and select this top face. Now there are loads of ways of duplicating that face, and all I'm going to do in this case, I don't need a linked duplicate, I just need duplicate. And if you remember, that is Shift ND will duplicate the face. Brilliant, that's now done. But immediately, straight away after going Shift and D and duplicating, I'm just going to press Enter to set it where it is. So I've not moved it left and right. If you do need to duplicate otherwise, it is under the Mesh menu, and we've got, where is it on here? Add duplicate. It's just there. Duplicate the mesh and move. That's absolutely fine. We don't get any linked duplicates whilst we're in edit mode. Now, once that's there, we need to separate it. So we've still got that face selected, so we can hit P, and we can separate by selection. And now, if we just have a look, I'm going to turn off the cube itself over here in the outliner. Let's hop on over into object mode. I'm just going to turn it off. And so that is the face that we've just copied. And the cube itself is still there. And we should, with the cube selected, we can see that it has its, let's go through here, 6 faces. Yeah, that's absolutely fine. We've not duplicated anything within the model itself. And we can look up there. There are 8 vertices around there, and it's still got 8. If we hop over here, we should have 4 vertices. If we hop into edit mode. It's because I've hidden it. I've hidden it, guys, and I've not noticed that I've hidden it. Okay, so now that that's there, we hop over to edit mode here with just that, essentially a plane on top. We've got an exact duplicate, and from that, of course, we can extrude and do things from, and that's now a completely separate model. Okay, brilliant. Let's go apply that knowledge over in our lamp base. And we're going to do that with a challenge. Okay, so I'd like you to create a stem for the lamp, using the face at the bottom of the hole, the one that I showed you a few minutes ago, and we're going to generate the new geometry and build the stem up from there. I do suggest scaling the stem in ever so slightly to create a slight gap around the top of the hole. So pause the video now and give that a go. Welcome back. Let's go complete this challenge over in Blender. So this is where we've left off, and let's hop straight on over and open up our animated lamp. And here we go, we've got the base in front of us, and it's these faces here that we want to duplicate, so this area in the middle. So I'm going to use the circle select tool to do that. I'm going to clear the selection first, so there we go. Press C for circle select, and I can just draw around. And it looks like I don't have face select selected at the moment. So again, let's clear that selection. Face select. Should have had a bit of a clue with the dots there, but C, draw around there. Brilliant. So that's all of those faces selected. Shift D will provide us with a duplicate. Once we've exited with the right mouse button from circle select. Shift D. That's produced a duplicate. Press Enter to set it in place. P to separate it. And I'm immediately going to rename it over here into stem will do for the moment. Hop on over into edit mode. Select all of those faces and we can extrude them upwards on the Z-axis. Whoop, there we go. I'm not sure how tall that is at the moment, in a bit far. That's absolutely fine. So the final thing we can do here is literally just scale it in ever so slightly. I'm not going to do it initially. I'm going to literally draw our border. So let's hop on over into object mode. Just draw a border around here and render it so we can see what's going on. In fact, we need the lights on. We've got our lights turned off at the moment. So where is it in our... Let's turn our backdrop on and the lamp on and somewhere else. Let's just minimize this here. I really ought to put all of my lighting in one area so I can find it. So I've turned the plane on, and there seems to be a bit of triangulation going on here. We can sort that out later on. Now, at the moment, if we go to this base area here, if I zoom out a little, and there, we can see that it's pretty much flush. Now, that's not going to happen in reality. So, with the stem selected, I'm just going to grab this top and literally just scale it in. Now, I'm going to be a bit silly here to show you what I want to do. In fact, we may bevel that edge on there just to make it a little neater. And we want a gap around there, but we only want a small gap. So let's scale it in by maybe 0.97. Let's just see. Yep, that's left a nice gap around there. And whilst we're talking about just beveling that edge around there so it's a little bit smoother, let's hop over to our lamp base. Pop into edit mode. I'm just going to stop the rendering so I can see what's going on. I'm going to select that edge loop round there. I'm going to bevel it. Of course, that would be silly. Only needs to be a little, perhaps something like that. Hop straight over into rendered mode, see how that looks. Much better. Brilliant. How did you guys get on? I'd love to see what you did when you got your stem put in. Did you have any challenges? Share in the discussions, and I will see you in the next lecture.
Welcome to Design and Considerations. In this video, we're going to design a rough outline for our lamp to use it as reference material, basically. We're going to make it believable as an object as well. There's no point in constructing something at this stage that's not going to work properly, not going to articulate in the right places. Now, I have chosen a simple and raw design, mainly because I want to get onto the rigging and the animating section of this section. Now remember, it can always be beautified later on, so we can go back and alter the model at any point, so that's absolutely fine. So what did I come up with? Well, I came up with this straightforward design here. It consists of a couple of major parts. I've tried to color code them so it's not too confusing looking at there. The only thing I have cheated on, so to speak, is right at the very top. I've decided to go for a ball joint at the top. Now, they're really hard to get working in the real world because they're kind of messy. There's usually a series of joints otherwise that would enable a ball joint type movement. But considering this is sort of a 3D package and we can cheat at certain points, I think we can get away with the ball joint at the top without too many people noticing that they don't usually have ball joints at the top. Okay, so it's challenge time for you guys. I would like you to design your lamp. Now feel free to use my design as a base or even just use my design, that's absolutely fine, and mock up your lamp. What do you want it to look like? Now but feel free to use pen and paper, use a whiteboard like I did. Feel free to mock it up in a CAD package if you've got one, or you could even muck about in Blender just to see how things would line up. So pause the video now and give that a go. Okay guys, welcome back. Well, you've seen my design here, so this is what I'm going to be working to. So feel free to follow along with that or use the skills we're about to go through to make your own. Please share your designs in the discussions. It would be great to see what you guys have come up with, and I will see you in the next lecture. Welcome to the introduction to armatures. In this video, you will learn about the armature object and add an armature to your model. So let's hop straight on over into Blender. Right, so over in Blender, the first thing that I'm going to do is actually just take a step away from our model for the moment so we can play with armatures by themselves, so there's nothing else cluttering up the screen. So I'm going to go File, New, and get a new file loaded. With this new Blender file, let's go ahead straight away and add in an armature. Now, an armature is an object much like our mesh object, like lamps, like cameras in our scene. So it's an object that can be manipulated. It has a center, a position, a rotation. You can scale it up and down. You can do lots with it. So let's go and add one now so we can see what it looks like. I'm going to use a Shift and A. And oh, that was lucky. It was right underneath the cursor. And I'm going to add an armature. And you can see there it says single bone.
Incidentally, that's not just luck. During my practice, this is the last thing I chose. So when you go and add something with Shift and A, and in many other places in Blender, it remembers the last place you selected. In this case, it was an armature single bone, so it appears there straight away, assuming that's the next thing you want to do as well. Nice little time-saving feature of Blender, though it can be confusing if you don't know why it's doing that.
We click that, and one of your first questions will be, I can't see it, Mike, where is it? Well, first of all, it's within that cube. I can guarantee you that. And it does say armature over in the outliner, so I know it does exist. So how do we make it so we can see it without hiding the object, especially if we're going to use these armatures to control our mesh objects? Well, let's have a look at the Properties tab over here for the armature. So we've got the little stick figure over here. Now, this gives us an option to name our armature. Now, an armature consists of a series of bones within it. In this case, we've only got one bone in one armature. And in general, you'll probably not want to have more than one armature in your particular scenes at one time for a particular object. So if you had two people in a scene, or since we're working on a lamp, two lamps in your scene, you'd have an armature per lamp itself. In fact, with a lamp, you could probably copy that armature across, duplicate it, and use it as a template armature for the other lamp, unless there were some really big differences between them. Let's go down. We've got the skeleton, we've got pose position and rest position. And then if we keep going down, we've got display. Okay, so octahedral, stick, B-bone, envelope and wire simply change how our armature looks, but we still can't see it at the moment. So put a tick in the box called X-ray. Now we can see it, and I'm going to hit the full stop on the number pad. You could go to view and do the same thing, and we can actually see our bone now through any objects that might be in the way. And that's a great way of being able to see what's going on. Obviously, when they're inside a model like that, you can't really have great control over them because you can't see what's going on. It's as simple as that. Turning on X-ray allows you to see the bones of the armature. Now, a couple of other things that you may want to turn on and off, just so you can get a bearing of what's going on. So we got names, and that'll turn on the name. It's just called bone at the moment. If we were to add another bone, that would be bone.001. And then we've got the axes themselves. Now, you're not going to see the axes come alive just at the moment, but having that on can help you understand the relationship of the global coordinates, i.e. Z being up. If we actually hopped on over into edit mode here, we can see that a Y is currently up for this bone itself. And that can be a bit confusing at first. So having the actual axes turned on will help massively, especially when we come to constraining movement. But more on that later. So in the properties window, next to the armature properties, are the bone properties. The bone itself, well, we want to name that bone. At the moment, there's only one in the scene, so it's pretty obvious which bone we're referring to. But if we were to call that bone cube, because that's the bone it's for, it's very apparent then what that bone is designed to do. So if it was part of a human, you might call it foot, finger, leg, arm, torso, whatever, head, neck, etc. So now we've named it, how do we link these two things together? Well, we want the armature itself to be the parent of the cube, or more specifically, that bone within the armature to be a parent of that cube. There are a couple of ways of doing that, but the easiest way is to select your child. So I'm going to hop back on into object mode, select the child, which is the cube, hold down shift and select the parent. Now you can get it through the object menu as well to go to parenting, or I like the shortcut keys, Control and P for parent. And we've got a load of options here, but we want to set it as a bone. There we go, we've got it set as a bone, and we notice over in the outliner the cube doesn't exist anymore. In fact, if we open it up, we can see it's now a child of the armature, which is exactly what we want it to be. And if we actually go into the cube properties itself, so under the object properties, if we scroll down a little, we can see the parent is the armature, and the bone it's linked to is the cube bone. Very useful. One final thing on bones, depending on the type of mesh you're dealing with, we're going to be dealing with a rigid mesh. Our lamp isn't going to be a bendy, floppy lamp. It's actually going to have arms that are rigid and do not flex. They just move. So if we select the bone again itself, and have a look at the properties here, you will actually want to turn off the option Deform. Otherwise, when we try and move things later on, it will actually distort our geometry rather than just move it. So I'd like you to untick that for every bone that we're going to put into our lamp going forward. Okay guys, it's challenge time. I'd like you to add an armature to the lamp. So add an armature to our lamp and make sure the armature is located at 0, 0, 0, so right in the center of our scene. Just center the 3D cursor before you add it. That's the easiest way of doing it. Call the armature lamp rig, because that's essentially what it will be becoming afterwards. Name the single bone that's generated stem, and then finally make that bone the parent of the stem mesh that we've already got, that little cylinder coming out the base. Okay, pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender. Right, now we're in our animated lamp. We just need to find the 3D cursor first of all. It's over there, it's taking a break. So I'm going to use Shift and C to recenter it. And then I'm going to press the number pad full stop there, so we can zoom straight back in. Right, now that we've recentered that, we can go ahead and add our armature. So we're in object mode, yep, I'm going to add an armature, single bone. Excellent, so that's a bit large. So at this point, I'm going to scale it down. It's much like any other object, as we've already discussed. So we've got the operator panel over here, add armature. If I reduce the radius, then it seems to be shrinking. I'm going to set it so, well, there will do for the moment. We can always alter it all later. And let's turn on X-ray so I can see where it's sitting. Excellent, that's exactly where I want it to be. So its position is now right. Let's call it lamp rig, because that is what it's going to become, lamp rig. Excellent. Now we've got the lamp rig named. We've got the one bone in there, and we need to name that bone. So with the bone selected, that's good. We can go in here and name the bone stem. We need to make the stem the child of the armature itself. Brilliant. Now the order in which you select these does matter. And then Control and P and set it to the bone. There we go. So finally, let's just make sure we're not deforming. So we're not deforming, so we can untick that in the bone properties. We've got it named stem there. I'm going to name this here lamp rig, so we know what we're talking about. Excellent. So I think that's everything done. Excellent. How did you guys get on? Please share in the discussions, and I will see you in the next lecture. Welcome to Revisiting the Mirror Modifier. In this video, you will learn how to use another object as the point of reflection. You're going to understand that it is the origin itself that acts as the point of reflection. And finally, see other objects' rotational values change the axis of reflection. So let's hop straight on over into Blender. Okay, so over in Blender, the first thing I'm just going to do, you don't have to follow me here, but I'm actually going to maximize the screen just to get a little bit more space on the screen for me. Okay, so the first thing we need to do is show you this axis of reflection. So we need an object to mirror, and I'm going to use our scene here. I'm going to just hide a couple of things. I'm going to hide the backdrop, and the camera and the lamp. So it's just the basics that are in our scene. Okay, now we've done that. If we go ahead and add a new object, it doesn't matter. Well, I want to put it over here. So I'm just going to click over here. I'm going to adjust those 3D cursor values. So let's find the location of the 3D cursor. Scroll down a little. Location, I want X and Y to be whatever they are, but oh no, I want Y to be 0 along here. I want it to sit on the X-axis itself, and the Z to also be 0. There we go. That looks much better. So we're going to create an object over here, and let's actually add a mesh object, and let's add a monkey. That's very, very big, and I'm going to scale the monkey right down. Okay, so we're going to use Suzanne here, the monkey, as basically our object that we're going to reflect in our mirror. So let's go straight ahead and add the mirror modifier. So I'm going to go to the wrench, add a modifier, and down here under generate, we've got mirror. Okay, and so currently it's reflecting in the X, Y, and Z axis, and it's reflecting about itself. Now it's actually reflecting about the origin. So if we were to center the cursor, so I'm just going to hide that render box that we placed on the screen before. There we go, it's out of the way. And I'm just going to click somewhere else, just over here. And in object mode, I'm going to go here and set origin to 3D cursor. And the moment we do that, you can see that all of the mirror modifiers axis down here, it's changed where they were. Before it was right on top, and afterwards it's here. So we can use another object as a point of reflection. So the last option here on the mirror modifier is mirror object. Now if we have a look at our lamp base, its origin is smack bang in the middle of it. And that's absolutely fine, that's what we want. So I'm going to grab Suzanne here with the mirror modifier and set the mirror object to the lamp base. There we go, excellent. It's reflected on both sides, and that's going to become very handy. The last thing to cover is how an object's reflection is also based upon this object, the mirror object down here, based upon its rotation. So sometimes you can end up with some funny stuff happening. So if I'm just going to uncouple the lamp base for the moment, so we're reflecting around the monkey's own origin, Suzanne's own origin here. If I now go to the lamp base and just rotate it 45 degrees on the y-axis, let's just say, so it's tilted like that. Now if I go back to Suzanne and mirror object, set it as the lamp base, we end up with a completely different reflection to what it was before. So you can see there how the mirror modifier can be very powerful, but it can also be confusing at times, because if you have rotated an object and then you decide to use it as a mirror object, you may, in fact, so if I go and rotate that all the way around, you may find you need another axis selected when it would have been a different one if you just use the, in this case, the object's own origin. Of course, if you wanted a monkey on either side of here, what you could always do is clear that. I'm going to center our scene with Shift and C. Oh, the plane's still in the scene. I'm going to use the number pad full stop to come back into our scene. Now the cursor's in the center, I'm going to set the origin of the monkey, which is fine, to the 3D cursor. And now it's reflecting around there. So if we wanted it on the x-axis, we've got that there. However, and we could achieve a very similar thing with the lamp base if we set it to the lamp base here. Let's go to the lamp base, etc., and rotate it in the y-axis by minus 45. There you go, you're back to the same thing. So one way of doing it is moving the origin. One is to use another object's origin, essentially. And of course, they've both got their benefits. You don't want to start using a mirror modifier and moving an origin outside if you're also going to use that origin for something else. So there are a couple of things in Blender that do use that origin, one of which is pivot points, scaling, proportional editing, physics, etc., etc. The list goes on. So sometimes you will want, if all you're doing is mirroring something and it has no other application, fine, move the origin quickly. You can always move it back again later on. Alternatively, I would use another object's origin. But again, if you go and move that object later on, say we're looking at this lamp base and it's not symmetrical, and we go and rotate it around the z-axis, well, look what happens there. That could cause some problems if you decide to rotate that round, especially if you were moving it or animating it. Other objects that were based upon this may indeed start to go a bit funny. Now, of course, you can create a mirror empty or a plane and hide it. It's entirely up to you there. There's always going to be more than one way of doing something like this. Okay, guys, it's challenge time. I would like you to build up the lamp stem and the first arm. So make the joint at the top of the stem. I'll be using a Boolean modifier and the union setting to make it one piece. Then finally use the mirror modifier for generating two arms coming out of our stem. These two arms will be a separate object. And just to give you an idea of where I'm going, of course your design might be slightly different, so you may have to modify these instructions to your model. But these are the front view and side view of the lamp that I'm going for, or that I'm going to try and go for. So we've got the stem on the screen, coming up, splitting into what I can only call a tuning fork type shape, and then finally the two arms, or actually there's only one object, and we've used the mirror modifier, and I've set the mirror modifier against the base there in order to generate the other arm. So pause the video now and give that a go. Welcome back. Let's hop straight on over into Blender. Right, so I've opened up the file as it was when we started, so we just get rid of all the Suzannes and any other changes that I've made to our scene. So the first thing I'm going to do is just hide a couple of bits and bobs that I don't want on anymore. The lamp can go, yeah. The lamp base can stay, the lamp rig can go. And the plane can go as well, because that plane is a light. In fact, I've still not moved that. I'm going to nest that under lamp, so I know it's out of the way now. Right, and got to remember, of course, to bring that back later. Anyway, to the task at hand. The first thing I'm going to do is place the 3D cursor on top of our stem and make sure that it's at 0, 0 on X and Y coordinates. Next, I'm going to add a cube to our scene. And it is in object mode. That's important at this point. Cube is far too big, so we're going to scale it in. I'm just going to do this to eye for the moment, or by eye, because I do want 2 bits either side of this. So I'm happy with that being the center gap by the looks of things. I'm going to hop into edit mode and just test. So I want it face select. Oh, I'm a bit too close. There we go. And I'm just going to extrude, thinking about this way being forward. So I'm going to extrude along the x-axis here. I'm going to extrude and just see how far that comes out. Looking at the lower corner there, about 0.3 or so. Okay, so if I type that in, 0.03 there, and here, extrude by 0.03. Excellent. Now I can scale the entire model. Ooh, not there, so everything. I'm going to scale it on the y-axis only. And we can see some artifacts happening here, and this is what can happen if you're working with a model at too small. If it was much smaller than this, it would be impossible to work with. So there we go, that's that there. So I'm going to have to find the stem. So I'm just going to select the stem actually. Go to the modifiers, add a modifier, a Boolean modifier. Oh, and we want a union between that and the cube. Okay, something weird has gone on there. Let's just do that again and make sure I've got everything selected that I want selected. So let's go into the lamp rig, which is where that's hidden, and the cube is on top. That's fine. Stem, add modifier, a Boolean, and we're going to go for a union with the cube. Okay, now that's a bit weird. Something funny's going on here. I'm going to pause the video and just see what's going on. Okay, so something weird's going on here. I'm literally going to save my file just in case there's a bug going on. And I'm going to shut down Blender. There we go. I'm going to reopen our animated lamp. Excellent. And I'm just going to try doing that again. So with the cube, a union. Okay, so I'm just going to remove the cube completely from our scene. And I'm just going to whack another cube on really quickly. So in object mode, mesh, cube, 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 scale it in. Okay, I'm now going to select this one. So a union with the cube again, and press apply. Okay, very interesting. So it seems that something was causing some sort of geometry screw up, basically, was causing the two things not to be unioned at all. So I'm just going to undo that operation. It could have been a bug in the program at some point. Crazy stuff going on there. I'm going to edit this cube before and scale it in on the x-axis to about there, I think. Excellent. And then I'm going to extrude out here by 0.03. Your numbers may be different, by the way. Don't have to copy exactly what I'm typing in here. So I'm going to extrude here by 0.03 again, because then these bits here I can extrude up into our to our tuning fork. I'm not sure on the size or anything. We can always go back and change that later. Okay, now I've done that. Select the stem, come out, select the stem, give it a union object with our cube, and click apply. So now when we hide our cube, excellent. That's exactly what I wanted it to do in the first place, and it wasn't doing it. I honestly, I do not know why. I think there was a complete bug, so I had to restart that whole bit again. So don't panic if that happens to you. And I've finally just deleted that old cube from the scene. So now we've cracked that, which should have been a very straightforward part of the video. We're going to add in our arms. So I'm going to click on this face here. So first of all, I'm going to go into edit mode on the stem. I'm going to go in face select, which I'm in. I'm going to select this face here. I'm going to use Shift and S to move our 3D cursor to the selected, and it will automatically go to the center. I'm now going to add, or come out of edit mode and add a plane. So we're going to build this arm from a plane, and let's make it a little smaller. Let's make the radius 0.03. That seems what a lot of the others seem to be at the moment. I'm going to set the let's just have a look at the axes here. I'm going to set the Y rotation to 90 degrees. And that might have flipped it the wrong way for us. I'm going to do -90. Yeah. See, the color difference there was basically I'm going to end up having to flip normals if I hadn't have done that. And let's see if I can get away with a 45-degree rotation on the x-axis as well. No, that's not going to do what I want it to do. So I'm going to add that plane again. I didn't mean to come away from it. And it was just 90 degrees, -90 on the y-axis. If I can get there, -90. Brilliant. Gonna then just rotate that around the x-axis by 45. Perfect. Gonna extrude out. So it's going to edit mode, extrude out by 0.03. And I don't need extra geometry here, so I'm not going to extrude from this point. I'm literally just going to move. And I think it's the X, no, it's going to be the Y-axis, but not like that. Another press on the Y. Oh no, is it Z then? No, it must be X. Great. So on the X-axis, but pressing X twice means that I'm going along the local axis. So finally, I don't know how long that is. So with the face still selected, I'm going to hop into orthographic mode and move around to the side. I think that can be a little bigger. So X, there we go. And of course, you can edit this to your heart's content at any point in the future as well. And there we go, that's our arm created. Now, I know that later on in this scene, I'm just going to clear that red border for the moment. I know later on in this scene, I'm likely to be animating it, and I'm going to be moving this base. So setting the mirror point for the mirror modifier to this base, I don't think would be a good idea. or any other moving part. In fact, in this case, I'm going to create an empty and use that as a reference point. So I'm going to create an empty. Which one should I choose? I'm just going to use a plain axis, and I'm going to, I wanted that to be at 0, 0, 0, and I can do that here, 0, 0, 0 in the operator panel. Perfect. And I'm going to nest that empty. I'm going to call it something first. I'm going to call it the mirror axis. And I'm going to set that as a child of the, not the stem, sorry, this plane 001, because that needs to be called lower arm. There we go. I've got caps lock on. Let me turn that off. Lower arm. There we go. So finally, we're going to add a modifier, a mirror modifier, to that arm. That being blind, there we go. Mirror modifier. I'm going to select the mirror object as the mirror axis. Oh, and I don't even have to select any other things. The x-axis is already ticked. Perfect. How did you guys get on? Please share in the discussions, and I will see you in the next lecture. Welcome to adding bones to our armature. In this video, you will learn how to add additional bones to an armature and understand that a new bone does not have to be connected to the previous one. Let's talk quickly about bone structure. There are three main components of a bone. We've got the tail or tip, a body, and a head or root. And simply put, the head or root is where the bone starts, and then you've got the body connecting it to the tail or the tip where it ends. Now, I'll be using that terminology lots as we talk about bones, so I just thought I'd explain and show you what I'm talking about. So now we've got the bone structure in our heads, let's hop straight on over into Blender. So we're at this stage in our lamp at the moment, and we've actually got some arms here. We've got our lower arms made. And if we have a look at the rig so far, we've only got, so I've just clicked the little eyeball here because I'd hidden it before. We've got just one bone in that rig. Now I'm going to do a bit of experimenting and putting lots of things in, so we're going to hop over into a new Blender file. Now once you're in a new Blender file, we're going to add an armature, so I'm going to go Shift and A and add a single bone. Oh, it looks like my keystrokes aren't showing. It looks like I can't be full screen. There we go, we're back to here and my keystrokes are showing. So we've added an armature and it's over here. I'm going to go to the armature properties and just make sure that X-ray is turned on so we can see what's going on. So we can see our bone in the scene here, and we want to go into edit mode. So I'm going to hit tab and go across to edit mode. And to add a new bone that's connected to the tail of the last bone, you literally extrude. So you can press the E key. And there's our new bone. And you can keep doing it again and again and again. Now, if for some reason you needed an extra bone in on this area here, you could then press E coming from there, and you can generate as many bones from a single point as you like, and of course you can move those around. Okay, so I'm just going to undo some of that quickly, because what you will generally want to do is just lock it to an axis. So I'm going to make up now our lamp sort of flow that we're going to do. So we've got a stem coming out there. We'll have a, well, I want to lock that to the Y axis in this case. So I'm going to go, well, everywhere except Z actually. So Shift and Z. Oh, sorry, Shift and X. And that's now on there. So we'll come back from there like that. We'll come up for the next bit and we'll have the lamp there. The little light at the top. Now, one of the things you may want to do when using bones is, well, the way that the bones are constructed defines the movement. So here, if we wanted to add in, let's say, one across for the base plate, if we wanted to make it wobble ever so slightly, rather than being linked directly to here, it wouldn't be that natural, but we could add a little bit of wobble to it. We may find that this is the wrong way around. And there's a couple of ways of flipping that round. We can go to Armature and switch direction. And you can see the shortcut key there is Alt and F. So if you ever need to switch the direction of a bone, you can do Alt and F and it will flip it round. And that's the same with all of our bones. Brilliant. And of course, if you've put the bones in the wrong order for whatever reason, you can select multiple ones and then flip the whole lot. Now, if we want to add another bone to our scene, to our armature, in fact, that's not connected directly to any of the others, there are certain circumstances where you'll want to do this, and we won't be touching on them just yet, but I just want to quickly show you. You simply position the 3D cursor where you want the new bone to be, so I'm going to put it over there, and I can just go Shift and A for add, and there you go, there's a new bone. Finally, of course, when you've got a complicated scene with several bones in it, do remember to name your bones themselves. So when we click on a bone, we can go over to the bone properties, and at the moment you can see as we click on these, this bone changes. So we've got, I've turned off X-ray, so we've got the bone at the bottom here, which is just going to be called bone, and then we've got bone 001, 02, 03, and this one's going to be 4, 5, 6, 7, etc. And they're not very descriptive. It is very important that we name them appropriately. I'm not going to name them at this point in time because I'm just about to get rid of this file, but I do suggest whenever you create a bone, you give it an appropriate name. Okay, so it's challenge time. I'd like you to add a second bone to the first one. So add another bone, making sure it is locked to the appropriate axis. Name the bone, that's very important. Position the bone's tail in line with the top of the lower arm, and then finally, parent the lower arm to the new bone. And I know that some of you are having problems with the first set of lower arms with the mirror modifier unapplied. So if you are having problems, do apply that. Also check that you have applied any transforms that you've made. If you've either edited something in object mode, its rotation or its scale, those can adversely affect the armature and movement. So make sure any of those are applied with Control and A as well. That should hopefully stave off any problems. So go ahead, pause the video now and give that a go. Okay guys, welcome back. Let's hop straight on over into Blender. So back over on our animated lamp, the first thing I need to do is just turn on the lamp rig so I can see it over there. So now we've got this in place, I'm going to not try and select it in here because I'm just going to end up selecting geometry. I'm just going to left click in the outliner on the lamp rig. I'm going to sweep right round to the left view. I'm in orthographic, which should mean that when I then hop into edit mode and extrude from there, I can bring it up and we see in the lower left, you can see the numbers going around and the change in the X coordinate is nothing. But just to make sure, I'm just going to go Shift and X. There we go, it's locked there, and I'm just going to put it into the approximate position. Now, you may notice that this looks like the hinge point or the pivot point is going to be in the wrong place, and you are right. But don't worry about that at the moment, because if we go and correct it with our current knowledge, it's going to make some funny stuff happen on the model, and we're going to deal with that in the next lecture. But now we've got that in the right place, we've got a couple of further things to do. First of all is just parenting the bone. I'm going to name the bone actually first, so I'm going to hop into the bone here. It's going to be called stem 001 because that was based on the first one, and I'm going to call this lower arm so we know what the bone is for. In fact, I've got caps lock on, which always helps. Lower arm, brilliant. So that's named. I'm then going to select the lower arm, so hop into object mode, Shift and select that, and go Control and P and parent it to the bone. So there we go, that's now all parented, and if we decide to move any of our armature, the rest of it moves with it, so we know that it's all parented. Okay, how did you guys get on? Please share in the discussions, and we'll solve this little hinge problem in the next lecture. Welcome to Pose Mode. In this video, you will be introduced to the Pose Mode. Understand that we use this mode to test our model's movement. Know that this is the best mode to be in to parent mesh objects to individual bones and to make alterations. So let's go explore this in Blender. Okay, so we've got our base, we've got our stem, and we've got our first lower arm, and we've got our two bones in place at the moment. And the first thing that we realise is that the bones are, this first one is too low down. So it may be, you may want to select the armature and go into edit mode. I mean, this was my first gut reaction when I started doing this. I'll just pull the armature all the way up to roughly the right location there. And there we go, it's done. Perfect. And when we go into object mode, our model shifts about lots. So one of the first things to make sure is that you position things correctly before you link to the bones, which I haven't done in this case. So I'm going to undo what I've just done there. Now, pose mode, I'm going to introduce you to that mode. You have to have the armature selected. And if we go where it says object mode, now we've got something in there called pose mode. And if we go to that, it allows us to grab our model and start moving it. And because it's linked, it actually controls with the rest of it. And now, of course, we will want to... Ooh, that's looking a bit funny there. I think that's just updating the mirror object. Now, we will want to constrain these later on, but at this point in time, it's just to show you that's how we can move our model about. Okay, so I'm going to come out of that for the moment. Just going to undo those changes that I made. Now, what we're going to need to do in order to reset this, because if we try moving any of these bits, it's just going to screw up our model. So we need to unparent our mesh. And we can do that very quickly in the outliner. We've got the lower arm here and the stem. If you've not got your rig, your armature expanded, you will want to do so you can see these two things. And we simply click on it and drag it to the left, and we can drop to clear parent. And we can do the same thing with the lower arm. Once we've done that, we can actually start remaking our parenting. Now, the first thing we're going to do, of course, is go back to the armature itself, go into edit mode, and just shift this one here all the way up. And as I say, I've got my 3D cursor in roughly the right place anyway, which is great. That's better luck than judgment. Now, when we use the tab key, you'll notice it goes from edit mode to pose mode. If we're in object mode, it goes from object mode to edit mode. So depending on which one you're in, the tab key will toggle you between the two. Now, if we're in pose mode, we can now select both the mesh and the bone with the shift key, one after the other, and we can see the bone is highlighted in blue. If we were doing a similar thing in object mode, the whole armature gets selected, and that doesn't give us the degree of control that we want. And it also causes your geometry to bounce about if you're unlucky enough to not have things perfectly aligned. So make sure you're in pose mode, select the object that you want to be parented, hold down shift, select the parent object, which in this case is our bone. I'm going to use Control and P, and I want to set the parent to bone. And I'm going to do the same thing with our lower arm. I'm going to shift click this top bone here, and then Control P, bone. And we can very quickly check that this is working by grabbing it and rotating it round. Yep, that's working absolutely fine there. And this one through here, if we rotate that round, it's starting to look pretty good. I've locked that to the Z-axis because that's what we'll be doing later, so it's a good representation of what's going on. Perfect. It's challenge time. I'd like you to move the stem bone's tail. So unparent the stem bone from the stem mesh, edit the stem bone and move its tail to the correct location, and then finally enter pose mode and reparent the mesh objects. Then finally, of course, you can play about with it and see how it all moves about. So pause the video now and give that a go. Okay guys, welcome back. Let's hop straight on over into Blender. So we're going to now go through the process that we've just been through, in fact, and just recap on it. So, first of all, I'm going to unparent our lower arm and our stem. I'm then going to hop into edit mode and adjust this tail piece of our stem bone. We can see it's the stem bone over here in the right hand side in the properties. And I'm going to hop over to the left view and literally move it up so it's almost on top of my 3D cursor. Perfect. Now I'm just going to whiz around and make sure that it's aligned and I've not moved it out of alignment. That looks great. Finally, I'm going to hop into object mode and then switch to pose mode. Now I can click our stem at the bottom, shift and select the lower bone here and go Control P, bone. Up here I can do the same thing, Control P, bone. And I'm now just going to check the mesh object, so I'm going to make sure I'm on the mesh properties here, or the object properties, and just go down here where with the lamp rig is the parent and we're connected to the lower arm. That's correct. We go to the stem Again, it's going to be the lamp brick that's the parent, and we're connected to the bone, which is the stem bone. Perfect. Great, guys. Please share in the discussions, and I will see you in the next lecture. Welcome to rest position and pose position. So in this video, you will understand the differences between rest position and pose position. You can see the rest position when in edit mode, and how to clear the pose back to the rest state after you've been playing with your model. So let's go over into Blender and play with our lamp. Okay, so let's talk about the pose mode and rest mode. So over in the armature properties, if we select them in the properties pane over here, we've got pose position and rest position. Now, very useful. In general, when you go into edit mode from pose mode, it will automatically flip back into your rest position. Now, the rest position is just the default position that you want your model to be in. So I'm going to create our animated lamp in this case with a rest position with the two arms, the lower and upper one, just going at 45 degrees to one another. So it looks kind of it's a rest position, it's natural rest position. That's absolutely fine. But there are some quirks that Blender will throw up. So first of all, we've got rest position and pose position that we can flick between here, and at the moment they're exactly the same. If I go down here and go to pose mode, and I just grab this, and I'm just going to rotate these two around ever so slightly. Let's put it that way. It doesn't matter in this case that it's going to look odd, just for demonstration. Now, if I hop into edit mode, something weird happens. This goes out of line. However, if we just quickly render this, you'll see that they are really still aligned with one another. I believe I've checked on two platforms now. I believe this is just a little bit of a bug in Blender itself. So there are a couple of ways of solidifying that. And what I'm going to do is simply make our lower arm have the modifier applied. That's all I'm going to do at the moment. If I need to edit this arm later on, I'll simply delete half of the mesh, the half I don't want there, and I will re-mirror it. Just clicking apply here on the modifier will set it right, and we won't end up with some weird artifacts going on. It just makes it a lot easier to manage. Okay, so back over into pose mode. Remember, you have to have the armature selected when we do this. I'm going to go over to the armature properties here. Now it's in the pose position. It will stay like that in object mode. Edit mode will flip it back to the rest position. And again, in pose mode as well, it will stay like it is in object mode. Hitting the rest position automatically sets it back to this area, but you can't move it. It's now locked in that rest position. So how do we get it back to the rest position without hitting this button? Well, there are three simple keys or key combinations that we can use. Alt and R will reset the rotation. Alt and G will reset any movement that you've done, and Alt and S will reset any sizing that you've done. So if I've got this bone selected here and I go Alt and R, it resets that to its original orientation. If I select this bone and do Alt-R, because that's all I've done, I've rotated twice, it will reset that one to its default rest position. So you can do it bone by bone if necessary. Now, I haven't got any scaling, but if I did have scaling in there as well, then Alt and S will reset it, and any movement will also be able to be reset with Alt and G. Now, if you come up with an excellent rest position by using the pose, you can apply the new pose position with Control and A. So apply the pose as a rest pose. Now, I'm not going to use this at the moment. That is actually the rest pose as well. But that's how you do that if you were moving your model into a more natural stance, if you created it in what you didn't want to be its rest position. If you want to use the menu to change these options, we can go down to Pose. And if we go up, we've got Clear Transform. So we can clear them all under this menu. So if you've done a lot of transforms, you can just clear them all. Or indeed, you can do the location, rotation, and scale all individually as well. Unfortunately, there's no shortcut key at the moment for clearing them all off. And of course, Control and A will apply that pose, that's the other one that we've just been through, as the rest pose or as a visual transform to pose. So there we go. There's the difference between pose and rest position. And we can use that later on as soon as we've got more of our lamp made. Okay guys, quick challenge for you all. I'd like you to play with posing the lamp. Now it's not complete yet, but what I would like you to do is apply the mirror modifier to eliminate that horrible artifact I showed you. And then just play about with the basic pose. Try movement, rotation, and scaling. You'll probably find movement at the moment acts exactly like rotation. And the scaling itself, well, I suppose later on we can scale it gently up and down as if the lamp was breathing, perhaps. Anyway, more on that later. Pause the video now and just give that a go. Okay guys, welcome back. Congratulations, well done on playing about with the basic pose there. Now you may have noticed as you were moving about, you had your geometry passing through one another. Well, in the next lecture, we'll go about constraining that geometry so it doesn't pass through itself. So I will see you guys in the next lecture. Welcome to Constraining Bone's Movement. So in this video, you'll be able to lock movement to a single axis if that's necessary. And you're going to be able to constrain the degree of movement that is possible. So let's hop straight on over into Blender. Okay, so the first thing we want to do is let's work on this bottom bone here. So at the moment when we try and rotate it, obviously we can rotate it manually and limit it to the Z, global Z axis, and that'll spin round like that. That's kind of the movement we want to constrain it to. So looking over here at the transform properties on the properties shelf over on the right hand side, if it's not enabled, press N and bring it in, or you can click the little plus up there. So once that's open, we can literally put a padlock against the axis we want to lock. Now this is also available in the bone properties over here. We have a series of transform locks just here. It's just hidden at the moment. And we've got the same padlocks here. So if we turn that on, it turns on here and vice versa. Brilliant. So let's turn on some and see what happens. So we've got the Z-axis here, yes. So we'll leave that one unlocked and lock the other two. Let's try rotating it and see what happens. Oh, okay. So that is not locked on what I would think would have been the Z-axis. So I'm just going to undo that. Now I'm going to go to the armature and turn on axes under the display options. And if we look at the top of this bone, it doesn't see Z as upwards, it sees Y as upwards. So great, that's a good use of having the axes on because we can see how it's applying. So if this case we unlock the Y and lock the Z, now let's just try hitting the R key. There we go, it's completely locked. It's not wobbling about the place. Okay guys, a micro challenge for you. So there will be more to this video after this slide. So lock the axis of the lower arm bone. So pause the video now and give that a go. Welcome back. Let's hop back into Blender and just lock the axis of the lower arm bone. Right, let's select this bone here and we're looking at that we've got the axes on. It's the X-axis that we need to leave open. So let's do Y and Z. Excellent. Now let's try and rotate it. Excellent. It's going round and round and round and round. Excellent. It's not disappearing and wandering about. So now that we've locked the axes on here, what we don't want to do is this one to pass all the way through the base. So we need to constrain the movement of that bone. Oh, and by the way, I just thought this may have been the reason why the mirror modifier was being all crazy. The mirror axis is, of course, moving away, and when it was a free movement and not a locked movement, it wouldn't be in the center of this lot. So that's possibly what was causing that artifact earlier. Right, so let's constrain this movement. So we need to constrain that along its X-axis. Now, there is a chain icon over in the Properties window for constraints, but fortunately, if we click on that, it says go to the Bone Constraints tab, and there's a button there. It's this one over here, so I'll just pull this out a little. So next to what looks like a texture tab, there's the Bone Constraints, and there's a big long list in these constraints, and we want to limit its rotation. Now, something that's very important is getting the right axis, and we know it's the X-axis in this point, so we're going to limit it on X. And with the minimum and maximum as 0, when we try and rotate it, nothing will happen. So it's actually now locked in place. Now, in general, what I would do here is I'd set the minimum as minus 180 and the maximum as 180 to help you alleviate problems. And now it should spin freely round and round. Well, we need to work out what the minimum would be. Now, I've been playing about with this. I'm going to, I think, around minus 30. So let's just try rotating again. Yes, it locks in place there. It won't go any lower. But what I did notice as I was moving around, I was getting this horrible snapping effect. Now, the reason that is happening basically is because it is using the world space. If I change that to local space, now when I rotate it, it will be much smoother. But these change. So now I think it's at minus 80 or thereabouts. You can play with figures to your heart's content. And I'm going to set the maximum here. I'm not going to have it go all the way around. I'm going to have it, I think, around 130. Let's just try that and rotate it. So it goes all the way around here and stops about there. That's absolutely fine. If it goes much further than that, the lamp will start looking a bit silly. Obviously, if you go over the side, it will flip back around the other way and start rotating around again. Okay, brilliant. Okay, guys, the second challenge of this lecture is a bit of a bigger one. I'd like you to build the upper arm and create a bone. Make the upper arm a child of that bone, lock it into the appropriate axis, constrain its movement. Now it's up to you how much you constrain it by. And remember to name your meshes and bones. Pause the video now and give that a go. Welcome back. Let's hop straight on over into Blender. Right, so let's go ahead and create the rest of this basic lamp. I'm going to hop into edit mode, as that's the best place to work on our model. Now, our top bit here, I'm going to simply make it the same width as whatever that is there, or almost that width. So let's place the 3D cursor somewhere around there. I know because we're on the XY, we've created it literally from the center of our model. We can literally go down here, find our 3D cursor, and set the XY positions to 0. And let's just see where that ends up. Nowhere near our model. Great. Actually, the Y position we don't want to be 0, and nor the Z. We just want the X to be 0. So let's just try that again and create X0, and it's bang in the middle. That's close enough for me. And I'm going to create a small cube there. Of course, I don't want to be in edit mode of our armature here. So let's hop out of there. And I'm going to reset our pose. In object mode, create ourselves a mesh that's a cube. And I'm just simply going to scale it down quite a bit. Oh, that was remarkable. I've actually made it exactly what I wanted. Right, so I'm going to rotate that. That was far more luck than anything else by 45. And I'm going to grab this bit here, this face here, and I'm literally just going to move it. And I'm going to lock it to local Y. Yeah, okay, that's good. Let's view that from the side, see how it looks. Actually, I quite like that there. I think that needs to come in just ever so slightly. About there. Perfect. Okay, so we've got that there. So let's hop over to our armature. I'm going to select it in the outliner here, lamp rig. Click on this one here and extrude. I do want that locked. So X-axis, Shift and X. And I don't know if I've placed that in the right place, so I'm going to shift round to the side. Doesn't matter which side. Zoom in. And again, at this point in time, I can just adjust it roughly. Okay, let's hop into pose mode and then back into edit mode. So pose mode. Let's hop into pose mode. Click on here. Click on our mesh object, which we've not named yet, and I must do that. And our bone. And Control P. And set the parent to the bone. Let's name cube upper. I've still got caps lock on. I must have hit that earlier. Upper arm. And let's also name our bone. Lower arm 001. Nope, it's upper arm, I'm afraid. Good guess though. Right, so we've got the bone named. Scroll down. Deform. We need to turn deform off. Have I done that with this one? No, I haven't. Oops. Forgot about that earlier. We don't want the mesh deforming. Right, so now we've got that linked in, we just need to constrain its movement. So I believe it'll also be the x-axis. It is, so let's go up here. With this bone selected, only allow it to move around the x-axis. And in the constraints, let's limit rotation, local space, and limit x again. Now let's just grab that and see, that looks like it's 0 position, great. So probably 45 down and 130 up or something. So minimum, I don't know which way this is going to go. So I'm just going to go minus 30 and plus 90 and just see how far it moves. So that's your 90, yep, and that's your 30. Perfect. And of course we can add more detail to all of this later on. I just want to keep it nice and simple to demonstrate armatures. I'm just going to increase that ever so slightly to 120 and try minus 45 there and just see what it looks like from the side. Okay, let's rotate that. It goes back to there and forward to here. Excellent. So it's not going too far and not pushing through anything else. Excellent. So now we should be able to rotate things around and everything moves all together. Rotate that one round, perfect, and move this one here, excellent. And of course I'm just going to reset what I've just moved so it goes back to the rest position so we can continue modelling later on. Great, how are you guys getting on? I'd love to see your lamp at the moment. Perhaps you've added a bit more detail than I have in these short sessions we've got. Please share in the discussions and I will see you in the next lecture. Welcome to the Solidify modifier. In this video, you will create a 3D object from just curves. Give the new object thickness using the Solidify modifier. So let's hop over into Blender. So here we are, we're tantalizingly close to having what's almost a complete lamp, but it's missing the lampshade at the top. So we're going to use some similar skills that we learnt when making the base in order to make the lamp. But of course the lamp is actually hollow because it needs a bulb in the middle of it. So let's create ourselves a new Blender file. So let's go ahead and do that now. So we can just practice these skills that we need to work on. I'm going to get rid of the default cube from our scene. I'm also going to get rid of the camera and the lamp just to make it simple to follow. So the first thing I will want to do is add myself 2 curves. One is going to be a circle. So let's add the circle, and it doesn't actually, oh, it does matter because it's the other curve that matters as well. So let's leave that in the middle. I'm going to rotate it so it's locked to the x-axis and facing down the y-axis. So there we go. That's the way the lamp's going to be generated from this circle. The next thing we need to do is add a Bezier curve. I want to be able to see what I'm doing. So I'm going to flip around to the left, and I need to be in orthographic projection. There we go. So there's our circle, and I want a Bezier curve that I can see here. So let's add a curve, making sure we're in object mode, a Bezier. I can't see it at the moment because it's on the XY plane. I think I just need to rotate it here, and 90 degrees there, and on the Y, is it? Oh, that's translation. So I'll make it disappear. Let's try 90 on here. So that looks good, and then 90 on the Y as well. Or is it X? Okay, so that's good, and it's actually going the way that I want it to go as well. I'm happy with that. I need to lift it up by 1 on the Z-axis, so I'll lock it to the Z-axis and press 1. So it's on the origin itself, just as I'm creating this. Okay, so let's link these two together so we can see it as we build it up. So we need to go to the curve properties over here, and we need the circle to have the bevel object of this definition curve that we've got here. Haven't named anything at the moment, so I'll call this outline. Oh, outling. That's not right. Oh, doing very well here with my typing. Right. And let's set the bevel object to the... Oh, no, it's the circle needs the one of the outline. There we go. So we're starting to get something building up here. And what we'll need to do, I'm going to go into edit mode and start moving these points about. So that's a rough lamp, obviously, but I think we're going to need 2 control points to get a rough shape. So I'm going to extrude out and pop one there. Rotate the handles around a little. There we go. And perhaps rotate this one around here. And pull that down so it's a bit sharper. Ooh. I think I need to just pull it up, actually. There we go. That gives a better define. And you can obviously play about with this to your heart's content to get the shape that you want. I'm going to leave it like that for the moment. Okay, so here we have basically a two-dimensional object. Now, in the curve properties here, if you hit 2D on the circle, it will fill it in and become a flat shape, and we can have a look at the wireframe and see that there's nothing inside it. It's just a completely solid object once you've done that. Now I'm going to hop back onto 3D because I want it hollow, but that is essentially just a skin. There's no thickness to it. So we need to use what's called a modifier, and we need the solidify modifier. So we're going to go to our modifiers, add a modifier, and go down to solidify, which is under generate. Now once we've done that, we can see it changes straight away. Oh, that looks good. And if we hop into wireframe mode, we can't see anything at the moment. That's probably because the thickness is very, very low. So let's have a thickness of 1. And oh, there we go. It's got a great thickness there. Perhaps 1 was a little too high. Let's go 0.5. And now hop out of wireframe mode and just see what's going on. And that's absolutely brilliant. We actually want a hole in the back here so we can change our curve if we wanted to make that happen. Now the clamp feature is very useful. It actually allows us to constrain the amount of thickness we add. So if we go here and increase the clamp value, it doesn't matter how much you increase or decrease this value. You've got negative thickness and positive thickness. It clamps it to a certain ratio, and that's very helpful to making sure that you don't push geometry through itself. So if I turn the clamp completely off and in this wireframe mode, just keep increasing the thickness, essentially the thinnest parts, as you can see, start passing through one another, and that will continue happening again and again and again. So eventually, if you push it out, you get something wacky like this going on. Although, to be quite honest, that is almost a jet fighter engine again, or a tannoy. Attention, everybody! Take this course now. Brilliant. So we've made a tannoy. But there's obviously a lot of geometry inside. It's a very messy model doing it that way. You'd be much better just defining this with curves. So let's push that back so it's sensible and increase the clamp. And depending on how high you set that clamp, it's got a value between 0 and 2. Depends on the amount of clamping that will actually happen. So again, in wireframe mode, it gives us a good indication of wall thickness throughout. So you generally just need to play with these two figures here, the thickness and clamp, in order to get yourself a reasonable looking lampshade or bell or anything else that has this shape here, or anything that follows a thickness pattern. So if you've defined anything else using curves, you can add this thickness here, or indeed just a plane, you can add thickness using the solidify modifier. Okay guys, it's challenge time. I'd like you to create the lampshade. So create the lampshade using curves with a solidify modifier. Now for ease, I do suggest you set a new rest position of the upper arm going along the y-axis. It'll just make creating your lampshade a lot easier. Now, if you're following along with my exact model, then do feel free to add a ball for the joint at the top of the lower arm. I'm going to make this top section really simple, so this head has not 360-degree movement. We're going to constrain it later on. But do add a ball at the top of the lower arm. If you've got a slightly different mechanism, then go ahead and create that with the knowledge you've now got. If you have created a ball joint, then set it as the parent of both curves. Add another bone to your armature, name that one appropriately, and then parent that bone to the lampshade ball joint. Okay, one final thing, when you are done, reset the rest pose so it looks like this in the picture. Pause the video now and give that a go. Welcome back guys, let's hop straight on over into Blender and create our lampshade. So let's go ahead and make our lampshade. So the first thing I want to do is just align this. So basically it's just running flat. Now because I've already put the constraints on and they're accurate, I know that I can literally just grab that and move it down and it will be locked in position. And if we move to the left view or the right view, it doesn't matter, we can see that it's running straight along there. Finally, I want to use Control and A and apply the pose as the rest pose. Now that then changes the edit mode, will be now the same. Now if we had done it in the edit mode, it actually screws up all of the angles and constraints that we put in because it changes the angles. So you need to make those sort of changes in pose mode. Now that we have that there, we need to actually create our circle and our Bezier curve. So the first thing I will do is move the cursor to the 3D cursor to the end of this section here. So I'm going to come out of edit mode, select our upper arm, hop into edit mode again, and excellent, the top face is selected. If it's not, I could select it. I'm going to move the 3D cursor to selection, or to selected, which will put it smack bang in the middle of that face. Right, the next thing I will need to do is come out of edit mode so I don't add our curves to that object and create us a circle. It's going to be pretty big. By default, it's going to be 1. So I'm going to do the rotation on the x-axis by 90. That's fine. And I'm going to here the radius. I've been playing with some figures. I think it's going to need to be about 0.08 or thereabouts. Perfect. I'm happy with that circle. So now we need to add another curve, which is going to define the outline of our model. Excellent. So that's in there. We'll do some tinkering with this curve in a moment. It doesn't really matter on the size, but I'm just going to make it roughly the same size as our circle that we have here. Now that we've got that, we need to make sure that the circle uses the line here, the Bezier curve, as its bevel object. And we can do some renaming in a moment. So now that we've got that there, let's actually sort out this curve here so that it actually follows the shape that we're making. Otherwise, it's just a bit confusing if you're moving things one way and they're moving on another axis. So the way that I'm going to do that, I'm just going to flip round to the top view so I can see this curve, and I'm going to rotate it round in the z-axis by 90, and let's just move it out as well so we can see what's going on. Now let's go in and edit that and see what happens when we move this one. Okay, so when we move left and right, the actual curve itself is moving forwards and back. So we need a 90-degree rotation somewhere. So let's hop back into object mode and let's try rotating it 90 degrees. Well, let's cancel the 90 degrees on the Z and try that again. And that's still moving left and right there. So let's do 90 degrees on the X. Okay, that's rotated around so we can't see it from this angle, but it looks like from the side that's going to make excellent sense. So let's go around here and just see what's going on. Hop into the left-hand view. Now that's starting to look more like our lampshade shape. So if we hop into edit mode and I pull it forward and back, it is going forward and back, but it looks like the curve itself is the wrong way around. So I'm just going to move the curve literally round itself and grab this point over here if I can see it anymore. There it is. And move it this way. Perfect. So then we've got this bit here, which is going forward and back. Still not quite right. So we need to rotate it once more on another axis. Let's cancel that one there and view it from the top and put a 90-degree rotation in there. Is this going to need 90 in all of them? It's going to need a 180 somewhere by the looks of it. Let's try 180x. Okay, that looks perfect. So a bit of playing about there and we've got ourselves the right shape. So let's go around to the left again and edit that curve, and we can see now when we pull it forward and back it matches, and it's even got the little incorrect inflection going on. So we can rotate that round so it's not being fussy and coming in on itself. So we can move that back ever so slightly now. This one here, clicking the wrong thing. And we've got a hole in there, that's absolutely fine. We can cover that up in a moment with a ball joint. I'm just going to move this one in a little because that's just a little bit wide, and move these controls around. Okay, that's looking good. So let's just have a look for scale. That might end up being a bit big, I'm not sure yet. We can always scale it up and down or modify these curves later. I'm just going to extrude and put another bit in here and around there. How's that looking? That's pretty much in proportion. It's looking a bit thick, so let's go here and push that in slightly. Move that one in again and just make this a bit smaller as well. Brilliant. I'm happy with that for the moment. I could probably spend the next hour or so fiddling about with it and getting it more perfect, but remember, don't chase perfection all the time. So we need to add ourselves in come out of edit mode into object mode and add a solidify modifier. So in the modifiers, making sure that our Bezier circle is selected, because that's the thing we're applying the thickness to, and go to solidify. Oh, that looks pretty good already. Let's just play with a couple of values. No, actually 0.1 seems absolutely fine. Oh, it's 0.01. There we go. Right, so I'm going to move the cursor to selected again with the right key combo of Shift and S. It'll place it back there, and I'm going to add a mesh object that's a UV sphere. Of course, it's going to be massive. I'm simply going to downsize it to, it was 0.8 earlier, I think, or 0.08, one of the two, 0.08. So 0.08, and again, you will have to play with some figures that suit your model fine. So now that we've got that in place, that's created a ball joint there. I'm happy with that. We will just set it as smooth shading so it matches the rest of the model. Okay, brilliant. That's starting to look much like a lamp. The final thing I'm going to do is change it so the rest position is similar to how it was before. So I'm going to hop over into pose mode after selecting the lamp rig. Once we've done that, I'm going to move this by 90 degrees up here, but it's not connected to anything yet. So let's go ahead and create another bone coming out of here, lock it to the y-axis. So it's coming out of there. And then finally, we've got a bit of parenting to do here. So this, let's have this area here, the actual lampshade and the ball, almost connected and being as one. So we've got our sphere here. So I'm going to call that lampshade joint, because that's essentially what it's doing. And then we've got our Bezier circle. So this is the lampshade profile. And then the curve is the lamp shade outline. Excellent. So now we have those three things named. I'm going to basically make the curves, I think, children of the joint. And then I can select the joint, select the armature, and we do need to be in pose mode for this. So let's hop back over to the rig. Pose mode. Excellent. So select the joint if I can. Yep. Select the armature, or more specifically the bone that's connected, and then parent it with Control and P to the bone. Okay, so now we should see that that is constrained there, and if we move around, we should be able to move it to the left, to the right, etc. Perfect. I'm going to reset the rotation, and finally, I'm going to lift this up. I'm going to rotate that by 45 degrees, and I think this one here, rotate it by -90 in the ZY plane, which will be Shift and X. Brilliant. So that is that set, and finally I want to go Control and A and apply the pose as the rest pose, because that's the default state our lamp is going to be in. Okay, let's have a look at our lamp and see how it's doing. I'm just going to turn X-ray off on the armatures. In fact, I'm just going to hide the rig for the moment. That'll probably be easier. Pose mode, and now I should be able to turn that rig off. Brilliant. So the only thing that I can see here for changing later on is potentially making this ball joint where it joins onto the upper arm, perhaps making the upper arm a bit thinner so that it's not Doesn't look so ridiculous at the top there, but otherwise we've got ourselves a pretty good looking lamp. How are you guys getting on? Please share in the discussions. I'd love to see how you're getting on, and I will see you in the next lecture. Welcome to the introduction to the Node Editor. In this video, you will open up the Node Editor, create some basic materials, apply these materials to our model, and see how adjustments in the Node Editor affect our model. So let's hop straight on over into Blender. Right, so over in Blender, there's a couple of things we'll need to do first of all. I'm going to turn my backdrop back on. I'm going to turn... the camera doesn't matter at this point in time. The cone, that was a positional cone, and now makes no sense to have anymore. So I'm going to delete that from our scene. Looking down the list here, I've got the lamp that was there and the plane. I'll want to turn both of those on, so our light sources are in the scene, because the Node Editor is all to do with cycles render. So, and further down here, I think that's all we need to turn on. Don't need to see the rig for this next bit. Now we need to add the Node Editor. So I'm going to go to the splitter widget on the 3D Editor header and just pull that down, and probably about 50-50 for me with my resolution here. Okay, and I'm going to change this bottom one to Node Editor, which is just here. So we're changing the window type to the Node Editor. And it just looks like this space here at the moment. Great. I'm also going to just pan upwards here, and I'm going to start focusing on the base of our lamp. To speed up render times, I'm going to use Control and B and just draw a box around the bottom of the lamp, basically, so we can see what's going on. In fact, I'm going to zoom in a little more, so that's filling up the screen. Then I'm just going to draw another border that's just slightly bigger. Then when I switch on Cycles Render at the top here, which it is, and go to Rendered View, it will only render this area here. And I can see that there's light coming in from our plane and everything else. Great. So I'm actually going to create our new material straight away over in the Materials tab over here. So I'm going to create a new material, and you can see two things have straight away appeared in the Node Editor. And for now, I'm just going to push this away to one side so we can see what's going on in the screen in front of us. I'm going to zoom in here because I can't read that at the moment, so you definitely can't. And we've got two items in front of us. These are nodes. Now, nodes can consist of different types. If we go down to Add on the header, we can see there are lots of different types of node that we can have. For the moment, we're going to be dealing with shaders, which is what a diffuse node is, and the material output. That's what we'll actually see. And we're connected here with two lines. So we've got the output here going all the way to the surface material here. If I click and drag that away from there, it literally disappears. But because it's the same as the default material at the moment, it looks no different. If I was to change this color here to something else, there we go. I'm going to make it bright red. I'll try and make it bright red. I can see a red cast in our scene, and I think we've colored in something else. Yes, we have. So let's select our base first. I didn't select the base, silly me. And I'm literally going to select from the materials here, material. And I'm going to name that material whilst I'm here, red lamp paint. You can choose a different color if you like. I just like the color red in this instance. Okay, so we've got a red lamp, and if I pull the surface connector out, it goes black. It's got no material assigned to it. So let's connect those back up again. Now, unlike Blender Render, where you can add the two things together over in the side, you can't do that with this materials property on the right hand side. So I'm just going to make that disappear. Now, what we need to do here, and I'm just going to squish it up a bit further to give myself a bit more space. And I'm going to zoom out here. Hopefully you can still read what's going on. I need to add another shader. So, like anything else in Blender, you can either go down to the Add menu here. But I'm going to use the shortcut key Shift and A. So Shift and A will bring up the Add menu. Now I'm going to be looking for the shader that is a mix shader, which is at the top. But there's a very quick way. If you know what you're looking for, in this case a mix shader, I'm going to type in, or I'm going to click on search and type in mix shader. It looks like that was the last one I was indeed looking for. And that will add a mix shader node in. Now, if you hover a node over the top of a connector, it will automatically join them together for us. So that's that done there. So we've now got a 50%, that's what this factor here means, of our diffuse shader, so it looks all matte, going to our material output, which is what we see on the screen. Now I want to give it a bit of specularity, a bit of reflection. So in order to do that, I need to add what's called a glossy shader. So I'm going to go down to shaders and just have a quick look down here, and there we go, glossy. If I add that, I'm going to place it next to here. You can place these wherever you like, but for organizational purposes, I like to keep these things together. And the output here, I'm going to plug into this second shader area. And you can see we're starting to get an interesting render at the top. Right, so let's play about with these a little more. I don't like what's come out there, so I'm going to move this to the left or the right and see if we can get what I think is a better mix. This will be around a 20% mix. That does look a lot better. Now, with the glossy shader, there is a series of selections you can go for. The only one that really makes a difference that I can see is sharp. In our particular model, it just produces a sharp reflection full stop. If I pick any of the others, they all look relatively similar. Now, whilst this is rendering away at the top here, it's only 10 samples. So what I'm going to quickly do is pull this out on the side. I'm going to go to the render properties and scroll down to where we have the sampling. And I'm going to turn the number of samples up in our preview to, I'm going to do 100. You don't have to go that high. And so it will get better and better as I wait. Every time I change something, it will have to start at 0 again. But that's not a big deal for me at the moment because we're only rendering a small area. In fact, I'm going to make the render area just slightly smaller again. Excellent. So I'm still not a great fan of what's going on here. This roughness slider, well, that is very useful when it comes to the glossy. If we turn it all the way up to 100%, it just looks like a matte. It just looks matte again. If we lower it all the way down to nothing, it goes super glossy, as if we had just selected sharp here on the distribution. However, after playing with it, oh, look at that. If we zoom in a little here, we can actually see it's reflecting the rest of the lamp up the top. That's brilliant. So I want to keep some of that reflection in our model. So I'm going to play with this roughness setting. I'm going to start with 0.2 and see if that is high enough. Let's zoom in a little. No, I want something a bit lower, so I'm going to try 0.1. And a lot of this is about experimentation. I can see the reflection is there. It's not really well defined, but it is there, and that's what I want. So I'm just going to pull out a little here. Okay, that's starting to look really good. I'm liking the output here. This factor here, again, if I moved all the way to one side, you just see the shiny part of it, and it looks like we've got some weird artifacts going around the base here. So it'd be worthwhile trying to clean that up in a few moments, and we can bring in the rest of our colour, which is our diffuse over here, into our scene. In fact, I quite like the setting I've managed to get there, which is about 13% coming through that's glossy. Right, let's see if we can quickly, I'm going to bring up the header bar over here. I'm just going to see whether we can go in and edit this and put another loop cut in just around here. And I'm going to bring it out ever so slightly to give it more of a base and see how that affects our render itself, to see if that makes a difference. That gives it a much more defined edge and doesn't look so nasty anymore. So you can see by applying the render soon on in the model, if we had actually gone through and rendered this a little bit earlier, we'd have been able to correct that geometry as we were going. That's brilliant. I think it's challenge time. I would like you to add material to the rest of the scene. Play with the materials in the node editor, have fun with it. Create at least 2 different materials by using the node editor. Remember, you have a material on the backdrop too, so you can add a different type of material to that, and make sure you assign your new materials to the rest of the lamp so that nothing's left with the default material. Pause the video now and give that a go. Okay guys, welcome back. Let's hop straight over into Blender. Right, so back over in Blender, I'm just going to pull this down a little so I can see what's going on. Let's have a look at what we've got so far. So there are a couple of other bits of our model to apply materials to. I think I'm going to keep my ball joint just a separate colour for the moment, and this one down the bottom here. Oh, I've gone behind my scene by the looks of things. So this stem, I think we've called it. So let's have a look at the stem now, and I'm going to call this metal. Again, I'm just going to play with how this turns out. Let's pull that up. There we go, let's pull that up there, and well, this is actually rendering quite a large area, so I'm going to draw a new area around here so I can just watch it render out. I'm going to add another one, and it's going to be shader gloss. Only worked with those at the moment. I also want to add a mix shader, which is, oh, I've run out of screen space there for that. I'm going to go to the top of that, that'll add it in, and I'm going to add another one. Okay, so metal's a little shinier than paint in general, and it tends to be kind of grey in colour, I suppose. So I'm going to make it a dark grey, and I'm going to go more towards that dark grey. But I'm going to decrease, the amount of roughness, not completely, but about there. Okay, how are we getting on there? Let's zoom in a little and see how that's looking. Oh, keep going behind the scene. Okay, that's looking pretty good. Let's see what it looks like with that all the way up. No, let's just raise it a little bit more. Okay, the rest of this these arms, I'm going to actually give those. I'm going to clear my selection for the moment. There we go. I'm going to give these arms the same material, so I can go to the material properties here and do red lamp paint. And I'm going to do the same for the lower arms. There we go. So it just leaves this ball joint here, and I think, and I can neaten that up later on. I'm not going to do it at the moment. I'm going to add in the metal one there. Okay, so now I've got those there. In fact, the metal one, I am going to make it highly reflective. So I'm literally going to set it to sharp, so it just reflects everything that's around it. Okay, so that's the basic lamp done. I'm going to have the backdrop. So let's have a bit of fun with the backdrop. I'm going to add a new material, and I'm going to call it backdrop. Very important to name your materials so you know what's going on. So backdrop. Now I've got loads and loads of choices. I mean, I could essentially change this to diffuse. So delete that, hit X and delete it. Of course, now it's got no material, so it disappears. I'm going to add a shader that is just glossy. Let's see what happens if we do this. I'm just having a bit of fun here. It might go horribly wrong. So with a roughness of 20, we actually get a reflection going on. Obviously, if we turn it all the way down, we end up with a very, very shiny mirror. And, oh, how does that look? There's got to be another reflection going on at some point over here. Or maybe not. No, no other reflection going on there. Wow, okay, so let's just turn up the roughness ever so slightly. I might leave it like that. Don't know if it's a bit too shiny, but I will give it a different colour. No. Still no. Blue does go well with red, but no. How about an orange? A deep orange. Oh, that's quite nice. It's quite a warm scene now. Although the problem with just having it reflective like that is it does look more like the lamp's floating than anything else. So I will add in another diffuse shader. and a mix shader. So I'm going to search for mix shader, add that in, add this one in here. I'm not going to do that. I'll cross them back over, and I'm going to set the color down here as, again, a deep color there, and slowly just turn it a bit up here so it's a bit more shiny. Excellent. Still looks a bit like it's floating though. That might just be me not in the right position or waiting for it to render out. Actually, no, it looks absolutely fine. Okay, that's great. I'd love to see what you guys have come up with your rendering of your lamp. And shortly, we'll be making this one move. Until then, I will see you in the next lecture. Welcome to lamps versus emissive materials in cycles. So in this video, you will learn the differences between the two light sources when using the cycle's render engine. Understand that there is a time and a place for both. They both have pros and cons. And finally, we're going to use the black body node. So let's hop straight on over into Blender. Okay, so we have our lamp here, and if we render it as we had it a few moments ago, we notice there's no light coming out of it, so we do want a light bulb inside our lamp. Now, there's a couple of ways how we can simulate this happening. So we've got the 3D cursor set there at the moment, so we can literally go ahead and add a lamp into our scene that is a spotlight. Okay, let's change this to solid for a moment so we can see the direction of the spotlight is currently down. So I'm going to rotate that 45 degrees. Yeah, that's brilliant. And it's roughly the right size as well. Over in the spotlight options, you can change a couple of items here. Its strength, we can see it's an emission, the color coming out of it, the size of the spot itself, and a couple of other options there. So let's just render that out and see what happens. In fact, I'm going to just render this area here where the lamp light is falling. And we can see we get a relatively clean lighting effect quite quickly. Let's just move it around a little and see how that comes out. Yes, that's looking quite good, but we're already at 30, with this number of samples are counting up here. I've raised my preview to about 100. That's not bright enough, so we can increase the strength here a little and see what we get then. So that should give us twice the amount of light, and in fact we can see there's a hole here, and it looks like I positioned the lamp behind something, so it's actually causing a shadow. But you can see very quickly how we've got a nice, quick, defined line, and it's not taking too long to get out a spot on the floor. But it's not as accurate as a mesh emission would be. So there's places for both of these. The actual bit of our scene that's lighting the main scene, this plane over here in the sky, this one here, that is an emission plane, and it's basically casting light across our scene. However, if we want our spotlight to be quite accurate, we may use a lamp to do it. So let's just let that render out now and see what it looks like after 100 samples. In fact, before we go and do that, I'm not going to let you be bored too much watching 100 samples. I'm literally just going to hop in here and move our lamp. Oh, wrong lamp. Move the spotlight. Just move it down a little to where a bulb would be. Okay, brilliant. So let's see how that works out when it's rendered. Okay, so we've reached 100 samples there. That's a really, really crisp image, really crisp spotlight, sorry, that's going on there. So I really like that in the case of here. And if I wanted to use that, I would attach it to the lamp itself, parent it to the lamp joint. I think we've got everything going on there. Now we've had a look at that, let's have a look at what an emission would be like. So I'm going to hide our spotlight. In fact, I'm just going to delete it from the scene for the moment. So it's not there at all, not going to cause us any problems. And I'm going to use a circle. So it's not a too complicated mesh. There's a circle. I'm going to have to scale that in. I don't know how small, probably 0.8 again. That seems to be a good number at the moment. I'm just going to turn off render mode for the moment as well. Okay, so I'm going to have to rotate that around the x-axis by 45 degrees. I'm going to go to the side view again. Let's just see, and move that down to around the same place as our lamp was. I'm just going to hop into wireframe mode to see where that is. That's absolutely fine. Now at the moment it's just a circle. So what we're going to have to do is fill the circle in so it's got a face to it. Now I'll go hop into edit mode and add a face. Now that looks like the face is actually the wrong way round, but it doesn't matter at this moment in time. But there is an option that will make sure that the light only comes from one side of the plane. We won't worry about that at the moment. We've got that set there, and let's create a new material, and I'm going to call it light bulb, and it's going to be an emissive material. And there it is on the node editor. It's hiding away out of the way. So I want to introduce you to this color value here. You can actually change the color of the lights coming off of here. And by default, it's set to white. Now we can control that color value. As you can see, there's a little entry point for it here. So if we go and add, and it's all the way down at the bottom, yet converter, you can see here we've got a black body. And what that does is it enables us to give a color temperature. So if we link the color output to the color input of emission, we can change the temperature of the color. So if you know you've got a 5000 Kelvin lamp, it will actually produce the right colored light. So now we've got that there, and we've got an emission strength of 1. Let's turn it up to 200 like the last lamp. And let's render a similar scene as before. Okay, so that is a 100 sample render, and as you can see, it's a lot more noisy than the last one, although it is probably more physically accurate. Now we can play with the settings down here and perhaps increase the strength, because it's quite a small surface area, and the way that light is calculated from an emission is, well, this strength, this value here, is based upon the area of the surface itself. As we saw with the large plane when we originally set that up for the lighting for the rest of the scene, because it was so large we could get away with a strength of only 5. But of course with this tiny bulb in the middle there, we have to make the strength much larger if we want a brighter light. So we see at 100 samples it's still very noisy. So over in the render properties here, we can go down here and let's find samples. I think I've whizzed past it actually. Sample, 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 sample. Sampling. Here we go. So in the preview, I've got it set to 100. I'm going to now up that to something silly and, of course, pause the video whilst it renders. So we're coming up to around 1,000 samples now, and it's actually looking dare I say it, a bit more realistic. It's not such a concise spot, and I don't think it would be coming out of a lamp like that, but it's a much more even spread of light. Now I'm going to, again, pause the video, but I'm going to just render the entire scene that we can see here. Okay, so just after 1,000 samples, and it's been about a 10-minute render at the moment. This is just a viewport render, not a camera-based render like we've done in the past. And we can see we're getting more and more of a spot appearing. But it's taken an absolute age to do this. So for accuracy, I mean, we've got the brighter light where it's closer and then it fading off. Obviously, this is an orange background, but the light itself is slightly orange as well from here. And, you know, there's an argument both ways. One's accurate, because that's exactly the light you would get out of that lampshade, whereas one is a fake spotlight. So one's kind of faking it, but it does depend on what you want to do and the power of your machine and the time you've got to render it. Obviously, the more complex a scene you've got to do. I mean, the other one had a realistic, or not a realistic render, but a suitable render in 30 seconds or so. This is already at 10.5 minutes, and it's going to probably just keep on going and going. What have we got there? Another 15 minutes. I'm tempted to leave it to do that, but at the same time, I want to get on with the next stage of this as well. So we'll leave it there for the moment. Actually, whilst that's rendering in the background, I'm going to give you a challenge. One quick thing that I'll mention before I do the challenge is that if we were to look inside the lamp at the moment, there would be a light in there. If we were to look inside of the lamp with only a lamp source, it's getting confusing with lamps and lamps here, but if we were to look inside the lamp when we had the previous spotlight generating the light coming out, we wouldn't see anything. It would be dark inside the lampshade itself. So there is a distinct difference there. So what you may want to do is do a small combination of both. So it maybe not turn the emission up quite this high, but just have it in there so there is a light source. So if the lamp were to ever look in the direction of the camera, at least then there is something inside there. Because it would look a bit odd if when we were animating it, you moved the lamp towards the camera, perhaps to look at the camera, and then you find that it's dark inside there. That would be a bit confusing for the viewer. Okay, so your challenge is to add your light bulb. Choose your light source for the bulb. You can do both, of course. You can do emissive and a spotlight. And then finally, parent the light source appropriately so it moves correctly when we move the lampshade. Pause the video now and give that a go. Welcome back. Let's hop over in Blender and sort that out. Wow, so we're back over in Blender, and I don't know if you can see what I'm seeing here, but the screen's gone a little bit funny. It looks like when I move the mouse over it, it all comes back. Is that bit coming back? I don't know. I don't know whether Blender's going to crash because of this, but I can still see it's doing its render at the moment, and it's not even reached 2,000 samples. I'm going to obviously move my model round in a moment to show you what I'm going to do, and I'm going to stop that rendering. I'm just going to solid. It's a shame to stop it there, but if we hop around now and just have a look inside the lamp, you'll see that that circle that I generated, when we actually look inside the lamp, if I hit render, it's white. There is a light source there, which is great. That is what we want. Hop back into solid mode. I'm going to use the origin of that, so I'm going to move the cursor to that origin, so Shift S, cursor to selected. I'm going to add. I'm in edit mode. I don't want to be in edit mode. I'm going to come out of edit mode. I'm going to add a lamp. I'm being blind here. Lamp, there we go. Spotlight. And I'm going to rotate that round by 45. I'm happy with the light it casts from there. And because we're working on the lamp now, we can see we've got a lamp output, we've got an emission, and I'm going to set it to the same color temperature as before. So I'm going to add a black body. So BLACK, body, there we go. And I'm going to link these two together. And of course, 1500 would be a very orange type light. I think we were at 5000 before. However, I will check. So let's go to the circle that's on here, 5000. That's absolutely right. Okay, so let's just do a very quick render. I'm going to use Control and B to go around here. And just hit render and see how that comes out. So we get a spot coming out plus all the other stuff in there. So what we can do to minimize that from happening is we can go onto our circle and just turn the strength right down. So if I set that to, I'm going to just do 100 for the moment. We still get a little bit of speckling, but it's not going to cause us too much grief. And when we look inside the lamp, we've still got a light. Oh, I'm looking at it through the rest of the backdrop there. Okay, I'm going to turn the emission down a little bit more. I'm going to go to 50. Maybe even less than that, actually. I am on the right thing. Yeah, I'm on the circle. Let's try 1. Okay, that's great. That adds something inside the lamp. And no, that's far too dim. Let's try 20. Okay, that adds enough detail in the lamp. And is it causing a lot of speckling outside? Because I do want to be cautious of the amount of noise that's being produced. No, that's absolutely fine. I'm quite happy with that. Although I do want the strength of our lamp to come up, the actual spotlight itself. So let's go back to the spot. And looking at this, we've got a strength of 100. Let's turn it up to 250 and see what we get then. A much more defined spot. Perfect. So I've left that to render out for 3,000 samples. That's a bit high. No need for you to go that high. And I've just noticed a couple of things. First of all, I don't want it to be quite this harsh, so I can change a few settings there. I did walk away to go grab a glass of water. I didn't deliberately let it run for 3,000 samples. So I'm going to go to the spotlight and go to the spot properties. I'm just going to increase the size of our spot to 60, and that will give it a much larger circle, so I'm happy with that. Okay, now I'm going to increase the blend ever so slightly as well to make it just a little bit softer round the edge. Maybe not quite that high, perhaps 0.5. Okay, now that's done, I just need to link both the lamp that we've just created, this circle here. I'm going to call that light bulb. Okay, so that's that and the spot. Now I need to find the, where is it? The lampshade joints. They're both children of that. And we'll just check really quickly if we click on the rig, go into pose mode, which we're in. I can't see the rig at the moment, so let's turn it on. Excellent. We need to grab one of the bones, and that is the, not the upper arm bone, the next one down. This one here. Oh, have we not? It's upper arm 001. Let's rename that straight away whilst we spotted that to lampshade. Excellent. So with that selected, if I move our lamp about, excellent, the spotlight moves as well. That's exactly what I wanted to do. Excellent. So please share how you got on in discussions. I'd love to see what sort of spotlights you guys came up with, whether you followed this exactly or you experimented a little. Please share in the discussions, and I will see you in the next lecture. Welcome to Auto Inverse Kinematics, or IK. In this video, you will learn how to turn on Auto IK, realise that this is a starting point and not perfect, understand that it applies to the whole rig, and see that it allows us to control the connected bones all at once. So let's hop straight on over into Blender. Okay, so we're back over in Blender, and I'm just going to clear up my screen space for the moment. So I'm going to hide our node editor, and I'm going to clear our render border, and actually just switch it over to solid. There we go. So now we've got our model in front of us. If we were to move it in its pose positions, what we currently have to do is grab each one of these individually and move it to the position that we want, which is a bit arduous. It would take ages to set up a pose for your model this way. But there is a better way. What we can do is turn on Auto IK. Now that's under the options menu on the tool shelf, and there's a little tick box here. It's the only one. You do need to be in pose mode with your armature selected and turn on Auto IK. Now what that does is it affects the entire rig. Every single bone in this rig, it now has Auto IK. Now what that means is as we move one of these bones, the others also move as well. Now it's not going to be perfect, but it's a great starting point to get your model into certain positions. And it controls all of these connected bones. If we had any bones that were separate to this model, it would not do that, and we couldn't use Auto IK to animate a model that was like that. Now, in terms of how powerful this is, as you can see, it allows us to get into any position very, very quickly. However, there are limitations, of course. You will see that as you move it about, occasionally the model will end up looking the wrong way. Now, it looks like it's going okay at the moment. It must just be the view I'm in. And I'm just clicking this end node here and just moving it about. If we grab the bone itself, it also does the same. If we grab the bone behind, it doesn't affect the bone in front of it. Now, that's an important consideration to make whenever you're moving your model around. The movement itself goes backwards down the chain, right to this root bone at the base that we have here. So if I'm moving this one, it affects everything. If I'm moving this one on the bottom, it only affects itself. This one would only affect itself and the one beneath it, and so forth and so forth. So at least we can position things how we want. Must remember to left click to set the position, and you can see it affects it. Now you can also move these all individually without auto IK applied as well. So we can just hit the rotate and just move it to a different position, just in case it's ended up in a bit of a squiffy position. And let's just see how that looks in rendered mode. Perfect. The lamp is looking at us. Okay, guys, it's challenge time. I would like you to strike a pose. Now play with the various poses and share your poses that you have in the discussions. Let's have some fun. Pause the video now and give that a go. Okay guys, welcome back. Let's hop quickly over into Blender and play with our model. So I'm going to hop back on over into solid mode. Now, depending on what you want to do with your model, what poses you have it in, of course you can move all of these bones. We can have the lamp looking at itself. Let's see if we can bring that in a little. Right, and lift this one up. I might have to rotate this one just here manually to point it down a little. There we go. So there's lots of poses you can get into. Now, as you've been playing about, you'll notice that sometimes you end up with this jerking happen where it flicks from one side to another. Now, there are certain ways we can eliminate that, but essentially you're going to have a few problems from time to time, especially if the bones end up flipped like that. So the simple thing is to make sure that you don't do too violent a movement at once. So don't go from one extreme over here to over here and expect it to look nice as it progresses through the movement. And as you can see, at certain points it ends up flipping and looking horrible. Brilliant! If you haven't done already, I'd love to see the poses you've come up with in the discussion, so please post a picture in there. And if you've got any questions, ask in the discussions, and I will see you in the next lecture. Welcome to the timeline. In this video, you'll be introduced to the timeline, shown how to adjust the playback and rendering range, and how to alter the frames per second of your animation. So let's hop straight on over into Blender. Okay, so let's first of all make the timeline appear. And I hid it a few lectures back. Now you may already still have it on your screen. I don't want to reveal it that way, so let's just get rid of that. I'm going to create a new window, and I'm going to change this bottom one to the timeline view. And I'm just going to push all this lot over here to one side so we can see the entire header bar of the timeline along the bottom of the screen here. Now I'm just going to go through it bit by bit. Obviously here we have what the window we have is, and we've got it selected to the timeline just here. It's at the bottom there, and it's got a picture of a little clock. Under view, well, we're not going to go into anything under view for the moment. Under markers, now this is incredibly useful if you need to mark a point in time. Now when you initially add a marker, it's named it F_01, you can right click and move that to where you want and press left click to place it, just like you do objects. We can zoom in and out of the timeline, by the way. I just nudged the scroll wheel there with the scroll wheel if necessary. Now, if F_01 is not to your liking, under marker, we've also got the option to rename marker. You can see there's a shortcut here for M to add a marker, and rename marker is Control and M. At the moment we have that, for instance, if we were going to make our model jump at this point, we can put in a marker there that we want it to be named jump. Perfect. Frame. Now there are some awesome options here. So the start frame and end frame. So the shortcuts here, S and E, well, they're the same as this start frame and end frame here. So I'll probably be editing them down here rather than going into the menu. However, if you've just gone to a certain location on a bigger project, say frame 80 is where you need to start from and work on, you can set the start frame very quickly by just doing that rather than waiting around and going here. But since in this case we're going to be starting from 0 and going onwards from there, those options aren't necessary in this module. And now, if we want to just preview a range, now this is very helpful. So if we go to set preview range, we can quickly select this area here by drawing a box around it essentially, and it limits the playback range, which is here, to this section here. Now, the great thing about that is it doesn't change anything else. So if we go back to frame and we clear the preview range, it goes back to how it was before. So we have the start and end frame here, which we can see is at 0 on this side and goes all the way along. I'm just clicking and dragging the green thing to demonstrate to 250. And obviously we can increase that and decrease that as we like. And then we've got some playback buttons along here. So we've got all the way back to the beginning, rewind, play backwards, play forwards, fast forward, and all the way to the end frame. So how do we control the frames per second, and how do we know what they are? I don't see any option along here. The rest of this we won't deal with on the header bar, by the way. We'll come to that when this area here with the what looks like a record button, this red circle, when we talk about keyframes in the next lecture. So, in order to change the frames per second, well, that's hidden under the render properties. So I'm just going to move this back out now. So we've got the camera here. We're in the properties window, the little picture of the camera, the render properties. Now, scrolling down, or scrolling up in this case, we want the one that says dimensions. And down here we have one of the options is frame rate, and that's where you can set the frame rate. So if we set this back to 0 and press play, it's currently moving along at 24 frames per second. So by the time we reach 240 frames, 10 seconds of animation has passed, before it automatically loops and plays through the animation again. Excellent. So if we change that to 60 frames per second, the animation speed is going to be a lot faster. Now in this case, what we probably want to do is leave it how it is. We're not matching it up to any existing video, so I'm quite happy leaving it at 24 frames per second. At any point, you can pause the video and we can play it backwards. And you can pause the video and play it forwards. Now you'll notice as I was hovering over there, it gives us a shortcut, which is Alt and A. So on the keyboard at any point, you can hit Alt and A, and it will start playing back the animation that we're working on. I'm so used to hitting space. It's not space, it's Alt. Now Shift, Alt and A will play it backwards. So Shift, Alt and A will play our animation backwards. And Alt and A will stop it and play it forwards, and stop it and play it forwards, and then we can go backwards and forwards as much as we like, looking at the animation we've made. Or we can just click the pause button down there. Great! One final consideration to make, when you work at a higher frame rate, i.e. FPS here, so we're at 60, there's going to be a lot more work for your computer to do when rendering in order to get your animation out. Because it's going to have to, in this case, do over twice the amount of work. In this case, it's going to have to do over twice the amount of work if we set it to 60 frames per second. And one thing you do not want to do is keep hopping between frames per second, because it will change how your animation looks. If you've set up your animation when it's at 60 frames per second and you essentially slow it down to 24 frames per second, your animation will get a lot slower. In fact, it will be over half as slow. Now, if you go the other way, if we set it 24 frames per second, we do our animation, and then we go back in and adjust it to 60 frames per second, it will go over twice the speed. And so once you need to set this right at the very beginning. You can't realistically go back and change everything. So make sure you get that right from the very beginning. Okay guys, it's challenge time. I'd like you to set the animation time to 5 seconds. So leaving the frames per second, the frame rate, at 24 frames per second. Set the start and end frame so that we will have a 5-second animation. Pause the video now and give that a go. Welcome back. Let's hop straight on over into Blender and solve this little mathematical problem. Okay, so back over in Blender, let's just make sure here the frame rate is 24 frames per second, which it is. Brilliant. Now a 5-second thing will be 5 times 24. Well, a 10-second one will be 240, so a 5-second one will be 120. So now we've got it on 120, we can see here, we can either change this end value here to 120, or indeed go to frame and set the end frame here, or press E. And there we go. We will now have ourselves a 5-second animation. And if we count 0, 1, 2, 3, 4, 5. Perfect. Now, of course, you can set whatever one you like, but for the purposes of this exercise, I want to keep it as short as possible so we can see our result as quickly as possible. If you set it at a 5-minute animation, the render time is going to be astronomical compared to a shorter animation. So we'll be also working with our animation shortly and constraining it to those 5 seconds. Excellent, so we've got the time frame set. In the next lecture, we're going to be starting to animate our lamp, bringing it to life. I can't wait. See you soon. Welcome to keyframes. In this video, you will understand what they are and how they are used. Be shown how to automatically add them and remove them from the timeline view. Realize almost anything can be keyframed, and be able to use keyframes to animate your lamp. So let's hop straight on over into Blender. Right, so let's start adding some keyframes. But before we do, just in case we end up, as we're experimenting, make a big mess of our animated lamp, let's hop over into a brand new Blender file and play with the default cube. Right, so I'm going to need the timeline, so I'm going to bring that out. I've changed my default file so I don't have to have the timeline there every time. Now, I'm not going to worry too much about the length of the timeline or anything along those lines. So, what is a keyframe? Well, a keyframe is simply a moment in time in our animation. So let's just set a keyframe really quickly. So first of all, I'm just going to hide this area here. So we've just got our 3D view in front of us and our timeline. So I'm going to click the record button here, and initially it won't do anything. However, the moment I do anything in our scene, even just move the cube ever so slightly, it records a point, and we can see that on the timeline now there's a yellow line just here on the timeline. That indicates that that particular moment contains a keyframe. Now let's say we go to frame 30 and move the cube up here and across a little, and then at frame 60 we bring it down and across a little again. Now we see that there are 3 main states that the cube is in. There's its starting frame, this keyframe here, and this one here. And what keyframes allow us to do is simply smoothly transition between those keyframes automatically. You imagine if you had to do that by placing it and setting it and placing it and setting it 60 times? That's just not going to happen. So keyframes allow us to do things with a certain amount of automation. And keyframes are those points where, let's say here, we reach the top of our jump and then we start descending again. Now keyframes can apply to literally anything and everything. And in Blender, any fields that you have can be adjusted. So let's open up this area here and let's hide those again. So you can see here what all the areas that are highlighted in yellow are ones that are actually being keyframed at this point. So sometimes you end up with individual ones, other times you end up with whole groups. So you can see that the scale is highlighted, but it doesn't actually change from frame to frame. And on the keyframe, they're yellow, and in between it guesses some numbers, so it's a smooth transition to the next keyframe. Now what we could do here is on frame 30, for instance, we can go to scale and make it longer. So in the z-axis, we can make it a bit taller. And then as we're jumping up, it stretches ever so slightly. And then by the time it comes back down again, it's not stretching. So there's loads of different things you can do with these keyframes. Now, if you want to delete one, say, well, actually, that one at the top there, I don't want. It's not going to go up anymore. It's just going to go along this y-axis. Then down on this set of keys down here on the timeline's header, we can click that and select certain types. In this case, I'm just going to go available, so it removes all the settings that we've made at this particular point. And then we can click the little key with a line through it, and that will remove the keyframe at that point. And then the cube will literally just slide along between these two keyframes. And of course, this will apply with everything. So with the record button on, if I lift it up and rotate it, it will then graduate between those positions, rotations, scales, pretty much anything and everything. Very, very powerful. Okay guys, it's challenge time. I'd like you to use the knowledge you've just acquired to animate the lamp. So animate the lamp using automatic keyframes. Do stick to that 5-second animation and remember to have fun. What poses can you come up with? What little jitties can you make your lamp do? Pause the video now and give that a go. Okay guys, welcome back. Let's go and animate our lamp. Right, so let's hop over to the animated lamp. Okay, so we've got our animated lamp here, and I want him to, or her, I don't know. Anyway, I want it to hop along our wall along this way. So at the moment, our default pose, if I select everything and reset the rotation, is actually facing the wall. So the first thing that I will want to do, looking at my hierarchy and everything, I'm going to be moving this base. And if I just move it at the moment, the rest of the lamp will stay still. I need to parent the lamp rig to the base. So if you haven't done that, you may have struggled with working out why that wasn't all moving together, but that's fine there. Finally, I'm going to go into pose mode here. So let's select where is it? The lamp rig. We're in pose mode. I'm going to grab this lower bone and rotate it by 90 degrees. Yep. Then finally pose. And then, being blind, apply the pose as the rest pose. That's fine. So, let's scoot round to the front view. I think it's front view. Either front or back. Yep, front's absolutely fine. And I'm going to do this in this orthographic projection. So, the first thing I want to do is make sure that the recording of keyframes is turned on. And I'm going to have a couple of frames of something. I'm just going to set that to 0, 0, 0 at this moment in time. I don't really want to lift that up there. There we go, the base. I'm going to set it as 0 there. Or just lift it up and then set it back down to 0. There we go. So we've got our lamp down at 0. And then something's going to happen. And it's going to end up over on this side over here. So it's going to probably jump up or something and then land back here. So let's just see if that distance is right. That's probably a little far. So let's go to here and perhaps back here. And I'm just trying to make an arc down to here. So there, and then midway between here and here is about 150, but you tend to fall quicker than you jump. So I'm going to scoot it just a little bit further this way. I'm going to start the jump around here. So I'm going to set the 3D cursor around this corner. Set the pivot point to the 3D cursor and just tip it forward ever so slightly. And then we'll have it going forward, but also that's going to have to go up a little. Otherwise we get this kind of sliding effect. And the top of the animation is going to be, let's take that back to the active element, lift it up. Now, is that too high Or indeed, has that just passed through something? No, that's just our plane. So let's turn the plane off so I can't see it. All these things in the way. Lighting plane, there we go. So whiz back round to the front view. And zoom in. I'll zoom out, back out again. I need to see what's going on, of course. So we're starting down here, we're jumping up, and we're landing about here. And a lot of this is just done by eye. I'm sure if you spend a lot of time, so that's actually going forward there before I want it to. In fact, here, I really want it kind of rocking back first. So I'm only starting on this base, by the way. We can move on to other bits and bobs in a moment. So let's zoom in down to this base and just focus on it a little closer. Have to zoom in there because the 3D cursor itself, I couldn't set it because the red arrow was in the way. So let's start here. Let's move forward a couple of frames and rock backwards first. Let's get our lamp leaning backwards as well, and we're in pose mode. So we've got it going backwards. In fact, we don't have a beginning of our pose. So let's have it in a more static position first. Then it leans back. And about there, we want it leaning forward. So let's lift that up. Perhaps not that much, otherwise it's going to be a violent move. Forward, and then we're going to lift up. And of course, as we come down, it's going to want to start to crouch. Ready for the landing, which happens, let's move round to there. So let's really move that back here. And then finally, oh, we haven't done the final bit of the animation there. So that, let's move it down a little bit more. Let's get the lamp rocking forward. So I need a pivot point around there, first of all, to rotate it back down to nothing. A few seconds later, it will rock forward. A few seconds later, but these are going to get closer and closer together. So we end up with this rocking effect. And then a final rest position where it's flat. Again, I'm just doing this by eye. And then finally, let's hop over to the posing itself. So we've got it landing. And that's going to start coming forward. And as it starts going back, it's going to stretch out to prevent itself from toppling. And then into our final rest pose. So I'm pretty much doing a 2D animation here, only in one plane. But of course, I'm going to get rid of that marker. It serves no purpose. So let's just see how our lamp is looking. There's something very weird happening at the beginning. I'm not happy with that at all. Because it's rocked back, it's lifted up, and we don't want it lifting up at this point. Okay, and it's moving forward to here. I don't want it moving forward at all. Oh, I've selected the wrong thing. Make sure you don't select the wrong thing when you intend to move items about. And let's pull it backwards. Let's just see. That does look ridiculous. But of course, you can play with this to your heart's content and get it just right. In fact, at this point, I'm going to delete every keyframe that's available at that point. So we've got it going up, and I just want it flying forward before it takes off. So it's here, we're rocking back. Let's have it rocking forward again before it goes into the sky. Let's rotate that round. And it's moved forward ever so slightly. So you do have to be really careful because it's moved forward there. It just looks a bit silly. That's a bit better. Let's just play that and see how it looks. Wow, it's low gravity by the looks of things, so I haven't it rocks lots, and then very big slide through there and going down there. Now, there are certain things we can do to tweak that, but I'm quite happy with that for the moment. And one final thing, at the top of that, I am going to just get the lamp to look at us. So I'm going to grab our pose position here, and I'm literally going to grab him to look round, but just the head. Just want the head looking. See if I can grab this in, let's zoom in. Our perspective mode probably isn't helping with my zooming here. Let's get him to look. Well, where's the camera? That's the first question. Well, we can sort that out in a moment. Yeah, that looks good enough. Let's go back round to the front. Just rotate it round a little bit more. Let's just see how that looks. So he jumps up, looks round, and swings his head back round for landing. Perfect. That's looking pretty good. Let's just see how that looks with the rig turned off so I can see our model. So let's turn the lamp rig off. Let's just have a look at that playing. So start animation. I'm struggling for screen space here. Start animation. So you're going to jump off the screen. Yep. So let's just see if we can lower that down a little. And of course, it just loops round and round and round. So I can probably just pull that up a little. Excellent. I'm liking our animated lamp. Now, of course, before we can go and share this with people, we need to make sure that we can export and not have our computer taking a small lifetime to do anything. And we'll cover that in the next couple of lectures, so you can start sharing your animations with people. Take care, and I will see you in the next lecture. Welcome to setting up the camera. In this video, you will understand that the camera view is for our animation rendering as well as our normal rendering that we do. We're going to set up the camera, ready for the animation, and also animate the camera. So let's hop straight on over into Blender. Okay, so we have our animated lamp that's jumping about here, but of course the way that we're currently viewing it, the view that we've currently got, is nothing to do with the rendering. If we go over here and click Render Image, you'll see what actually is going on. Okay, so before we go any further, there's something really weird going on with this base here. This is not the view we want for our animation, but this is neither the base that we want here. So let's go and troubleshoot this really quickly. Now it looks like geometry is going over the top of one another, yet in the 3D view, when we render or set the viewport shading to rendered, we don't get that issue. So something that's turned on in rendered mode is not turned on in our view mode. I'm guessing, actually looking at the outline here, I'm guessing it's probably these two curves are still rendering. We can see here they've still got cameras on them. So the base curves that we had before, if we turn those two off and just render our image again, perfect, that artifact has gone. So it's a good point just to highlight here that before we go and animate anything and do 120 different renders, let's just make sure one of them comes out right first. And I'm happy with that, but I'm not happy with how it looks. So we need to move our camera. So let's hop straight back to the 3D view. Okay, and let's turn on some of the other lighting that's going to be going on here. So we're missing the plane at the back. So let's turn that plane on. Right, and hop around to where the camera is. So view, camera, or number pad 0. And this is what the camera can currently see. Well, not all that the camera can currently see. I'm going to need to zoom out a little. There you go. That's what the camera is currently seeing inside that border. Now that's not an inspiring view, and we want to move the camera around. And the camera is just like any other object. First of all, in the outliner, we need to check that it is actually visible in our scene. We can see that it is not. And if we try and select the camera and do anything with it, try and move it, well, we can move it up here in the transform pane, that's absolutely fine. But if we try and use G and move it without it being selected as visible, it won't do anything. So it depends which tools you want to use. We've got keyframing still turned on. Notice this is all gone yellow. Now we may in fact want to keyframe it anyway. So let's move it around to its starting position. So I'm definitely going to want to rotate it, not like that, around its own z-axis, maybe about there. Now this plane that's emitting light for us is likely to end up being in the shot if we leave it like this, and we don't want that. If we go if we go render image, let's see as that comes out. Yes, that plane is going to be in our render. And I don't think we can just turn it off in the render because then we'll lose the light from it. So let's just try that and go and click on render. As it comes out, you can see the scene's much darker. So we can't just hide it from our render because it needs to physically be there in order to emit light to make our lamp shine. So we're going to have to move the camera ever so slightly closer. So I'm going to hop straight back down round to the 3D view. And we're going to use these transform here just to adjust our view ever so slightly. I do actually want to be a bit closer to the lamp. So there's fine. I'm just going to grab the camera and move it there. And let's hop into non-rendered, just solid view, and just play our animation and see how that looks. Okay, that's looking good. We can see here that the animation is slipping back ever so slightly before we go. So let's just go to this part here, and then we don't want the camera following us, so we just need to shift it back slightly. So on that keyframe there, since I am going to animate this, I can just move it back ever so slightly like that. Let's see how that looks now as we shift through. Yeah, that's still in frame. And it's actually still in frame as it jumps at the top. So let's see if we can zoom in a little closer. So let's change the... What is it going to be? Z goes up and down. So I'm going to have to move it down slightly and then move it closer to the camera. And probably this way as well. Now I need to rotate it. So let's rotate it round a little this way. Don't need to do it that way, and I will have to look up slightly because I'm going to lower the camera down to here. Got to pull it back here, and there's lots of adjustments you can do here. There's no right or wrong for doing this. I'm just setting it up how I think it's going to look quite good on the final render, and that's going to go out of shot, but that's fine because we can adjust and keyframe in some new camera positions as we go forward, and obviously that's going to fly off the end of our scene there. Brilliant. So we've got the first stage, we've got the first keyframe all set up, we've got our starting position for the camera all set up. We'll just do a quick render again to make sure it's coming out how we want it to. Perfect. That's great. If this render here is taking a very long time, remember in the rendered options there are some settings that you'll need to do. And if I scroll down, 64 by 64, well, for a start I know that 16 by 16 is going to be slightly quicker. Now this is not going to be a fair test. We've got 2 minutes 26. If I render again like this, it's probably going to be very close. 2 minutes. Okay, it's taken longer in that case. But it's too close to call at those low levels anyway. So the other thing, of course, is scrolling up the samples here. We've got the render sample set to 10. Now, I suggest you do leave that down low at the moment. If you increase that massively and find there's a problem, like we had that base problem, if I hadn't rendered it there and missed that, again, being lean, make sure you render it quickly. Well, we're about to render 120, so 120 times 3 seconds is several minutes of waiting. However, if we set that render samples to 1 just for a test render and then hit this, we can see it's very grainy, but it's done very quickly. And if we go ahead and render out an animation like that, which I don't want you to do just yet because it's not going to come out how we want it because we haven't set it up for exporting like that yet. We're just dealing with the camera. It will render very quickly anyway. And of course, once you've got the animation right, you can turn these rendering samples up as high as you like, is depending on how long you have to wait. The higher that is, the better the image quality is going to be until you get diminishing returns. But anyway, I've got a challenge for you guys. I would like you to set up and animate the camera. So set up the camera so our lamp is in view the entire time. Animate the camera to keep our lamp in view as it's jumping about, and then have fun. Try different angles, see what you come up with. I'd love to see your animations as well, but we're not quite ready to export the animations. Hold on, and we'll deal with that in the next lecture. But for now, pause the video now and set up and animate that camera. Okay guys, welcome back. Let's hop back on over into Blender. Okay, so I need to hop straight on to my 3D view once more. Now that we're here, the camera needs to really be rotated upwards so we can see it. Now, at the lamp's highest point, which is around there, I'm going to move the camera up. Well, actually, I'm going to look up. So I'm going to move the camera along so it's kind of following. And let's see, if I rotate, I think it's X, yeah, to look up. And I can even move the camera in ever so slightly. Brilliant. So let's just see how that looks. So the camera should follow us here. Now the base goes slightly out of shot, but am I happy with that? Yep, that's fine. And as it goes down to land, obviously it's nowhere near our lamp. And I would like to be looking back. I've decided I want to look back on our lamp. So before it lands, so I can see it lands about there. Before it lands, I want the camera already in position. So it's going to be around here that the camera needs to be there. So I need to rotate it round to look down our scene. And this is the X coordinate, I believe. So let's pull it out. Let's move this in. And the camera down. So let's see how that looks as it swings round. Because the other thing we need to bear in mind is if we're animating the camera, does it make sense? So let's look there, and then the camera's being pulled round. Now I'd actually like it to be looking down on the scene at this point. Part of the point of having this lamp is that it's shining a light on the floor. So at this point here, we come to here. I want it to be looking down, so let's rotate the camera. Let's pull it down here and then lift it back up. So how does that feel as we pan across? Go across here, and then we go out for a wider shot. Perfect. So the final thing that I would do here is I would just pull this camera perhaps a little bit further down, even rotate it round, rotate just a little bit more. Oh, that's a bit too much, because I want to see the spot that this is doing. So let's just run through that from here, comes around and pans out. Perfect. Excellent. How did you guys get on? And shortly you'll be able to share your animations with the rest of us. Take care. See you in the next lecture. Welcome to Rendering an Animation. In this video you will learn how to render your animation, how to stop the rendering, what settings to use for good results, and how to preview an animation once it has finished rendering. So let's hop straight on over into Blender. Now, some of you observant students would have realised that under the render menu there's this button called Render Animation with the shortcut Control and F12. Now, don't touch it, because we're not ready to render the animation just yet. We need to do some setting changes first, especially as this is our first animation. So, what to do? Well, first of all, let's go over to the render properties and look through this. So we've got a lot of options here. First of all, your device that you're rendering on. If you've worked out that your GPU is faster than your CPU, make sure it's on the GPU. Scrolling down a little, under dimensions, we have the resolution and the percentage of final resolution. So this is going to be 50% of 1080p essentially. Now, obviously, the higher that is, the more resolution there is, the higher the image quality is going to be. However, it's also going to take longer to do. We're going to leave the frame rate as it is. That's absolutely fine. And if we scroll down here, we have an output folder. Now, that is very important. That tells Blender where it's going to put your information. Now, contrary to what it feels like down here when we select on what to save it as. At the moment it's PNG. And we go, oh, there's lots of video options here. Surely we select that? The simple answer is no. The reason for that is it's much better to make your animation an image format, so you end up with, in this case, 120 images, and then compile them into one single movie later on. If for whatever reason you do decide to use one of these movie options, and then later on during this 5-hour render that you're about to do, something goes wrong, you have a power cut, anything that stops the render will kill your file completely. However, if you had finished off rendering 50 out of the 120 frames, and you would have 50 pictures on your computer. And so if your computer crashed, Blender crashed, you lost power, whatever reason, you don't have to worry, because on the next time you change this value here, you change the start value to 50 or 51, and you'd carry on. So there's a great reason for not having it render straight to a video. It also gives you more control doing it this way. And there's an additional benefit which we'll go over in a couple of lectures time, where you render across multiple machines. Very powerful. So the start and end frames are very important. That dictates how long the rendering is going to last for as well. We just hinted at that there. So anything beyond, any animation beyond the start and end or before the start and end won't actually make it to the final render. Of course, it's the camera settings as well that dictate what is being seen. Now, one final thing, and we've touched on it when we did our render tests earlier on, so we scroll all the way down to where it says performance. Now, you'll want to set this appropriately for your system. So, because I'm using a CPU, generally the smaller tiles are better, and you'll need a much larger tile size if you're using a GPU. Again, if you've not done the full test, I do suggest you do that, because now that we're rendering an animation, it's going to take several minutes to do. So now that I've got it to 16 by 16, I'm happy with everything else. Let's go to sampling. I'm going to do a test render to begin with. So on this samples here, I'm going to set the render level to just 1. Okay, that's good. Let's go up. Let's select an output folder. I'm happy leaving it as the temp at the moment because it's just an example, but you can go into here and select a specific location to store your animation on your hard drive. Now, when we come to do our final animation, we'll actually pick a folder that isn't buried deep in your system. In fact, the temp folder itself is quite hard to get to on a Mac, a lot easier to get to on a PC. So in this case, I'm going to literally I'm going to put it in my downloads folder. I'm going to create a new directory there and set it as one sample lamp. And this is literally just to get a feel of our animation. So with that selected there, we can go ahead and go render and render animation. And we can see that because we've only got one sample, it is very quick to render out our animation itself. But it's still going to take several minutes. It's going to take at least 2 minutes. So I'll let this whiz ahead and I'll join you in a moment. Okay, so we're halfway through our rendering, and one of the things that I've noticed after watching this is because there's no reference material in the background, I'm not sure whether we know by looking at this whether the lamp is actually jumping at all. But let's let that be gone. So I'm just going to stop the rendering at the moment, and there's a little cross here that will stop the rendering on the info header bar, and we can click that there and it just stops in place. Now, if we go into our operating system, and I'm just going to find the sample lamp folder, bring this down for you, and we can see, oh, there's one PNG. We can actually go through these. I didn't mean to open that, and I'm down to 78. So at any point I can just continue from 78 onwards if I wanted to continue this particular render. So in the render menu itself, I can go to play rendered animation, and it will play where we got to. And then it will stop and repeat. Now we can see here there is a reference there's just this thin band at the back. So perhaps in this case, I'm not going to add anything to our scene at the moment, but it just tells you here, even on this very rough and very grainy rendering, that there is something probably missing to give the viewer, the person watching this video, a clue, even though there is a dark band there. Now, I don't know with more samples whether that's going to be more prominent. It's certainly obvious that it's jumping as soon as we swing round and see it landing again, but I'm not sure if it is at the moment. Anyway, so that's all of our stuff done. We've got a series of pictures. I'm just going to continue rendering this out. Where did we get to? We got to number 78. So if you need to stop for whatever reason, the great thing is here, I can continue, and I'm just going to check 78. It's a whole picture. That's great. So I'm going to finish off the rest of my rendering by going down to here and typing in 78. Now, once I've typed in 78, I can just go back to render and render animation, and off it goes and completes the rendering. Excellent, so the render's just finished, so we can hop back onto render and play the rendered animation, see how that's come out. And of course, it's just going to play the last bit of our animation, which looks absolutely fine. Brilliant. So we have a quick look after doing that rendering. We see that there are 121 items in here. There's 121 pictures. And as we can see, if we scroll down, they are of our lamp jumping. Excellent. So we've got all of our 121 frames all rendered out. And that means for you guys, it's a challenge time. I would like you to render a trial animation. So set up a one sample test folder to save to. Set your render samples to 1 and render your animation. Preview your animation and make sure you are happy with it. Pause the video now and give that a go. Welcome back. How did you guys get on? Did you have to go back and make some adjustments? Are you happy with that render, with that trial render? If you're not, if the camera's in the wrong position, if your model looks a bit odd, if you want to move something, do something else, now's the time to go back and make those alterations before we go ahead and render the full animation, which may take several hours to do. Right, so I might as well take this opportunity to go back to the 3D view, because one of my concerns was that with the background being so smooth, we might not actually be able to really grasp that this lamp is jumping up in the air. So I'm happy with the end in the start location, but this I'm not happy with, because it doesn't really convey that the lamp is actually going upwards. I could put something in the background that might help for reference, but in this case I can also help by just adjusting the camera. So let's pull it back down to the ground plane and zoom out slightly, and we can zoom out by just moving. Oh, that's rotation, not location. There we go. And let's pull that across a little and perhaps up so it's still in frame. Let's just see how that looks now. So let's play that animation. Oh, we're not at 0, so let's set it back to 0, so it's jumping up. Right, that peaks just above the frame. I do want to keep it inside the frame, so let's just stop that from playing with the right key combination. So it jumps up a little bit there. So if we raise that up, which is Z, ever so slightly. So that's wonderful there and here. And perhaps I will make this just a little bit more dynamic by starting slightly behind our lamp. So I'll start here, but this time rotate it round. So I'm starting like this. In fact, the lamp is still going off there, so we're going to have to pull it this way just a little bit more. Right, let's try that. In fact, let's go down a little and just push it in a bit closer to the camera. So does that go off the camera? No, that's fine. Jumps up, stays in frame. That gives a much better impression of height. Okay, so I've made the changes that I like. I'm going to create a new folder. So let's go up a directory. I'm going to store this in my downloads for temporary use. I'm going to call it one sample test 2 lamp. You can call it whatever you like. And I'm going to accept that as the location. And I'm going to hit render animation. And I'm going to go make myself a cup of tea whilst that renders out. Okay, so the render's all done. Brilliant. And I've got a lovely cup of Earl Grey. How did you guys get on? Please keep your renders, your test renders that you've currently got, because not in the next lecture, but the one after that, you'll be able to export this to a movie to share with everybody. Brilliant. See you in the next lecture. Welcome to rendering across multiple blenders. In this video, you will use multiple computers to render an animation. Learn how to use multiple instances of Blender to utilize the CPU and GPU on your computer. And finally, decide on how many samples for the final animation. So let's hop straight on over into Blenders. So first of all, let's decide on how many samples our final render is going to be. So looking at our scene in front of us here, that is just with one sample, and that is quite grainy. That would be unacceptable for a final render. So we need to simply up the samples count and see what we get. Now in the 3D view itself, if we can hop around to the camera position at this point in time, we'll see roughly what the camera sees as it pans round. So if I go to that end state there and go to camera, that's the scene that we can see. And I'm going to set my render border kind of like that. So I'm going to hold down Control and B and just go around our lamp there. I don't want the whole scene being rendered, just that area there. I'm going to switch on rendered view after I've gone down here and changed our preview. I've had it set to 100 and changed it down to 1. And I'm going to go to rendered. So this is roughly what it looks like at the moment. And you can simply keep on increasing the preview samples here. As long as you don't move the viewport at all or resize your windows, it will just keep adding the samples to it. And we can see at the top here of the viewport, it's a sample 4 of 4. So you can get a feeling, if I go and set that at 50, let's say, it will then render out to 50 samples and we'll get a good impression of how that final render will look. Ultimately, the more samples you have, the more and more detail you will end up with at the end. Now, that has to be weighed off against the time it takes to do the render. If this was a presentation render, then obviously you'd want to spend as much time as you physically got doing it, or a final render for an animated film or something like that. But in this case, we've got to make a decision as to when the sample rate is high enough. Now, whenever I've done things in the past, I tend to set it greater than 100, to be quite honest, maybe in 200 or 300. And if you're really working on something that's got a lot of detail in the scene, perhaps even glass or something along those lines, you'll want it even higher than that to just get the clarity out. So it does, of course, depend on your scene itself and how detailed you want to be. So we're at 50 at the moment, and if I increase that to I don't know, let's go up to 300 and just let that render out in the background. Now, if you want to speed things up when you do the rendered animation, you can do something quite clever. Now, it does depend on the speed of your computer, how you pass all this out. So I know that my GPU is slightly slower than my CPU on this particular computer, and I can utilize both of those. So we'll cover that one first. I'm loath to interrupt this, so I'm just going to let that render out to 300 and see what it looks like, and join you again in a few moments. Okay, so looking at 300 samples, that's pretty neat. There's very little noise in the scene that I can see. There's a little bit around the lamp base, but I think that'd be absolutely fine for me rendering at that, without, of course, waiting weeks and weeks and weeks for the render itself. Okay, so with multiple instances of Blender on one computer. Now, if you've got a dedicated graphics card in the computer and it works with Blender, then you will want to do a test render just with the GPU, and we'll do that now. So we've got this scene here with 300 samples. Of course, it's going to resample in a moment, and I'm going to switch across to GPU compute and see how that comes out. And we can see it renders it pretty much exactly the same as our CPU does. So I'm happy with that. So I'm going to switch that back to CPU for the moment. And I'm going to get really cramped on the screen. Please bear with me. I'm going to save this file that I've been working on, and I'm going to go half screen with my work. I'm going to open up another instance of Blender, and I'm going to shove that over the other side of the screen. And it's very, very tight on here, so let's just see if we can make it a little bit easier to see. And there we go. I'll save that file there. And I'm just going to turn off the rendering at the moment so it doesn't start rendering automatically. Resave that. So over here, I'm going to open up. This is a separate instance of Blender. So now we've got the same one across multiple instances on Blender. Now the secret here, well, it's not really a secret, but shh, don't tell anyone. The secret here is to literally, on this one computer, I would set the start and the end as perhaps 0 to 80, knowing that the CPU is faster. And on this side, I would start at 81 and end at 120. And therefore, both sides are going to be doing their own thing. I'm going to set the device here to GPU, knowing that this side's going to manage it with the CPU. So we can have a look at that across there. So CPU and GPU. And then finally, I can literally just go to render. Well, let's set it up here first before we do that. Before we do any renders, we need to change this to 300 as we set before. And the same on this side. So the render samples are the same. Okay, if you had set that before opening up the same file, the settings would apply. So just to follow good practice, I will quit the one that I've been mucking around with, save this file over here, open up another instance of Blender, and I'm going to open up our animated lamp file again. And that makes sure that any of the settings we change on our actual main lamp are reflected across here. And then finally, if I just scroll down, yep, samples are the same. In fact, it should be exactly the same. Start and end. So the start and end on this one is 0 to 80. And then finally, across here, we've got the start and end at 0 to 80. So we'll want this one 81 to 120 was our last bit. Excellent. So that's now ready to render. And if we simply went... well, no, it's not. Before we do that, it's very tempting to just click render. Let's make sure the output folder is the same. Up the top here. So I'm going to just go up here, and I'm going to create another directory and go lamp 300 final. That's absolutely fine. I'm going to select that and accept. And I'm just going to start the render going over here. So render animation. So that one's started going. Now, there's a couple of things on the GPU that we need to change. So I'm going to change my tile size here so it's slightly larger. I can't remember which one was good, but I think 256, 256 would be absolutely fine. I'm going to make sure we are using the GPU. So that's set there. And then finally, we just need to make sure it's directed to the right folder. So in downloads, lamp 300 final and accept. And then when I hit render and render animation on here, this one will be dumping from frame 81 to 120, and off it goes. Now you can use the same principle across multiple computers. So if you were sharing files via Dropbox, you could literally save the files in the Dropbox, and when all the computers have finished rendering, there you go, you've got your PNGs in this case ready to go, ready to make into a movie. So if we were using multiple computers, again, I would divide them all by the speed. So you'd have to work out the relative speed of each computer. And so in this case, we can see that it's going to take about a minute to do this rendering here, and it's going to take slightly over a minute to do here. So I know to split it up in this sort of 60-40 principle. But I've got another computer in the office just over the way. If I go and get that, I know that is slightly faster than the computer I'm currently working on when it comes to rendering, but it's only got CPU. So if I was utilising that one as well, I would set it to 30, 30, no, not 30, 30, 40. It would probably be more like 50 CPU on this machine, 50 on the other machine frames, and then 20 frames on the GPU. And it probably finish off the GPU quicker than anything else, but that's absolutely fine. I don't mind if that's what happens. So we just leave it now to render out, and we end up with our polished scene at the end. Okay, so one quick final learning that I almost overlooked. Now the screen's slightly different. You remember earlier when we were looking through the camera and we set up a render border in the camera itself. Now you will notice that if we had actually gone through and rendered the image, that it's no longer this 16:9 aspect ratio that we're used to having, especially since that itself, if we scroll up here, is the dimension of the render. Now, when you have it set like that, that render border, it affects the final render too. So I'll cancel that now. Let's go back and see. This red render border that we applied whilst in the camera view will actually change what comes out on the final render. If we set one up anywhere else, so if we rotate round here and set another one up, that won't matter, that won't change it, but the camera one has a separate render border. So before you go ahead and render out spend hours rendering and find out you've cut off the edges of your scene, I do suggest you clear that border before doing so. I just spotted it watching them render. I didn't see it when the screens were condensed like that. So Control Alt and B will remove that from our scene, and I'll just quickly do a quick render test, and we can see there it's back to a 16:9. So I can crack straight on now and render out the animation. Okay guys, render the final animation. Set up your final render settings. Now you choose the number of samples. I'm going to use 300. If you have a dedicated graphics card, a GPU, try using multiple instances of Blender to render. Now, caution, this will stress your computer. Now, I say caution here because if you've got an overclocked computer, or you live in a hot country, or your computer generally runs quite hot, you may find that doing this will overheat your computer and potentially crash it. So do this with some caution, or certainly if you've got adjustable fans, turn them up. So more computers. Well, render the frames across multiple computers to speed the process up. Only if you've got access to them, of course. Bring all the pictures together, those PNGs, into one folder after they're done. So Dropbox, OneDrive can do that automatically for you if all of the computers share the same account. But otherwise, drop them on a memory stick, bring them across to the other computer. So go ahead and render your final animation. And atypically, I will not be saying pause the video now and go ahead and do that. Just go ahead and do that. I'm not going to come back to you after this because it's probably going to take you at least an hour, if not longer, to render out this animation. Take care, and I will see you in the next lecture. Welcome to creating a video of your animation. In this video, you will be introduced to the video editor. Combine your rendered images into a final video, explore the various exporting options, and export your images to a movie file. So let's hop straight on over into Blender. So over in Blender, we've got our lamp all rendered up, and we have a series of pictures in a folder on our computer. So the first thing I'm going to do is go to the very top of the info header, just here, and where it says, well, I've got mine titled Blender Guide. You may have yours set to default still. I would like you to switch it to video editing. Now, there are a few things that will appear in here. This here is the graph editor. We're going to ignore that, but we're going to be focused down here. So looking down here, this is the video editor, and it is this option here, which is the sequencer. The next one along is the image preview, which is this area up on the top right. These are both the same window, just a different view. So down at the bottom here, we need to make sure our start and end are set to the right amount, and at the moment it's set to 40. It needs to be up at 120. So that's that bit done. Now we need to go to add, and when we go to add we need to select image. Now you'll need to navigate to where your images are stored. I'm going to go find my animated lamp. So we'll have all of our PNGs that we've got in front of us here. And I want to select the first one and the last one and everything in between. You can also press the A key twice. Now I've got a couple of GIFs in my folder as well, so I just want to unselect those from our selection. So we've got 0 to 120. Perfect. Add image strip. You just want to click this button here. And there we go. They have been added to our sequencer down here. Now it looks like at the moment they're being added far too late, so I can just click this with the right mouse button just like everything else in Blender and move it, and when that's back down at 0 I can left click to place it. And if we run through that, if we just scrub through that there, we can see that our animation is playing in the top right. Perfect. Now that we've done that, we can go back over to the 3D editor view. So I'm just going to go back to my Blender guide, and in this case when we're back over here we can just go straight down and change PNG now to one of these movie files. I'm going to select H.264. That's a pretty standard type of video these days, so I'm going to select that one. Next is the encoding a bit further down, and we've got a series of presets. Now you will have to find what works best for you. On my computer QuickTime works very well. H.264 also works quite well, but the Mac doesn't recognize it. I have to use VLC, which is an external video player, in order to view it. So I'm going to select QuickTime itself. There are some other options down here, but I would suggest for the moment you don't play about with those, you just leave them as they are. So now you've done that, we can scroll up to the top of this window and you click on Render Animation. And at first it may seem like you're about to render the animation again, but you'll see very quickly that that's not what you're doing, because it never rendered that quickly before. And now it is rendering out our images as a movie file of a type, an H.264, as in this case a QuickTime using the codec H.264. And once that's finished, that will have placed a video in the same folder, so in our sample animation folder that I've set up before. And let's just let that come to an end, and then we'll go find the video. So just a couple of frames left. Excellent. So it just finishes there, done and dusted. On your hard drive now, you should be able to play back your movie. So let's go find that now. Okay, so I've gone into my 300 sample lamp animation folder, and right at the very top is a movie, and if I double click that, I can play back the movie. Final challenge for this section, I'd like you to create your 5-second video. So export your pictures to a video and share with everybody in the discussions. Of course, one of the questions you might have is, how do I get my video into the discussions? Well, one of the best ways would be to upload it to somewhere like YouTube and then embed that you've got a little share link when you do that, and you can share that on the forum and it will play within your post. Obviously, you can also upload it directly to Facebook if you're part of the Facebook group too. I look forward to seeing your work, and I will see you in the next lecture. Welcome to exporting your model. In this video, you will learn how to set up the FBX export and understand why we use it. Realize that your model is currently only suitable for Blender. The export doesn't fully work in the model's current state. So let's hop straight on over into Blender. Even though this and the following lectures are focused on exporting to other packages, you'll want to follow along even if you don't want to do this at the moment, so you gain an understanding of how things need to be set up, and also it'll give you a deeper understanding into how to set up a rig in a very neat and concise manner. Right, so over in Blender, you may be confronted with this if you were to open up your screen afresh. Now, don't worry, we're on the image/UV editor to do with Blender. Now, usually, obviously, you'd see something there, but because I've quit the program and come back in, it's opened up how it was last time. So I'm just going to go down here to the what was the 3D editor header and actually just change it back to 3D view so we can see our lamp. Now, if we export this, let's go through the options we've got of exporting. Now, if we go to File and Export, it gives a series of options down here. Now, there are various options down here. We're going to be focusing on FBX because it is a standard file that will work across multiple platforms, whether you need to import this to another 3D package or whether you're importing it into a game engine. So let's go ahead and click on Export. Okay, so we end up with our file management system here, and I've already got a file that I've been testing called Lamp Mesh Export FBX, so I'm going to click on that, and that's what I'm going to overwrite essentially. Now, down here in the lower left, we have a lot of different options. I suggest you leave the version alone. Now, applying units. What's going on here? Now, this is the orientation of our model. Now, I believe, I'm not quite sure, let's go and check which way forward is and which way up is. So let's just cancel that for the moment and hop around our model. Okay, so let's make sure it's in its default pose and nothing else. So let's go on the outliner here, select the rig. It's in pose mode, which is great. Just going to zoom in on a bit of our model. I'm in orthographic projection at the moment, so I'm just going to toggle out of that. Right, let's show our rig so I can move it about. Excellent. Let's select the entire rig. And just make sure that there's no extra rotations applied. Brilliant. Okay, so our model is it's actually looking backwards, so it's looking along the x-axis. To make that clear, if I were to look down the axis of X, which you can see the red arrow just here on the screen, that would be looking down X, that would be looking down Y. Now, of course, you're looking backwards, so that would be negative Y, and this would be negative X. So in this case, the lamp is actually orientated around this way, so the orientation would be as X is forward, and of course, Z being up. So let's go ahead and go to File, Export, FBX. Right, forward, X, and up is Z. Perfect. Now, a few of the extra ones down here, we've got the empties that you've got in the scene, the camera, the lamp. I'm going to leave all of those selected, so you're literally going to export everything that's in our scene. And we're going to leave all the other ones as they are for the moment. So I'm just going to click Export here. And that has saved the file. Now, do note, and this is quite important, that if you've already got an export file labeled and you go and export again with the same file name, it will overwrite it without asking you, are you sure? Now, these day and age, we're so used to the computer asking us, are you sure you want to do that? Well, if in this particular case, it's just going to overwrite it. So bear that in mind when doing exports. So just follow along with me for a moment as we go and have a look at our export when it's brought into two game engines. So I'll be pausing the video whilst these things load up, and let's just see how they come in. Okay, so I'm over in Unity here, and you'll have to bear with me because I'm not a Unity expert, but I know I need to import a new asset. And I'm going to go ahead and select my FBX file. Here we go. I found it here, and I'm going to bring that into our scene. And click and drag, and that will drop it in. As we can see here, something's gone horribly wrong. It's not looking at all like it should do. Aha. So things are all skew with and not where we want them to be. In fact, this has an animation along with it that if we play that animation, something's happening there. Oh, that looks horrible.
the base is moving by itself and it's on completely the wrong plane and everything else. So that's not very good. The lamp isn't moving, the rig's not attached to the lamp, lots of mess going on there, so that's no good. Let's see how it happens in Unreal. In fact, when I first tried to import this into the Unity engine, the lamp wasn't even attached to, the lampshade wasn't even attached to the rest of the body. So, not quite sure why it's actually come across quite as neat as it was, but it's still not right. Okay, so let's go ahead in the Unreal engine and just go ahead and import with everything as default. So let's import all. Got a couple of warnings along there. And, oh, there's lots of things in here. Let's go for the lamp if we can find it. Lamp mesh. Well, that looks like it's our backdrop. Lovely. That also looks like it's our backdrop. Ooh. Okay, so one of the lessons we can learn here is there's lots of things that can be imported. Do you need all of them? So the first thing I think we need to go and do is make sure that our model only has the vital bits in it. In fact, looking along here, our lamp doesn't even seem to be in the FBX file when Unreal reads it. So we need to sort that out. It's a bit useless at the moment. So, over back in Blender, the first thing we're going to need to do is make everything a little neater. So, all I want left in my scene is the lamp and its armature. I don't want anything else. I also want to make sure that any curve objects that we've created are solidified into a mesh, because we're going to need it to be a mesh object later on. I've got a challenge for you guys. Okay, I'd like you to simplify the scene. Save as a new Blender file and make sure you include the word export in that new Blender file just so you know what it's for. Make sure that any curve objects are converted into a mesh object. And then finally, remove everything from the scene that isn't part of the lamp or armature. Pause the video now and give that a go. Okay guys, welcome back. Let's hop straight on over into Blender. Right, so looking at our lamp, let's go ahead straight away and remove some of the stuff that's a bit further out. So we're going to remove the backdrop that's not part of our lamp. Ooh, before we do this, let's go File, Save As, almost rushed ahead, and I'm going to call it Animated Lamp Export. Save as Blender file. Animated lamp export at the top. Brilliant. Right, I'm going to delete this lighting plane as well. Now, I can't actually select that at the moment. I can select the lamp that it's parented to, but I can't select it because it is probably, here we go. No, not that one there. Plane here. I've turned off selecting in the outliner. That's what that little arrow means. Right, I can now delete that. I'm going to delete the camera as well. Now, in our model, let's have a look down here. We've got a couple of objects that are curved objects, the lampshade outline and the lampshade profile. Well, the lampshade profile is the one I care about. Let's select that and object convert to mesh from curve, or Alt and C. We've got that there in the... Here we can keep the original, but in this case I don't want to, so that's absolutely fine over in the operator panel. And I'm going to delete the lampshade outline. Excellent, so that's there. The spot lamp that's in here, I'm going to remove that as well. That's not part of the lamp. The lower arm has an empty associated with it, the mirror axis, that can go now as well. Let's see, any other... Nope, that's fine. We've got some old archaic stuff here, so the base curves can be deleted, the base curve outline can be deleted as well, the base mesh old can be deleted, and that leaves us, I think, pretty much with the only bits we need: the lamp rig and the meshes themselves. Excellent. How did you guys do? I hope you've ended up with a nice clean model, and I will see you in the next lecture. Welcome to Vertex Groups. In this video you will learn what a vertex group is,
assign vertices to a vertex group, and see that because we created our model in parts, it is really easy to assign groupings. So let's hop straight on over into Blender. Okay, so on to vertex groups. Well, vertex groups are a great way of grouping vertices together. And if we select, let's say, this lampshade at the top here and go to the object data properties. Now, this is a new one for you. It's this upside down triangle here with 3 vertices and some edges there. And we can see that there are vertex groups. And in this case, we can just create one here. And it's not very useful, called group. Let's call it shade, and let's work on the shade at the very top. Now, in order to assign vertices to this vertex group, we need to be in edit mode. So let's hop over to edit mode now. Let's press A twice. Oh, just once in this case because nothing else was selected. Everything is selected, and we just click here assign with a weight of 1. Now that weight is important. It means that these vertices are wholly and solely part of the shade vertex group. Excellent. Now we can deselect now and select everything as part of that. And just for playing devil's advocate, if I was to select a face in there, press plus and just leave it as group for the moment and assign. Now I can select my entire lampshade there, or indeed I can go down to group and select those 4 vertices that I've highlighted just here. Powerful, yes. My example, no. So let's get rid of that one that we've created there. However, there are a couple of other things that are part of this lampshade when it moves. This ball joint at the top is one, and of course we've got the little light source in the middle of it there. So let's focus on, let's hop out of here, select our lampshade joint, and we notice that the vertex group has disappeared. So it would be very useful in this case to have all of these linked as one object. So one thing I have noticed when doing this, if I were to select the lampshade joint, then the lampshade profile, then the light bulb inside, and join them together with Control and J, it actually goes back to its default position that we started modeling in a while back. And that's because the rotation of one of these is not set appropriately, and we'd need to rotate it round by 90 degrees. Now, I'm not going to faff about doing that because there are a couple of ways that you can get round it. And usually the simplest one, and let's try it now, is just selecting them literally in a different order. So I've gone light bulb, lampshade profile, and lampshade joints. So instead of going top down, I've gone bottom up. And when we join them, they're all one mesh object, and I'm simply going to name that mesh object shade as well. So now that they're all there, I'm going to go into edit mode, select everything, and let's bring the properties panel back up and assign them to shade, because shade is the one that's highlighted. Finally, to make sure that I don't make any mistakes and muck around with it, I'm going to put the padlock on. Okay guys, it's challenge time. I'd like you to assign vertex groups. So assign vertex groups to the rest of our mesh objects. Join them together where necessary. Name them appropriately. I suggest keeping it to one word, just to keep things simple. In this instance, keep the number of mesh objects the same as the number of bones, so consider joining mesh objects together where necessary. Pause the video now and give this a go. Okay guys, welcome back. Let's hop straight into Blender. Right, so let's go ahead and assign the rest of our vertex groups. So we've got 4 bones and 5 objects. Okay, so let's go ahead and just go down. So I'm going to hop into object mode, select the upper arm, select everything in it. I'm doing it in a slightly different order. I'm going to name this one upper, and I'm going to click assign. Excellent. I'm going to select the lower arm, hop into edit mode, select all of the mesh, add a new vertex group, and call it lower. You're getting the hang of this, I can tell. I'm going to lock it as well. Oh, did I assign? Let's just make sure I assign. And we can check that by deselecting and selecting. So that looks good to me. I'm going to lock that one. Hop into here, lock that one. Okay, so this bottom one here, the lamp base and the stem. Well, I'm going to join the stem to the lamp base in that order, so it inherits the name lamp base, so I don't have to rename the mesh. So let's join that together. Let's hop into edit mode and select all the vertices. I'm just going to go here and remove doubles, because I know at some point they're going to meet, and I think that's right at the very bottom. So let's remove 32 vertices, and then I'm going to add a new vertex group, and I'm going to call that group base, and I'm going to assign all of these vertices that I've selected to that. I'm just going to deselect and select to make sure it's there. Perfect. And I'm going to lock the group. Brilliant. How did you guys get on? We're almost ready now to re-rig our model, so not only will it look better in the hierarchy in a much simpler layout, we're also going to be able to export it to external packages. Take care, and I will see you in the next lecture. Welcome to re-rigging our model. In this video, you will unparent your lamp meshes and join them together, ending up with one mesh object. You will rename your vertex groups and bones so that they match one another. And finally, test your new rig. So let's hop straight on over into Blender. Okay, so before we go any further forward, we're going to hop into Object Mode. And we're going to select all of our objects, going all the way up to the very top or all the way down. It doesn't matter, because whatever we end up with, we're going to end up renaming it anyway, because it won't be appropriate anymore. So let's just join those together. Excellent. So they're all joined together now. Let's just have a look in the outline of where this is sitting. It's still sitting under the lamp rig. I'm just going to drop it to the left, click and drag, and clear the parent. Okay, so now that is clear, one thing I have noticed is that the normals of one section of it have been reversed. They need flipping back round. Okay, but now that it's one mesh, it can be a bit tricky to do that. Not so, because we've assigned vertex groups. And one thing you'll notice is here, now in the object data properties, because we brought all these together, all the vertex groups have joined together. So I'm going to select nothing at all, go to the upper arm, the one that's reversed, or just called upper in this case, and go select. Excellent. Now I can simply go to mesh, normals, and flip the normals to the right way round. Excellent. So that's now sorted out. They looked fine before. Perhaps I missed the fact that I've made it inside out. Anyway, that's now sorted. Okay, so now we've got this here. We need to rename vertex groups so that they match the bones, all the other way around. So let's start with the shade itself. So let's turn the armature back on so we can see it. And we've got a shade. And what's the upper part of our lamp called? It's just called lampshade. So I'm going to rename that shade. Okay, now that this and the actual part of the mesh is called shade, they should work. Well, let's go and try that now. We do need to add a new modifier to our lamp. So let's first of all call it a lamp, because that's what it is now. Excellent. So we've got a lamp here. Let's add a modifier and add an armature modifier. And I'm being completely blind. Let's just try that again. I'm not being blind. I had to scroll up. Low resolution and all that. Here we go. Deform armature. And underneath object, we need to set the object as the lamp rig and to vertex groups. Now there's one very important thing that did apply before and doesn't apply now, and we need to go into our bones. So let's go into the lamp rig, go to shade, and we want it to deform now. So in the bone properties here, let's scroll down. Deform is ticked. Okay, so let's grab this and see what happens. Excellent. The actual lamp is now joined back to the mesh. Perfect. So we just need to do that with the rest of our model. bet you guys know what's coming up. That's right, it's challenge time. I'd like you to finish the re-rigging. Make sure the bones are set to deform. Match names of bones and vertex groups. Don't mind which way you do it. It's just an exercise in this case. Obviously, with a larger model, you would probably want to be more precise with your bones named and not make them so generic. Otherwise, this rig will not work. And then finally, test your rig. Play back that animation. See how it looks. Pause the video now and give that a go. Okay guys, welcome back. Let's hop into Blender and finish the re-rigging. So this should be relatively straightforward. We need to now do a couple of things, and first of all I'm going to just make sure all the bones are set to deform. Excellent. So, set to deform, there we go. So now they're all set to deform, we just need to make sure they're all named appropriately, and hopefully it should just all take over. So we've got ourselves some vertex groups, so let's just go remind ourselves of what they're called. So in the object data tab, upper, shade, lower and base. So working from here, this one should be called base, then just lower, and then upper. Let's give that a test and see what happens. Hey, how about that? That looks pretty good and everything's moving about. Let's just test the animation too. Let's just press play. Oh, so he's looking around. Oh, looks like, oh yes. The reason why it looks a bit funny now is before we actually animated the base, and the base actually no longer exists. Whereas all the rest of the movements were actually the armature as well. So there's a learning point there, that sometimes if you redo your model, you're going to lose something. In this case, it was actually quite important. So we would need to go back in and do basically redo the base animation and get it right. It will take several minutes to do that. So I'm not going to do it right at this moment for you, because we've got to export this now and see how it is, and we'll do that in the next lecture. So see you soon. Remember to share your work, share your re-rigging. As you can see, the hierarchy now is much cleaner than it's ever been. There are two objects in our scene, the lamp and its corresponding rig, and it controls it perfectly. So share what you've got, and I will see you in the next lecture. Welcome to exporting the final model. In this video, you will export the model and test it, and just watch if you don't have Unity or Unreal installed, so you can see the process, so you can see what's involved if you're passing this asset on to someone else in your team perhaps, or someone else who's developing a game that you're working with them on. So let's hop straight on over into Blender and export our file. Okay, so one thing I did quickly do after the last video is just clean up the animation. I just made this little one here where he jumps up, spins round and lands again, and then it just repeats over and over. So I thought that was pretty good, just getting a little, perhaps a jump animation in. So now that that's all there, let's go ahead and go File, Export, and remember FBX. Now I'm going to find my storage location, so animated lamp export FBX. So let's export that now. Perfect. So let's go ahead and open that up now in Unity. So I've already got a blank scene open to save the crashes I had earlier and how to edit out. So let's go to import a new asset. I'm going to find my animated lamp export, and here we go. So now when we drag this into our scene, lo and behold, it's the right way up, which is pretty good. And also, I'm not going to attach it to the animation, just there we go. The animation itself has come in. I'm not going to attach that and muck about in Unity too much whilst I'm here, but that's all ready to go. I'm not sure if I press play whether it will do it. No, it's not set up to play at the moment, but I could go through and assign the animation, etc. to it. So let's see how that comes across in Unreal. Let's go and import. Okay, I'm not sure whether my Unreal editor is working or not. UE4, hello. Okay, let's just try that once more. Okay, there appears to be something weird going on with it. Bear with me and I'll be right back. Okay, I seem to have functionality back. Don't know what it was causing that. It might have been actually because I pressed play in Unity. Not quite sure, but here we go. Let's go and import our model. Let's go to the right thing. Animated lamp. Now the animation, I'm going to import animations here. Yeah, the animated time, that's absolutely fine. Let's go down here. Let's import all. A couple of warnings there, mainly to do with the fact that it's not got everything in there. So we've got a series of things in here, including our materials, etc. And we've got an animation sequence. And here is our lamp in our scene. How cool is that? It's coming straight away without any extra gumph on it. I'm not used to moving around in Unreal, so I feel like a 5-year-old. It feels backwards moving about. I'm sure I get used to that. When I'm moving to the right, it's moving to the left, etc. Wow, that's a bit different from Blender after you've been using that. Okay, so that's into Unreal. I mean, look at that. That's brilliant. It's got shadows and everything straight away. Wonderful thing, Unreal 4. Okay, so now we've got that in there. You can see when we've set up the model correctly, it actually imports correctly into other programs. And just out of curiosity, have I got SketchUp installed? No, not Sketchbook. SketchUp. So let's go and import and see whether... Oh, I will get to the right folder one day. SketchUp doesn't appear to support FBX. Never mind, so I'm not going to be able to import that into there. Worthwhile knowing and worthwhile investigating if you are going to move things between packages. See whether or not they are openable in the package you want to export to and use it in. Okay, so just as a side note, I've just been a quick experimentation, and it turns out that Collada files, it does support. It does also support 3ds, but it comes in completely wrong. The DAE or Collada file appears to come in absolutely fine. And, well, I'm going to go back into Blender now and just see how tall it is, because this person's going to be, what, 1.8 meters tall, something like that. So if we hop into Blender, let's see how scale comes across, because that is important. And we can see here that with these squares, if we zoom out, I can see, I don't know whether you can, that is about 1.6, 1.8. Perfect. How's that? That's a very, very large lamp. Anyway, I hope you guys have had fun in the lamp section. If you do have any questions, give us a shout. Please post your questions in the discussions. Share what you've done so far. I love seeing what you guys have done. It's really inspiring, and it inspires the other students as well. So I will see you in the next lecture. Take care. Congratulations, guys. Well done for getting this far in the course. We've had some wonderful shares already in this section, some brilliant animated lamps. Thank you very much for sharing if you have done. If you haven't, please do share what you're working on, because we love seeing how far you're progressing. And if we can lend a hand when you've shared, perhaps we spotted something, it's great to jump in and help you even further. So we've covered a lot. So remember to go ahead and just to go and apply it, either to perhaps the bowling ball and Skittles, animate them flying out, or even on a project you're currently working on. Now, speaking of projects you're currently working on, if you are working on something and you're allowed to share it and you want to share it with us, please do. We love seeing what you guys are creating in Blender. Far outside the scope of this course, it helps existing students realise the power and potential of Blender. Okay, so remember to help others as well. You're all becoming much more skilled with Blender now, and I'm afraid I'm only one person. I try and make sure that I'm there, but despite my best efforts, my body does not want to stay awake 24/7. So if you see someone that's perhaps struggling with coordinates or moving something about, something early on in the course, then do lend a hand. And thank you to anybody who's already doing this. It's great to see you supporting one another and building up a wonderful community. Okay, so finally, go straight on over to the next section, start it straight away, and hop on over into Blender. Welcome to setting up the camera. In this video, you will understand that the camera view is for our animation rendering as well as our normal rendering that we do. We're going to set up the camera, ready for the animation, and also animate the camera. So let's hop straight on over into Blender. Okay, so we have our animated lamp that's jumping about here, but of course the way that we're currently viewing it, the view that we've currently got, is nothing to do with the rendering. If we go over here and click Render Image, we'll see what actually is going on. Okay, so before we go any further, there's something really weird going on with this base here. This is not the view we want for our animation, but this is neither the base that we want here. So let's go and troubleshoot this really quickly. Now it looks like geometry is going over the top of one another, yet in the 3D view, when we render or set the viewport shading to rendered, we don't get that issue. So something that's turned on in rendered mode is not turned on in our view mode. I'm guessing, actually looking at the outline here, I'm guessing it's probably these two curves are still rendering. We can see here they've still got cameras on them. So the base curves that we had before, if we turn those two off and just render our image again, perfect, that artifact has gone. So it's a good point just to highlight here that before we go and animate anything and do 120 different renders, let's just make sure one of them comes out right first. And I'm happy with that, but I'm not happy with how it looks. So we need to move our camera. So let's hop straight back to the 3D view. Okay, and let's turn on some of the other lighting that's going to be going on here. So we're missing the plane at the back. So let's turn that plane on. Right, and hop around to where the camera is. So view, camera, or number pad 0. And this is what the camera can currently see. Well, not all that the camera can currently see. I'm going to need to zoom out a little. There you go. That's what the camera is currently seeing inside that border. Now that's not an inspiring view, and we want to move the camera around. And the camera is just like any other object. First of all, in the outliner, we need to check that it is actually visible in our scene. We can see that it is not. And if we try and select the camera and do anything with it, try and move it, well, we can move it up here in the transform pane, that's absolutely fine. But if we try and use G and move it without it being selected as visible, it won't do anything. So it depends which tools you want to use. We've got keyframing still turned on. Notice this is all gone yellow. Now we may in fact want to keyframe it anyway. So let's move it around to its starting position. So I'm definitely going to want to rotate it, not like that, around its own Z-axis, maybe about there. Now this plane that's emitting light for us is likely to end up being in the shot if we leave it like this, and we don't want that. If we go if we go render image, let's see as that comes out. Yes, that plane is going to be in our render. So we're going to have a problem there if we ever need our light source in the scene. Now there are a couple of options here, of course. We can hide it from the render, but of course then the light doesn't actually affect our scene as well, so we don't want to do that. The other thing we could do is make sure the camera never passes behind or rather in front of the plane itself, but that may be difficult. If you were doing almost like if you imagine a selfie where the light is always directly in front, lighting the object or the main part of the scene, then it's likely that that's going to actually be in the way at some point. There's a couple of ways we can sort that out. As I say, we can just avoid having our camera anywhere near that, but on the times when it's unavoidable, what we can do is actually go to the emissive plane, or planes if you've got more than one in your scene, and actually go to its object properties. And if we scroll down, so the object properties is this cube here, if we scroll all the way down under cycles settings, we can actually say ray visibility and whether or not it's visible in the camera. If we go ahead and turn that off and render the same scene again, so we just go and render image here, what we should find is that it is no longer there. Perfect. Yet it's still adding light to the scene. So if we turn that back on and hit render, we will see that it will render out the scene and we'll get that white line back in there. But if we do that, as we can see here, oh, have I turned off? I've turned off the lamp base instead of the plane. Silly me. But as you can see here, if we go ahead and turn off the plane in rendering, what will happen is all of that light will be missing from our scene, which is no good. The reason why we've put the light there is to light our scene. So let's turn that back on and quickly re-render, make sure it's all working. Excellent. And of course, on ray visibility under the object of the plane, so with the plane selected, object properties, scroll all the way down, ray visibility on the camera, we can turn that on and off. And in this case, we'll want to turn it off, so that it's not interrupting depending on where we put the camera. I think my camera's going to be much closer than this plane ever is, but just to make sure that it doesn't appear in shot, we can turn it off under the cycle settings. So I'm going to hop straight back round to the 3D view, and we're going to use these transform here just to adjust our view ever so slightly. I do actually want to be a bit closer to the lamp, so there's fine. I'm just going to grab the camera and move it there, and let's hop into non-rendered, just solid view, and just play our animation and see how that looks. Okay, that's looking good. We can see here that the animation is slipping back ever so slightly before we go. So let's just go to this part here, and then we don't want the camera following us, so we just need to shift it back slightly. So on that keyframe there, since I am going to animate this, I can just move it back ever so slightly like that. Let's see how that looks now as we shift through. Yeah, that's still in frame. And it's actually still in frame as it jumps at the top. So let's see if we can zoom in a little closer. So let's change the... what is it going to be? Z goes up and down, so I'm going to have to move it down slightly and then move it closer to the camera, and probably this way as well. Now I need to rotate it, so let's rotate it round a little this way. I don't need to do it that way, and I will have to look up slightly because I'm going to lower the camera down to here. Got to pull it back here, and there's lots of adjustments you can do here. There's no right or wrong for doing this. I'm just setting it up how I think it's going to look quite good on the final render, and that's going to go out of shot, but that's fine because we can adjust and keyframe in some new camera positions as we go forward, and obviously that's going to fly off the end of our scene there. Brilliant. So we've got the first stage, we've got the first keyframe all set up, we've got our starting position for the camera all set up. We just do a quick render again to make sure it's coming out how we want it to. Perfect. That's great. If this render here is taking a very long time, remember in the rendered options there are some settings that you'll need to do, and if I scroll down, 64 by 64, well, for a start I know that 16 by 16 is going to be slightly quicker. Now this is not going to be a fair test, we've got 2 minutes 26. If I render again like this, it's probably going to be very close. 2 minutes, okay, it's taken longer in that case. But it's too close to cool at those low levels anyway. So the other thing, of course, is scrolling up the samples here. We've got the render sample set to 10. Now, I suggest you do leave that down low at the moment. If you increase that massively and find there's a problem, like we had that base problem, if I hadn't rendered it there and missed that, again, being lean, make sure you render it quickly. Well, we're about to render 120, so 120 times 3 seconds is several minutes of waiting. However, if we set that render samples to 1 just for a test render and then hit this, we can see it's very grainy, but it's done very quickly. And if we go ahead and render out an animation like that, which I don't want you to do just yet because it's not going to come out how we want it, because we haven't set it up for exporting like that yet, we're just dealing with the camera, it will render very quickly anyway. And of course, once you've got the animation right, you can turn these rendering samples up as high as you like, is depending on how long you have to wait. The higher that is, the better the image quality is going to be until you get diminishing returns. But anyway, I've got a challenge for you guys. I would like you to set up and animate the camera. So set up the camera so our lamp is in view the entire time, animate the camera to keep our lamp in view as it's jumping about, and then have fun. Try different angles, see what you come up with. I'd love to see your animations as well, but we're not quite ready to export the animations. Hold on and we'll deal with that in the next lecture, but for now, pause the video now and set up and animate that camera. Okay guys, welcome back. Let's hop back on over into Blender. Okay, so I need to hop straight on to my 3D view once more. Now that we're here, the camera needs to really be rotated upwards so we can see it. Now, at the lamp's highest point, which is around there, I'm going to move the camera up. Oh, actually, I'm going to look up. So I'm going to move the camera along so it's kind of following. And let's see, if I rotate, I think it's X. Yeah, to look up. And I can even move the camera in ever so slightly. Brilliant. So let's just see how that looks. So the camera should follow us here. Now the base goes slightly out of shot, but am I happy with that? Yep, that's fine. And as it goes down to land, obviously it's nowhere near our lamp. And I would like to be looking back. I've decided I want to look back on our lamp. So before it lands, so I can see it lands about there. Before it lands, I want the camera already in position. So it's going to be around here that the camera needs to be there. So I need to rotate it round to look down our scene. And this is the X coordinate, I believe. So let's pull it out. Let's move this in. And the camera down. So let's see how that looks as it swings round. Because the other thing we need to bear in mind is if we're animating the camera, does it make sense? So let's look there, and then the camera's being pulled round. Now I'd actually like it to be looking down on the scene at this point. Part of the point of having this lamp is that it's shining a light on the floor. So at this point here, we come to here. I want it to be looking down. So let's rotate the camera. Let's pull it down here and then lift it back up. So how does that feel as we pan across? Go across here. And then we go out for a wider shot. Perfect. So the final thing that I would do here is I would just pull this camera perhaps a little bit further down, even rotate it round, rotate just a little bit more. Oh, that's a bit too much, because I want to see the spot that this is doing. So let's just run through that from here, comes around and pans out. Perfect. Excellent. How did you guys get on? And shortly you'll be able to share your animations with the rest of us. Take care. See you in the next lecture.